transformer. That's already efficient. We just get rid of all the one-by-one steps. But unfortunately, we lose position of the word. When you pass one word at a time, you could say first word, second word, third word, fourth word. If you pass everything, you can't do that, right? So what transformers brought to the conversation was positional encoding, where you can have the embeddings of the words at the concept of where they actually need to be, and that becomes a position-aware encoding, for example. Something simple, just get the word, get the numerical value of the word, understand the semantics of the word, understand where it's positioned, and that's what we call position-aware encoding. Something that I did not know what that even was, and maybe there is, of course, more context to this, but I don't want to have a headache going through all these things. Self-attention, just the basic concept of attention is that when you have a sequence of words, you can actually understand how one word can be related to the rest and how strong their relationship is with certain words. That's the concept. And transformers actually do that on their own. This is another example where when you translate English to French, which, by the way, don't ask me to say the French word here because I'm not that good at it, but you can see how in the two English sentences, the word it in the first one meant animal or refers to the animal, and the second one refers to the street, if I'm not mistaken. Yeah. Yep. So you can see how this model allows us to understand the relationship with other words, and without needing to have all this one by one, processing and large amount of memory, it actually could understand this. So transformers now are becoming a thing, not just for text. It was built once again for translation, but now the architecture and the concepts are being used by more than just text. So it's becoming this cross-modal general architecture. So when it comes to text, we can talk about large language models now. In a large language model is a neural network that, for example, could use a transformer architecture, process large amounts of data, and be able to produce parameters. And those parameters are the ones that would help us then to understand, for example, statistical relationships in a language, and this would be at scale, right, with a lot of information. So one interesting part in here that we're missing is, wait a minute, but so far you're talking about training something, but you were talking about that you need to somehow know the actual target value, so when you predict something, you can tell it where it was wrong. When we talk about large amount of data, you cannot just do that because you cannot label every single thing that is out there in the internet, right? So there's this concept of self-supervised learning that allows the model to actually learn based on the information that it's processing as an input, but at the same time, it's actually, for example, trying to predict a word after a sentence. It's trying to mask a few words, and that's how it starts learning on its own, for example. So now, when we talk about training, pre-training, it's very important to understand as well. You can have a model that would go through a lot of data, a lot of money, a lot of computation, so many days, months, and you will get, from a large language model perspective, you will get a pre-trained model. Something that is just there, has a lot of knowledge of the language, but you will have to actually tweak it, fine-tune it, in order to be a specific, to be useful for a specific or a special action, for example. You can still use it for certain things that I'm going to show you in a little bit, but if you want to be very specialized and maybe reduce the amount of errors that this base model, pre-trained model now can have, you have to fine-tune it. And that's what we mean with pre-train and fine-tune. So think about this for a second. Base large language models, like, for example, GPT-3 and 3.5, when you tell it to predict the next word, it would do it for you. But if you actually ask it something directly, it will get a little confused. It will be like, wait, you're asking me for similar questions? I can do that. I can just provide similar. You will have to fine-tune that in order to be able to hold that type of conversation. So there is a concept of instruction-tuned LLM, or large language model, that it's a pre-trained model that you can actually fine-tune in order to interact with you as if it was actually a conversation and understanding instructions, right? So GPT models, now that we understand some of this, are a generative pre-trained transformer model. So I hope that that's clear now, what GPT is. So rather than telling you what it is in the first slide, I hope that the explanation kind of helped a little bit. And the concept here is that this model was trained to predict the next word, went through processing a lot amount of data, and then the interesting part in here, of course, is transformer-based, but it's the concepts in here now, I hope that they make more sense. It's 175 billion parameters, 96 hidden layers, so layers of neurons, and it was trained on apparently 500 billion words or tokens is what I was also reading. This type of model is what we also call a foundation model, because it's a model that now you can use, you can adapt that model, and you can perform other tasks, or you can fine-tune it, as I mentioned before. And the concept of foundation or general models means that before we had all this knowledge about language, there were specific models that were being created for one specific task. You would collect labeled data, not large amount of data, but you will collect enough data, you will build a model, you will try to solve the problem. Let's solve phishing, let's solve ransomware. So you build specific models for each specific task. A foundation model, because it has this knowledge, foundation knowledge, it could actually be super useful to then be able to be fine-tuned with some small amount of data, as I showed you before, and then be able to even achieve better results than a regular task model. If it doesn't make sense, let's talk about my dog Stevie. So Stevie, using Midjourney, now it becomes that cartoon. So think about Stevie. My dog is a foundation model because my dog actually knows, it could be adapted. It has enough knowledge as a dog of the things that it could do. Sit, come, stay, right? All the stuff. But if I want it to be a special, specific task, I need to fine-tune Stevie. And if I want it to be a rescue dog, it's not as easy as say, come, sit, right? Stay, right? It has to go through a really, more than just trying to say a word and then expect the dog to do something, right? So that's the concept of foundation models. That's how you can talk about it if somebody wants this to be explained in other terms. Now, these models, as I mentioned before, because they do have enough foundational knowledge, you can adapt them to do things such as tell me, based on your knowledge, a poem, write something for me. You can adapt it without fine-tune it, and that is changing the way how we think about traditional ML. Now it has turned into prompt-based ML. A prompt is something that you ask a query that you run against the model in order to perform a task, right? So that's pretty interesting, how we went from the typical to now, if you're a prompt engineer, that's going to be a thing soon, a job about prompt engineering. And out-of-the-box capabilities of these type of models, you have to understand that exists the understanding of language and the generation of something, text. Because that's how you can start categorizing what use cases you can actually use it for. On the top, you're talking about understanding code, for example, understanding command lines, and you just want it to tell you exactly what's going on. Sentiment analysis, what I showed before, a phishing email. You can use these models to provide that type of task. On the bottom, the generation piece, you start talking about text summarization, a bunch of incidents, summarize that, maybe summarize it with this other incident stack, and tell me what's going on right away, right? This also helps to dialogue systems as well, right? Because you can start going back and forth and create some type of conversations. Text generation, because you can tell it to write things for you, and text translation also. And this applies not only to English, to French, that type of translation. You can actually have language to code, for example, like SQL queries, etc., right? So now that we went through all of this is all the foundations of what the basics of these models are, starting from neural networks. We now know about GPT, some of the basics of GPT as well, some of the capabilities. So what can we do with something like this? So my goal is to share some of the experiments that I did to be able to inspire you, hopefully, so you can do your own. And the idea here, we can just jump directly to the code, so that way, okay. I put together this Jupyter book, which I'm going to be releasing today. This is not complete. This is just the first iteration. And in here, what we're trying to do is show you that the first step, and hopefully you guys can see it. Yes? Is that good? Okay. Maybe I can do one more. Maybe that. All right. So the first thing we need to do is import our libraries to start interacting with some of the companies like OpenAI that allows you to use their GPT models via an API, right? You can also use other models as well, but let's just do OpenAI for now. You need to define your OpenAI key, like set it. I usually set it as an environment part of a .env file, and then I just use the .env in order to load those environment variables, and then I set it to a variable, so that way I don't disclose my key while I'm talking to you guys, right? So the next step is to create a function that would allow us to interact with this API. And the first thing we need to do is define the model. So now we know that we're dealing with GPT models. GPT 3.5 Turbo is the model before GPT-4. 4 is the current one used by some applications, as this chatbot that exists out there. But 3.5 is the one where we actually have enough documentation. Now, so we define the model. We also want to pass messages to this call, and then we have the temperature. Temperature tells, you can tell the model how creative, how much randomness you would like to add to the responses. If you set it to 5, 6, 7, that might start hallucinating a little bit more for you. So the first concept would be simple, something very simple. Let's start interacting with this. Let's create a prompt and say, classify the email subject text below. You have to, the key in prompting is you have to be very specific, right? So I want it to be between those 3 single quotes, and I just give it a name. Right away, this one goes and says, this is benign. It's just an email subject. Text appears to be a legitimate request, whatever. But now what we can do is implement concepts such as few-shot learning, which is how you adapt the model a little bit to be able to respond in a certain way. So in this case, what I'm saying is, I'm going to give you a few examples. So few-shot learning will just provide context before it tries to ask the question. So I'm giving it some subjects, and that's misspelled, by the way. And then I give it a label, and I say, look, if you see this is malicious. If you see something like this, it's benign. If I run this again, it tells me, oh yeah, that's malicious, by the way. The same subject, right? The same email subject as the one before. This basic exercise, that's the concept of be able to adapt the model to do something else that probably it couldn't do before. And if you start interacting with this, of course, this is a basic example, but just imagine this at scale. You can build an email classifier, right, with a foundation model like an LLM. The next one is going to be summarizing. So let me just make this bigger. Same concept, import libraries, get the key, get my function to interact with OpenAI, and then I give it another prompt. So in this prompt, I'm saying, hey, and this is also, let me make sure that we can, yep. There you go, that's much better. We can actually play a little bit with the prompts. We can actually have the text that we would like the model to actually process, right, to tell me something about. And then I can create an initial prompt where I can actually tell it, your task is to do this. You today are going to be a cybersecurity professional specialized in reverse engineering, for example. So you can actually provide some of that context, and because the model has this foundational knowledge of language, it will be able to provide some of that context in the responses as well. So in here, we pass the evidence, and then it's going to tell us, oh, the actor is disabling Windows Defender, is deleting files, is doing all this stuff. It's missing a few things in there, but that's okay, just for the example. But you can see how powerful it could be for security analysts that don't have much of that probably knowledge because they're juniors, right? Probably they are coming from a different background, different field, so it would be super helpful, right? And the last thing that I want to talk about, and hopefully we still have enough time in there, is this last experiment that was super cool that I just was thinking, what else can I do with this, right? What else can I do with this LLM can I maybe start asking questions about my own data? Because the model will respond up to the date where it was trained. All the knowledge, all the things that it knows is up to when it finished training. Whatever happens after that, it won't be able to answer. We can actually ask, hey, how is NorthSec 2023? And it would be like, I don't know, I finished training in 2021, so I don't know what happened in the past 2 years. That's exactly what you will get. So in this scenario, we're going to use the concept of retrieval augmentation, where you can actually provide also your data and now be able to ask questions based on that data. And that's also how you can adapt the model a little bit to be able to interact with knowledge that doesn't exist anywhere else. Now, granted, this example is using APIs, so some of the data is going out, but this is just an example, right? And in here, the interesting piece, as I mentioned before, is that the world exists at a static snapshot. And then the idea behind is actually to be able to ask a question, and maybe this next image will make more sense. But you ask a question, you start understanding how similar your question is to the knowledge that you have in a vectorized database, and then you can pass that context to the model. So what does that mean? So what I did is I wanted to replicate what it would be in a threat intel team, in a company that has intel, and then it has all this knowledge about threat actors that you cannot share with anybody else because it's your intel. Maybe you want to share some, yes, with other partners, but there is some knowledge that you cannot share, right? So I was thinking, you know what? What public knowledge has some of that context in the world? MITRE ATT&CK groups does have the type of information where they collect information about groups, public information, and they map all this knowledge to all the groups. So there you are. That's my Intel database for my POC. So why not do that? So what I did is I have this Python library that I wrote. It's a GitHub project that allows me to query data from MITRE ATT&CK in a sticks format. MITRE ATT&CK does have a database. It's a taxi server database where you can just get the data. So I wrote some code with this library. I create documents. I tokenize my data. I hope that tokenize now makes sense, right? And then I create the embeddings. I hope that also makes sense again, right? Of every single document. So we tokenize embeddings, and then I put it into a database that understands numerical values that will represent a document and the semantics of the document, right? So now when I run my query and I say, hey, I would like to know more about these threat actors that exist in MITRE ATT&CK, but if I go to the MITRE ATT&CK search capability through the website, all I can do is keyword-based search, right? All you can do is type phishing, process injection, discovery, and then it tries to find the documents. But what if I want to ask, what are the top phishing techniques, or what are the most common phishing techniques in your whole database? The whole website goes down, right? Because it doesn't understand that type of conversation. So we start with our query. Our query is going to be embedded. That embedding is going to be compared with whatever we have in the database, so it knows what's similar, my query and the documents, and it brings me the top 5, top 10 documents. Then I can just have that and pass it to the LLM and say, here is my context. I would like to know what are the most common techniques that are used in the world, right? Something like that. So let's do that. And that's the last example. So just making sure I want to go over that. Sorry. By accident, I clicked other buttons. All right. And then let's get rid of this. All right. So this is going to walk through the whole thing. And once again, the code is going to be, there you go. So we import our attack Python client library. We define some variables. We initialize the attack client. I wrote a give me all the groups function, right? Give me all the groups. That's pretty much what it does. And then I start getting information about all the groups that exist at MITRE ATT&CK and some of the information such as techniques, etc., of MITRE ATT&CK. Then I create the way how I want to structure my documents, because the way how I was before, it just has information that I don't want. I just want to have specific things in there. So that's what it does. It just allows me to pick what it is that I want my documents to be like. And I'll go down. So I start processing, creating markdown files for every single threat actor. And that's what you see in companies that are tracking Intel. You have a threat actor, you have a summary of the threat actor, and you have connections, of course, to evidence and things like that. But the primary overview of the threat actor is super important, right? So we go through all this, and now we use a tool called LangChain. Super useful. If you want to dive into these examples, it simplifies a lot of these things. It has a lot of wrappers around some of these APIs that I was showing you before. And then we start capturing information from all these documents with LangChain. And then we start actually loading every single group into its token representations to understand how many tokens we have. So pretty much this is telling me that there are documents that do have 176 tokens. There are documents that have over 7,000 tokens in the document. When you interact with these models, there is also a limit of how many tokens you can pass when you interact with that model. That's what I do, this right here. So in order to avoid these large tokens per document, we start splitting the documents. And this is also an art. I didn't know. Splitting a document, it's an art when you try to pass it to an LLM. Why is that? And maybe I could show you here. Yeah. You can actually split documents in chunks of 500, for example, let's say tokens. And then the overlap is 50. What does that mean? That if I have a document that ends on threat actor X, and then the other one starts with something else not related to that threat actor, especially when you have long documents of intel of a threat actor, sometimes you don't keep the threat actor names all the way at the bottom. So maybe the information at the bottom might not be pointing to the top, and it's important to have some of that context in every single chunk. So the first thing you can do is say, I'm going to take the first chunk, overlap that chunk, and try to capture maybe some of that information, so that way I start making my chunks more similar. Another technique is in every single chunk, you just put the name of the threat actor. And now you have context of one chunk associated to the threat actor. So that's another technique that you can do, right? So once we do that, we're going to just splitting all the data, and then I'm going to export it as a .jsonl file. And why is that? It's because if you truly want to collaborate with people, if you really want to share your information, like something like this, what I did is I created this document that what it does, it gives you the ID of the chunks. It tells you that this chunk is 0 in 0, 1, like 1, 2. So 0, 1, index 0, index 1. Those two chunks belong to one document. And then I provide the text, how the text was split. So now that I'm talking to data scientists, they want to know how I prepare my data. Now I could tell them this is exactly how I would do it, and maybe you can use it on your own. And that's better because some of them don't understand some of this information, but our role as a security researcher is to be able to share our knowledge. And that's what this presentation was about, right? To be able to take some of this knowledge that they know and how we're going to start using it to start even parsing what we know so they can use it, right? So this whole document has that splitting, how many chunks, some chunks all the way to even 7 chunks, for example, etc. Okay. So then we, almost done in there, yeah. And then we create a database with all these chunks, right? I want to skip that one over there. What I do there, I just simply save all that in a pickle file for those that do Python programming, or I just saved all that information. Now I can start querying this knowledge. Right? So I do the same thing as before, import my variables, set my key, and now I set my database as a retriever object. So it would allow me to retrieve information from there. And then I just pass one query. My query is, what are some of the phishing techniques used by threat actors? When I pass this through the retriever, it's going to give me documents that are related to my question now. So now I can enable question and answering also with this information. So now I take all these documents that I received, And then I passed that as context, and then I asked the same question. And the response was, threat actors have used spear phishing emails with malicious attachments, links to HTML application files embedded with, and you get the idea, right? So it was able to generate content, new text, right? Generate text that now allows me to simplify the way how I interact with my Intel database, for example. So if you're an Intel analyst, you might want to do that, right? Just to get some more insights that you might miss because you cannot read thousands of documents, split it in chunks, and then ask questions, right? We can't do that, right? So this is what this is about, and you can apply this idea to anything, any type of knowledge in the security realm. There's a lot of stuff that I'm super excited to dive into the next couple of weeks. So that, at the end, by the way, I took my JSON file, and now I contributed it to the Hugging Face hub. So now that it's a file that people can use, download, directly interact with it. So that's my contribution to the community of the AI community. And that's all we have. This is the link for the GitHub repo, which, by the way, I just want to make sure that it is private. No, yeah, so hopefully it lets me do that. And, okay, real quick, sorry. Oh my God, see, that's the inconvenience. And just making it, let's see. And of course, I need to disconnect this, right? So otherwise, all right, I'll do it when I'm done. But what a way to finish the keynote with a contribution to the community and share some of these concepts so that you can take them back, experiment, inspire yourself, and just share your knowledge. This GitHub repo is to do that, is to share some of these experiments, and then you can take them and then make them your own repos and all that. Thank you very much for your time, and hope it was useful. Thank you. Hey, thank you, brother. Oh.
reduce the number of false negatives while not blowing up false positives. That's like
Yeah, basically. And I'm looking forward to the Q&A. It's going to feel like... Oh.
all right. Hello, hello. Good. So we took a shorter break. We're already a little bit behind schedule, as with every good conference. So for our next block, we have the detection block. Our moderator is Jared Atkinson. He's a security researcher who specializes in digital forensics and incident response. He previously led incident response missions for the U.S. Air Force UNTEAM, detecting and removing advanced persistent threats. He also loves open source and is a lead dev of Power Forensics and Uproot while blogging about detection engineering. So please welcome Jared Atkinson.
Perfect. All righty. Thanks, everybody. Who here's detection engineers, blue teamers? I assume most people, right? That's why you're interested in the detection block. The next talk that we have is going to be a talk that's really quite interesting. One of the biggest problems that we have in detection engineering is this dichotomy of false positives versus false negatives, right? So we have this issue to where there's two types of error that we have to deal with, right? So what we don't want to do is we don't want to detect benign things and report them as malicious and then, destroy our networks as a result of that, waste resources. But we also want to make sure that we're not missing malicious things. And the problem is that those two things are inversely related, right? So as we reduce the number of false negatives that we're going to encounter, right, we're going to start to really deal with trying to find things, cast a wider net. We end up creating a bunch more alerts, and we have this problem with alert fatigue and things like that. And so our next presentation is going to really get into that. And our speakers are Emilio Gonzalez, who works in a blue team in a large Canadian organization. He loves to participate in CTFs and create challenges to introduce people to some defensive aspects of cybersecurity. And he's a co-organizer for Mantra Hack, a monthly CTF workshop in Montreal. And then I told Remy that I'm probably going to mess up his name a little bit because it's very French. But we have Remy Langevin. Was that right? Okay, cool. And Remy's been working in a blue team for a few years as a threat hunter and developer. In addition to threat hunting, they both like to talk about indenting their code. So apparently they're zealots. Are you tab or two-space? Tab? Okay, so... Uh-oh. Now... That was something we should have saved for after the talk, because now you have an uphill battle going against everybody. But welcome Remy and Emilio to the stage, and we'll go ahead and take it away, guys.
Test, yeah. Hi everyone, it's good to be here. So today we're gonna talk about detection engineering, alert fatigue, and dealing with security operations centers' limited resources, and how we try to overcome that. My name is Emilio, but I've already been presented, so let's skip that part. And same goes for Remy. So for the presentation, we're gonna talk about our context and the problems we were trying to solve. Indicators, what they are, why they're cool, and when not to use them. We're then gonna show our implementation of a platform that leverages the concept of indicators, which we call Yamaha. We're gonna suggest a free and open implementation for people who want to try the concept without having to pay. And we're gonna close with takeaways and the future of Yamaha. So, context and problems. About our organization, we're a fairly big organization with about 50,000 employees, which means we manage lots of endpoints, both workstations and servers, more than 70,000. For the workstations, it's mostly Windows with a small amount of Mac and Linux. For the servers, we have both cloud and on-premises infrastructure with a good mix of Windows servers and Unix servers. We have an EDR installed on the vast majority of machines and a TLS inspecting corporate proxy that sends logs directly to the SIM, which means we have lots of telemetry to build detections on. For the SOC, we're a fairly big SOC with more than 20 SOC analysts slash threat hunters slash detection engineers. And we have a very heterogeneous network that carries decades of IT work at a time where security wasn't a main concern. And this is kind of important when doing detection engineering to be aware of that. So let's say you wake up today, you say, I want to build a good detection. So what are the characteristics that detection should have? First, you want no false negative. So you want to detect all malicious behavior you want to detect, but you also want no false positive. So you never want to detect illegitimate behavior. You want the detection to have a small time footprint, which means you don't want to exceed the SOC's capacity to respond to all of the alerts of that detection, which either means not many alerts, or the alerts can be investigated quite fast, or in the best world, both. You want the detection to be fully actionable, which means an analyst will know what to do to investigate and respond to that alert and can actually do it. And finally, you want the detection to be maintainable, so not bloated with exclusions and overly complex logics. So when you look at the detection, it's clear what it does. So you guessed it, a good detection is more like a perfect detection. You're never gonna get a perfect detection, but you want to approach these characteristics. Small word about alert fatigue, because this is really important. Alert fatigue is a phenomenon that occurs when cybersecurity professionals become desensitized after dealing with an overwhelming number of alerts. So they start to overlook or ignore them and have slower response times. So if you work in a SOC, this is really important to understand. And if you haven't worked as an analyst dealing with a large number of alerts, which all look the same and are all false positives, it might not be obvious that this is something real, but it is, believe me. And if you build detections and you don't take into account alert fatigue, you might have a false sense of coverage or security because you said, well, my detection is built, it detects the stuff. But if you don't consider that analysts have alert fatigue or can have alert fatigue, you might believe that if something malicious happens, it's going to get detected. Whereas if the detection is like 99.99% false positives, analysts perhaps will take mental shortcuts and ignore stuff that's actually malicious. So usually, we want to address that. And one of the main ways to address alert fatigue is reducing the number of false positives. So how can we handle false positives in a SOC? The most obvious answer is add exclusions to your detection. And this is usually good. It lowers the amount of false positives, but the more exclusions you add, the higher the chance that you're going to miss something that's actually malicious. So meaning increasing the number of false negatives. So you need to be careful. You can have a triage tier, and not everybody uses the term triage the same way, but for this presentation, triage means having either analysts or automations that look at alerts and close quickly obvious false positives. And this is usually good to do, but we need to be careful because it actually increases the likelihood of alert fatigue for the analysts that look at the alert first. You can hire more analysts, but this costs lots of money, doesn't address alert fatigue, and in a talent and labor shortage, it's harder than ever to do. You can automate contextualization and response with a SOAR, and that helps greatly, but it requires a lot of time to do correctly and resources, and it's not a silver bullet. Some stuff is still going to have to be done by humans, and it's okay like that. And perhaps the most common is not using the detection. For detection engineers out there, probably happened at least once. You looked at the technique, you said, well, this is so easy to detect. I'm going to build a detection looking at process creations with that filter. You build a detection, you say, I love this detection, it's going to fit so well in our environment. You put it to prod, you wait a day, and what happens? It triggers 300 times that day. And you're like, that's too much for my SOC of 3 people to handle. I'm going to add exclusions. And you add exclusions, and then it triggers, it's better, it triggers 30 times every day, which is still too much. So what do you end up doing? You take the detection, you cry a bit, and you throw it in the garbage, which keeps your blind spots, which means infinite false negatives. But What if there was a way of keeping that detection instead of throwing it in the garbage?
So yeah, we decided to turn to indicators. And what are the indicators? What do we mean by indicator? It's the output of a detection logic, of a rule or content match, whatever you want to call it, but it's mainly the output. The main output, you know, is probably the alert. So there's a SOC analyst that will investigate the output of this detection logic, but we added one that is an indicator. So what is an indicator? And what do we do with them? So, the feedback. All right. So yeah, what do we do with them? We correlate them to trigger incidents. So let's say you have a phishing attempt, like an indicator for a phishing attempt, but it's not precise enough to get an alert for it. And then you have the same thing for persistence afterward and something else. And then you might just tag them and build an alert for the whole incident. You might also use them for additional context. So let's say you have a ticket to investigate. You want to see for a host what else has happened on the same host during the same time period. Well, you can just use what has already triggered as an indicator on the same host. You can also use them as threat hunting leads. So if you just put them like in some UI or some data store, and your threat hunters want to just like browse them and find malicious stuff, well, that's a good one. And also, you can use an entity model to score the entities to just like help the threat hunting prioritize their leads, or use them for triggering alerts with high scores. And you can do that for machines, users, domains, and especially cats, because they're kind of malicious or at least suspicious. So yeah, what are the benefits of using them? Well, when we don't have one detection equals one alert, we may bypass some of the negative side effects of the false positives. So what does that mean? We can do like detection logics that we would have just thrown away, like Emilio said, or otherwise, it would have done some alert fatigue for the SOC analyst. So we can implement them. They are less precise, but it's fine because they are not actioned on for like in a one-to-one manner. It also enables us to detect suspicious stuff, but not really abnormal. So let's say you have a net users. Your sysadmins do that. Maybe your developers or somebody that knows a bit of command line might do that, but it's not malicious. But you want maybe to get an indicator for this. For if there's an incident, you might just use that as to help you contextualize. And they often stack together to build some incident or a story that helps you investigate or trigger alerts. But can you put anything in these? No. Garbage in, garbage out, as they say. They should be meaningful. They should be in tune. Also, if you have like a lot of false positive, you should do your exclusion and everything. Like something that triggers 10,000 times a day might be fine for informational indicator, just like there's no scoring, it's only there for contextualization, but maybe not for high severity because you don't want to score on on a lot of noise. And they should be an indicator of attacks. So let's say you have a process making a lot of DNS queries. Maybe Chrome is not a good process for that because it's basically the main thing that Chrome does is DNS request. Okay, so maybe you're thinking these are cool. I want to implement indicators, but there is basic stuff to do before that. Well, you need a good budget, like anything in security. You need security-minded developers to leverage these indicators, build platform around it, and make this valuable. You have basic stuff like proper assets and software management. The SIM, EDR, firewalls, anything that the log source, basically, because you need them to build detection logics. If you don't have this, you won't build detection logic at all. And they have built-in the detections if you don't have people to work on the detection logic team. So this is the basic. Then you want people to just investigate those alerts. if there are alerts and nobody's there to answer them, that's not good. And afterward, the detection logic team and the most critical detection before indicators, because indicators are just there to circumvent the blind spot you have with the critical detections. And also a threat hunting team maybe that can just leverage other, to get more leverage on these indicators. So let's go to the implementation. What did we do? So there's 4 blocks. There are the log sources, the enrichment sources, the analytic platform, which is Databricks, and the outputs. So first, in the log source, you want a SIM. There are probably already some detection logic implemented there. You can put some simple indicators there and forward them to the analytic platform. The other log management tool, the EDR, firewalls, everything. You can maybe pull directly the data from your analytic platform. There's also, There's also the enrichment sources like Aristotle for domains, binaries, just to get context for something known. Top 1 million domains, GeoIP, etc. And then there's in the analytic platform, there's the hunting data, which is like what are the binaries we have seen, when were they first seen, on how many hosts, same for users, binary domains, etc. And then all of this goes into the notebook magic, where the scoring and the indicator logic happens, and we output this in a data store. And from there, we have 3 types of outputs. We can open directly a ticket into the ticketing system to get an investigation. The SOAR can pull the data and contextualize investigation automatically. Or there is the Power BI for manual user queries that want to explore the data. So yeah, in the notebook magic, we explored 3 main scoring algorithms. One we call TF-IDF, which is a frequency analysis, basically. So if there are many entities that trigger the same indicator, you get less information from the indicator, so the score is just like lessened. And yeah, if it scores on like a small subset of machine, then the score just gets boosted. There are the indicator severity that we might just like security knowledge. If we say this is a critical, we give it 1,000 point, and then a high, we give it 100 point, and so on. This is like the simplest score. And then the inertia analysis, it's more like a baseline. If a host or an entity gets like a score, it's stable for a week, and then get a spike in score, then we can just boost its score with using like the delta.
So yeah, so time for a demo. So let's see. One level. All right, so it looks like this for an analyst, and this is the main page. So this is mostly for threat hunting. So it's a Power BI report with many pages, a Power BI application, I think it's called. So as you can see, there's a slider here to determine the date range you want to examine, and the data gets updated quite fast. So we can see here the indicators that have triggered their severity, so critical, high, medium, low, and informational. And here you have, for a given date and a given computer, a score. So the score Remy talked about 1 minute ago. You can filter easily, so if you click, it's going to filter for that specific computer day. And you can see which indicator triggered for that machine. So you can go into the details here, for example, the command line. Power BI has a feature that's called a drill through, which is pretty interesting to go to another report by passing arguments. So we can have here a better view of the given day for the given computer. And you can see the indicators that I've triggered with a bit more space, so it's easier to threat hunt. And this might be a bit confusing. This is anonymized data, and the indicator name are taken from the Sigma repository on GitHub. You can also drill through to show all the detections for that computer. So it's interesting because you have this now, and the slider to determine the date. And you can see how many indicators have triggered for that specific machine every day. So you can see spikes and potentially suspicious activity. And you can filter in the same way that Power BI allows. And you can see what triggered and when. But it's not only for threat hunting. As we said, we can use them to pivot from ongoing investigation. So let's say there's an EDR alert that gets triggered. The analyst that looks at the alert, they want to see what kind of indicators have triggered. So we have a page for that where you can input a machine and see basically the same stuff that we've seen while threat hunting. So you can see which indicators have triggered, and this might be helpful to pivot during an investigation. And we actually have a success story with this. We had a server that had a web application that was compromised, and during the investigation, an EDR alert triggered. And by going into Yamaha, we had a small but noisy indicator, which was a rare domain was accessed on a small amount of machines. And by looking at the domains and pivoting further, we were able to confirm that this machine was indeed compromised, and Yamaha was a key part in that. Returning to threat hunting, as we've said, we have multiple scoring algorithms, so we have multiple views for them. So this one is the TF-IDF. So as Remy said, the more an indicator triggers, the less the score, and the more rare the indicator, the higher the score. So if you notice, those are different machines. They're scored by score, TF-IDF. So different algorithms are going to give different machines. So for threat hunting, having multiple views is really great for all hunting activities. We've talked about scoring machines, but we're not required to look by machines. So we have a page here looking for domains. So indicators can be triggered for domains. And if we look here, we can filter for a specific domain, that weird domain.windows.net. We can see that 3 file names triggered that indicators for that specific domain. So this is EDR telemetry. So we look at DNS requests and we map it to the process creation to see what's the file name and what's the command line. So again, very helpful to threat hunt. We can also filter by MITRE ATT&CK tactics. So when we build our indicators, we associate them with MITRE tactics. So if we, for example, want to do threat hunting for only defense evasion, well, we can filter that, and it's very fast with Power BI. We can filter only for specific tactics. And finally, that page, which is not for investigation nor for threat hunting, it's for the detection engineers. So you can look at indicators that have triggered. So you can see how many indicators have triggered every day. And you can see for how many computers, for example, a given indicator has triggered. So we can see here the node process execution indicator. It has triggered for 48,000 computers, and it's a medium severity indicator. So perhaps we should add exclusions or lower the severity for that indicator because it triggers way too much, and we can filter. And as we can see, we can look at how many indicators have been triggered each day. So for example, 12,000 here, and then it drops to 392 a day. So actually, we added an exclusion to that indicator using that page because we saw that it was way, way too noisy. So back to regularly scheduled programming.
All right, so if you want to try this at home or just like not spend a huge budget on this, we just list for you some open and free alternatives. Yeah. So for the job orchestration, you need something to coordinate the execution of the notebooks to tell which one is first, and then like there are dependencies and when should they run. We use Data Factory. Apache Airflow is more than capable of this. Yeah. So when the notebooks run in Databricks, and Jupyter Notebook is pretty much the same in the free and open world. But it doesn't have a managed data store, neither it has managed clusters. You have to do this on your own in Jupyter. For the data store, we use Delta tables. It is also free and open. I just didn't put it in there. But you can use like a PostgreSQL or a file system, whatever you want, that the analytic engine can parse, which, for instance, is Apache Spark, and it is also free and open. So yeah, and for the presentation UI, we use Power BI as you saw, but I don't think there's anything that matches Power BI in the free and open world. So you might just use Jupyter Notebooks with IPython widgets and some graphing libraries, or Kibana from the Elastic Stack. Yeah, and you need data source, so we use a SIM and a EDR. But in the Elastic Stack, you have also Elasticsearch and Elastic Defend that is built in, and maybe Sysmon or OddsetD for Linux. And you should be able to get going and do some of this stuff. What are the takeaways and the future of it? Well, they are cool. It's pretty nice. We use them every day. You need a good tactic and environment coverage, like anything, but especially a good tactic coverage if you want to build up incident from different step of the kill chain or something like that. You need to don't just focus on the execution or defense evasion. You need to get all the tactic of the malware attack. It does not replace alerts. It's just for the blind spot you have with alerts that you cannot just trigger every time an alert. You use indicator instead, but you should fall back. It's only a fallback. You need a good maintenance, like Emilio just showed you. If you don't do this, maybe Node is going crazy, and then you will have 40,000 indicators per day, and that's not good. So you have to tune them. Your environment is changing. Your data sources are changing. So yep. And many views, many scoring, because some scoring or just don't show up, some small noisy attackers or threat actor. So you need another way to just make them pop up. The next steps, we want automated alerting based on a sudden increase in score. Let's say a host is behaving abnormally and it has a spike and suspiciousness. We want to open an alert from this. We would want also an analyst feedback loop. So if there's an indicator that is not quite good enough and the analyst just say yes or no, this is good, this is not, it labels data. It helps us tune the indicators, but also we might just use that for automated tuning or suggestion for exclusions, and that would be great. Better indicators and coverage, just like any detection logic stuff. And something exploring new scoring algorithm, like something ML or machine learning. And I hope this has inspired you for your detection logics. So thank you.
Thanks.
Bon. Wow. I'm on.
Testing, testing. There we go. Okay. That was a great talk by Emilio and Remy. That's a really cool project. I'm really interested. After Olaf's talk, we're going to have a little panel discussion, and I want to try to dig into some of the questions that I had during the presentation. Things like how are they developing the scoring, certain topics like that. Our next speaker is Olaf Hartong, all the way from the Netherlands. He's a security researcher at Falcon Force and a Microsoft Security MVP. He specializes in understanding the attacker tradecraft and thereby improving detection capabilities. He has a varied background in blue and purple team operations, network engineering, and security transformation projects. One of the things, so Olaf's going to be talking about how they manage detection pipelines at Falcon Force. And I think one of the really cool things that's about what they're doing is they're professionalizing kind of detection engineering. So one of the big problems, I'm a consultant in my day job, and one of the problems that we run into, especially with threat hunting, who here does threat hunting or interacts with threat hunters? One of the big problems, my original background in the Air Force was I was on the Air Force hunt team. And so I'm kind of been around that for 15 years or something. And the thing that we run into is there's a lot of ad hoc nature in threat hunting. And there's often a lot of tension between the SOC and threat hunters. And the problem comes in that the SOC is responsible for security all the time, and threat hunters get to kind of take this, smaller scope problem and be more focused, right? And one of the big issues that, from my experience, that causes that tension is this issue where they're not feeding their output back into the steady state, right? And so one of the things that Olaf's going to be talking about is how do you manage the steady state? How do you make sure that things are working? How do you make sure that everything that you've deployed is operating as expected? And so I'll let you take it away from there, buddy.
Thanks, man. All right. So this is the longest title that could fit on a slide. Basically, we're talking about detection as code. So already Jared introduced me, so I'll keep it very short. My name's Olaf. I like warm hugs. I'm a father of 2 boys, and I used to be a documentary photographer, so I never went to school for cyber. Doesn't really matter, I guess. It proves what you do with it. So I'm a detection engineer and security researcher, and that's kind of important for the rest of the context as well. And I work at Falcon Force. I'm actually one of the founders of it. It's a Dutch-based company, but we provide services globally where we are one team as red and blue, so we're sort of a purple company. And that allows us to do a lot of the things that we do also in this talk. So what you can expect here is basically why we started doing the detection as code bit. What does it mean to us? How we document and store and process and analyze everything. What are some of the benefits of that? And then also how that can enable you to do automatic validation. And to start off a little bit there is we have a division that's called Falcon Force Sentry, and basically that's doing the detect, analyze, and respond bit for our clients. And that starts out with the most basic model that everybody knows, right? So you have all kinds of stuff that generates telemetry. There's all kinds of automated detection logic on top of that that generates alerts or indicators. And they boil down into an incident, hopefully. But there's some issues with that, as was already alluded to in the previous talk. So stock content is relatively easy to bypass. Every red teamer can buy an EDR, test whatever he wants to do, and knows that he can bypass everything. That's also what we do. And then on top of that, there's all kinds of time wasted by repetitive alerts. Alert fatigue, as was explained in the previous talk, so that saves me some time. But we're also not utilizing all of the telemetry that all of these tools provide us. And we don't know how well it's working, and if it's even working at all. So that's why we started expanding that model into all of those additional green blocks that we're doing, right? So we're building a lot of custom content, we're doing risk-based analysis and scoring on top of that. We're building an engine that can automatically enrich everything based on entities, but also on context. So maybe Bloodhound or other stuff will be used into those factors. But that's not why I'm here, right? I'm talking about the automatic deployment and the replay of a tag bit today. So it's one of the aspects in our whole ecosystem that we provide. So the detection as code is basically removing some of the challenges that I alluded to earlier. So who changed this rule and what was actually changed, right? Because an analyst, if it runs in a sim, can relatively easily make a modification that tunes something, which might actually break the whole detection or create all kinds of false negatives for that matter. But also, if I want to make a change, will it actually work? Will it break? These kind of things, so those uncertainties will be partially addressed there. And also knowing, like, hey, when was this rule implemented and what was actually changed the last time we made a modification and what was that and when was that? And it allows you to also ensure some of the quality of the detections, follow best practices that you might want to follow, and also keep the documentation up to date, because nobody does that, right? So we all want to do it, but we're all too busy to actually keep track of it. And if it's still working, that's maybe even more important. Are the data sources still there? Is the detection actually detecting the attack that I wrote it for? So all these kind of things we want to address. So detection as code to us, as Falcon Force, but basically most of the community will probably follow a similar thing, is we follow an agile process just to keep everything organized. We use a simple language as a markup language for all of our detection logic. And we plan for reusability. And this is very important to us because we provide a service as consultants. But even in an internal organization, you might have multiple levels of detections running in different environments. Or you did an acquisition and you can't merge your SIMs yet, so you have to deploy it on 2 places. And you don't want to copy-paste everything. Version control, as I started talking about earlier, is super important. And it's driven by automation, because we're a small company. We're also kind of tending to over-engineer things for the better, because we want to do cool stuff instead of replicating basic actions the whole time. And the unit testing based on realistic alerts. So we're not generating base telemetry, we're actually executing attacks constantly, automatically. Because then we actually know that it's doing what we expect it to be doing, instead of triggering on a base set that we generated at some point that might not be realistic for the new way of attacking it. So from that agile process, it's mostly common as everything, right? So we have a backlog, we prioritize, we write dedicated documentation per detection. Then we test and review all these changes. So we test it in our lab environment, where we have basically a small enterprise that we simulate. And we review all the changes. So if I write a new detection or make a modification, then one of my colleagues actually has to look at what I did to make sure that we're doing the right things and not missing anything. And like every agile process, we have some stand-ups, which is like 15 minutes twice a week. So it's not over complicated there, where we also track progress, have some discussions and some planning sessions. And then we also organize our maintenance there, because feedback from research or from developing detections is actually super important for the maintenance of the whole stack, because we might have found a new way of detecting something or have a more optimized way of the query language, these kind of things that we can then factor into all of our other ones, if we want. So from a very simplified example, I have a new idea for a detection, I put it on the backlog, that gets planned in the planning session, and there we might, during a detection or a discussion already, figure out, hey, this is not feasible, we're not going to be able to do that, so we abandon it immediately. Otherwise, it moves on to the R&D phase, where we are starting to replicate that attack, looking at the telemetry, and basically writing a detection for that, which still can go wrong, right? There can be all kinds of reasons why we can either abandon it because we can't have the telemetry for it in a feasible way, or it gets blocked because for whatever reason the telemetry is not there yet, but it will be. So then it gets blocked and we put it on a backlog later, or we abandon it at some point because it takes too long or it's not that prevalent anymore. But let's say we actually succeed, which usually is the case, fortunately. we write our detection and we commit it to Git, do a pull request, and it goes into the review and testing mode. So basically, we already automatically deploy it, which I'll show you in a sec, to our test environment, where some colleague can actually review it, look at the output, look at how it's running, look at the performance, and the quality of the code and the documentation. And in some cases, there might be some feedback where it has to go back into R&D to improve or modify or make some altercation, and then it can still be abandoned, right? So that's always the case. And if it's okay, then everything is happy, everything is fine, it gets accepted into the main repo, and it gets deployed to one or multiple environments. So no surprise there, we use a Kanban board where we have the whole flow that I just alluded to into multiple swim lanes. So we have a swim lane for use cases, we have one for our text scripts, we have one for maintenance, and we have one for our enrichment and analysis pipeline, which didn't fit the screenshot. And then we go into that file format. So make it as simple to maintain as possible. You can have JSON and all kinds of funky stuff. We work in the Azure environment primarily, so we use Kusto as a language, and they use ARM templates to deploy it, which is a huge JSON file, which is horrible to maintain. So we chose YAML, because it's super simple, we can still programmatically look at it and process it. So from there, try to be as expressive and simple as possible, and plan for the code you use, that I'll give an example for. And we can have like code reuse, but also all kinds of lookup lists. So we have a list of the lol bash project. We can just have that in a single place and not put it into all of our detections, because that's way much more work to maintain. And if you have it in the central place, you only have to maintain it once. So these kind of simple things are super nice. And then since we use YAML, we can actually build a schema for our whole document. So we can validate it programmatically, but also it's super easy to maintain it, because you can only choose from a couple of options on some of the fields. And then the next one is also designed for the ability to deploy to multiple environments. Even if you only have one SIM now, as I explained earlier, you might acquire a company or merge or whatever, want it to run in test and prod. You can actually do that easier if you do that this way. So what does it look like? So we have some identifiers in our document, right? You need to give it a name, you need to give it an ID, and the ID is basically what it will look like in the SIM in the end. Then we tag it with all kinds of stuff. So we call booster pack or suspicious behavior. You can basically make up the list yourself. We have some qualifiers in which operating system, our expected false positive rate based on our experience, the severity that we want to give to it, and of course MITRE tags for tactic, technique, and sub-techniques. Next, we also provide a list of data sources that the query utilizes, so that we can validate fairly easily if the data is even available. So we tell it the provider, so where does it come from, which event ID or event name or action type, whatever it's called, which table it goes into, and then also, again, the MITRE tag data source components that they classify with that, so that we can generate overviews, which I'll show you later. Then everybody's favorite bit is the documentation, especially the analysts will love you if you do this well, where we have a brief technical description of what the query actually tries to do, a description of the attack, so what does the attacker want to achieve with its attack, so what are we looking at? Some considerations, which could be anything for the analyst to be aware of. Some known false positives, so that's easier to classify. Some known blind spots, because you can tailor a detection in a specific direction, knowing that you're not looking at that bit. So you can classify that there, right? So we know that we're only focusing on this. The other thing is addressed in either that detection or we don't do it because of X, Y, Z. And then a basic response plan. And of course, that depends on your internal requirements, what you want to do with this. For one client, we built even a whole playbook design in there, which would automatically be deployed into their Confluence instance with graphs and everything. So this can be very flexible. We also maintain a change log within the detection so that we know what was changed when and what the impact of that change might be. Again, this is for multiple environment tracking extremely useful, but even for generic overviews, so you can at least have some basic indication what was changed without having to go through the whole commit log. Then some basic deployment information, so where do we want to deploy it? So the language in this case is Custo, but it could also be SPL or whatever you like. The platform that we intended it to be deployed to, so in this case it's Defender for Endpoint, but we can also deploy it to Sentinel, and then we can have some of the how often should it run, which entities should be extracted, these kind of information to it. And then, of course, the most important bit is the query. So this is a relatively simple example, just to make it a bit legible. And we use some Jinja formatting that I'll show you later, and I'll explain why. Because this is where it becomes powerful with the detection as code. And then you get basically a structure like this. So I mentioned the schema support already, and this is kind of nice because in VS Code there's already a way that it knows, hey, for permissions required, you can only use this. So if you type anything else, you'll get an error, so you can't even fully commit it yet. And it also makes it easier, right? So you know I can type this. You can just select it and click. So that Jinja templating that I mentioned, this is what I really, really like. So Jinja is basically a Python module that you can use and allows you for templating. So all the green bits are basically template blocks, which we can automatically replace in our pipeline. And we can even specify defaults. So in the, that doesn't work, but in the top line you see a time frame with a default of 1 hour. So if I don't specify this at all, it will take the default. That's basically sort of what you have to get from that. And then we can have also even if-else statements if we want to make it really fancy. So we can actually be super flexible. So in example 1, we have a customer that doesn't want to exclude or does want to exclude the servers, and there's some filtering for their environment there. So when we run the pipeline, we basically get output like this. So the time frame wasn't specified here, so it uses the default. Also the initiators one uses the default, and then it adds those 2 green lines that were mentioned here as a post filter, and it will generate the rest of it because the exclude servers is true, so this whole block gets added too. For client 2, they want it to only run every 4 hours. They don't want to exclude the servers, and they have PowerShell added to it. So basically when we ran it there, it looks very different, right? Even though the same base query is there. We can make it extremely flexible this way, which makes it also way easier to maintain because we only have to maintain this bit, and then 2 clients get a new detection. That's sort of why we started doing this. And this is also where version control becomes very useful because we can track all changes via commits. We can enforce or at least have peer reviews. So we can, depending on your organization and your procedures, you can enforce it or not. Right? You can also make the sort of agreement that, hey, you never push your own stuff into the master branch or main branch unless it's extremely important, whatever. There should be a fallback mechanism. And this allows also, so if I make a mistake, accidentally push it, I can roll it back as well. And the awesome bit here is we have one single source of truth now. So if an analyst, for whatever reason, makes an adjustment in production, our pipeline will override it. So the chance of faultiness is way lower this way. And that also allows all kinds of cool stuff because now we have it in Git. We can do CI/CD based stuff where we can do all kinds of actions, automatic deployments, but also validations on it. So yeah, this is basically what it looks like, right? You have all kinds of nice plugins for VS Code where you can actually see who made that commit and what they did, when they did it. And this is basically how it looks on our end. So we can see that syntax validation and the deployment was successful. So the reviewer already knows, hey, the code at least ran and is up to our standards, and then still has to look at it to see if also the detection is. And this is where we go more into the automatic validation and deployment bit. So from a pipeline perspective, it's kind of nice because it enforces, or it enables us, I'm not sure what enforces, but it enables us to do static and dynamic testing of every detection that we build. So we can do linting, we have a language server, and we can have all kinds of practice checks built into our validation so that we don't have to do that manually every time, because people overlook stuff, everybody's busy. And it also allows us to be sure that all environments that we talk to are running the version that we want. And of course, best of all, it generates all kinds of documentation, playbooks, whatever, and put into the place that you want it. So, and last but not least is also that it allows for automatic detection validation in most cases. And in most cases, some attacks are very hard to script. You can't sometimes script it, or it requires certain permissions that you don't want to have a pipeline have. Like nobody wants global admin on their pipeline in Azure DevOps, because there's all kinds of nice tech techniques that you can then apply to it. So basically, per environment, we have 4 separate pipelines. So one that does the test cases, so does the attacks. One that analyzes the attacks. One does a standard app output to Git, and one that is doing all of the other magic. We call it the hatchery because we're Falcon Force and we have a lot of eggs. So basically what we have is every pipeline has multiple stages. So in the first stage, we validate the syntax. The second stage, we deploy it to our ball pit, basically our lab environment, and we do a dry run deployment to our production environment, where we only feed it and see if it's not complaining, basically, because sometimes the data in prod is different than the lab, so we want to make sure that it works on both sides. Then there's a pause that can't be visualized, but basically there's just a review bit. If the review is accepted, the wiki is deployed or updated, and it's deployed into production and enabled and these kind of things. So from a pipeline perspective, there's all kinds of steps, and you can see that it validated all detections and no warnings. So on a warning, it will only complain, but it will move on. But we can also generate errors based on whatever is in there. And that's the same on the deployment side. So now it checks whether the rule is already there, and it's the same as what we wanted to deploy, and then it's skipping it. If it's a new one, it will just deploy what's new. If there's something different, it will actually pull it, store it in the log, and then push the new stuff, because that's what we agreed, right? The Git bit is our single source of truth, but at least we record what was there in prod. So even if it's a small change, we know that somebody made a change, we can have a look at it, and we can actually, we can either decide whether we want to include it into our Git repo or not, or talk to the person who's like, hey, why did you do it there? So it's just a nice check. And then the same goes for the update of the wiki and the deployment of the production environment. So those are way simpler because we already checked everything. So some of the errors are not the easiest to read, but once you get used to this flow, we're actually quite flexible there. And it will already tell you, like, hey, some of the things are missing or whatever. So we made some changes to that to make it more user-friendly. One of the other things that we have in the pipeline next to a linting bit is we built a language server for Kusto, which is the query language that we use. And we can do offline schema validation, and it enables us to do some other things. So basically what it does, it automatically gets all the documentation from Microsoft and updates the schema that it's actually working against. So it's sort of emulating a Sentinel or a Defender for Endpoint instance, which allows us to build some additional custom parsers and things in it as well. And that's what I just said. So we open sourced it, and we also host an instance which you can run in your own pipeline if you want. We don't log anything, so we don't want to know what you're doing with it. And basically what that does is it uses those ARM templates that I started out with. So how you deploy it to Microsoft, you also push it against this API, which basically says which environment in it, the query itself, and of course a lot of other stuff, but it ignores that. And you can just feed it into the API with the simplest query ever. And it gives a lot of output. So we can't read this. So one of the things it does is it tells you which columns are coming out of your query. So what is the result in fields that you get back? And why do you want that? It's basically if I expect something as an analyst, or I have entity mappings or other stuff in my detection logic, and in my documentation, then you want to make sure that's actually there. But it will also do all kinds of parsing errors. So if there's an error in your query, it will already tell you here before it actually goes into a production instance or a test instance. And also it tells you some other nice things, is which tables you're working with and which reference columns, basically which columns are you querying. So if you don't have that data, then it will start complaining about it. And afterwards it will start generating all kinds of documentation overviews. So we have a sort of a list of all of our detections, which platforms they're using and these kind of things. It's not the most pretty, but it's super efficient. And per client, we also generate an overview of which version are they running, what is the latest version, how is it called in their environment, when was it published, what's the status of it, and does it need updating? Because in some cases, the client actually might want to have an older version because they're still running, I don't know, 40 nets from 5 years ago, where the schema is actually different than the one that is in our current detection. So we want to have that flexibility there. And then what we started adding as well, because the wiki is nice, but a portal is nicer, so we built a portal that's automatically generated every time we merge something into the main branch, where we can have all kinds of easier dissections. So we can quickly see, hey, do we have a detection for AWS? And then you can just click it and get a list of an overview, and you get a prettier version of the documentation just rendered this way. It's all marked down on the back end, so it's the same and might be a bit familiar, but it's a little bit friendlier to look at. And of course, we can also generate all these nice fancy heat maps, and we color it based on prevalence of detections. So the darker the color, the more detections we have for it, because you can't always cover everything in one detection, right? And then last bit is basically the unit testing. So now we built all these detections, we roll them out, but how do we know they're working? So that we had a couple of goals in mind. So we want to make sure that the agent actually is logging the events that we expect when an attack is happening, because otherwise, how can you detect it? The format of the logging is still consistent, like the 40net example, but it can be for anything. Also, Microsoft has a tendency to sometimes change schemas and not always be super exact in their way of logging. So we want to make sure that it's actually still doing what we expect it to do. But also, are they even arriving? So if it doesn't arrive there and it's generated, what's the point of having it? And then the last one is also, is there an out-of-the-box, it's kind of doing weird, is there an out-of-the-box detection coming from the EDR, for instance, now on a detection that we also wrote, so that we can have a difference to see, hey, does it actually make sense to keep it? Because maybe the out-of-the-box detection is equally good, so we can deprecate one of our own detections, saving some compute time and maintenance hassle. And ideally, each use case can have like at least one of the test cases that we have. Sometimes it has multiple, because an attack can be executed in various ways and it's incorporated into the detection, but we flag that all. So some design principles that we had is where possible, actually do the attack. So don't mimic it. But also, most importantly, and this is where a lot of the other tools miss it, I think, in my opinion, is where if I execute an attack, I also want to make sure that the attack succeeded. So I want to measure that, because I can run a script and move on and then see, hey, the detection didn't work, and then you're looking at the problem at the wrong end maybe, right? If the attack already failed, then the detection will never trigger. So how do you validate that? And have variables that can differ in every environment, like a domain name, file name, location, username, these kind of things. So you can be a little bit more flexible there. And if you do an endpoint-based thing, focus on the EDR and not the AV, because AV is trivial. Everybody can bypass that with a little bit of effort, so our detections usually aren't incorporating that. So, and that's where we started designing our own YAML format again, which is based on Atomic Red Team, which is awesome. Just extended it a bit with the things that we were missing from it. So from a logical flow perspective, we have a detection rule that might have an attack script that goes into that attack script pipeline that we run every 15 minutes. But you shouldn't do that. You should do it once a month or whatever if you do it on an internal basis. We just do it a lot so that we can quicker see results and have better maintenance that way. From there, that attack script can execute it directly on a host via SSH or some other agent that we have built ourselves, but we can also integrate with some of the commercial breach and attack tools like Prelude, but we can also work with a Caldera or some other tools. as long as they can work with that YAML format that we have. So that then executes it on a target. The target reports the status back, including did it succeed or not, because that's very important to us. And the tool, or actually a pipeline, depending on where we run it, feeds that result into Sentinel. But the target also has a role there, because they have an agent running and they log stuff, so they either alert or log to Sentinel. Alert gets generated. And from there, we can actually start correlating, hey, the attack ran, it was successful, and it was detected or not. So that goes all into a dashboard, which is the manual bit of looking at it. We can also run it from the pipeline that I showed you earlier. And we can generate a Slack alert and say, hey, there's a discrepancy from what I expected and what is actually there. So for instance, the attack is failing now where it used to work, or the other way around where the attack is still succeeding but it's not detected anymore. So we need to look at it and do some maintenance. And that can be either on the attack side or on the detection logic where either one of them is failing. And then to have a very simple example to what it looks like, this is just, again, a YAML format where we show what it's linked to, which detection we expect to trigger. So this is tied to one of ours, but it can be many. So sometimes we trigger multiple detections with one attack. And that also includes out-of-the-box stuff from the EDR or the SIM. So we look at those as well, because, yeah, why not? Where we can run it from, so that in this case it's only one variable, but it can also be many from a domain name and these kind of things, some global dependencies. So we built one hijacking DLL, which we run in multiple attacks. It's just easier than tailoring it completely. And then a basic script where it's also checking did it succeed or not, and it cleans up after itself, because we want to have a clean system afterwards. And then some of those dashboards examples are relatively simple, where we have a lot of detonations, and we can also see over time how well is it doing, and have an overall success rate that we calculate. So we basically know, okay, this 100% of the time ran, and the two red ones we need to do something about, preferably sooner than after a couple of weeks, right? But that can happen. And then on the flip side, we also have a dashboard for all the detections, which are tied to the attack scripts, but we can basically measure, hey, it executed 50 times, and we detected it, 37 times. So why? And of course, you can click everything and drill down into the raw logs and see what was actually executed and why it's not detected. So in some cases, we actually ran into some issues where alert grouping and these kind of things are also occurring, which might be either a misconfiguration in the SIM, or NVE in this case also wants to be smart and just group everything into one single incident, and then it's not detected anymore. So that's sometimes also where these numbers come from. But this only occurs if you do it in our way, where we run it every 15 minutes, which in a production or a large enterprise doesn't always make sense. So then you do it once a week, once a month. And then you just have a pipeline that deploys an environment, you run all your stuff, you let it sit for a bit, and then you kill the environment, and you start up with a clean slate the next time. And then somebody actually has to look at the results, because otherwise, yeah, you can test it, but if nobody's validating what is tested, then you're wasting a lot of resources. So to wrap up, because time is up, just some simple things, right? So detection as code provides a lot of quality control, automation. It's usually ease of life for most of the detection engineers or the people maintaining this. And you have a lot of opportunities for review and improvements there. It ensures a single source of truth. It allows for automated deployment, even across a lot of environments. It doesn't really matter how much, that just config. And it's self-documenting, provided that the detection engineers do a good job and they get flagged with reviews if they don't. And the best thing here, that I like about it is that there's some certainty from the validation perspective, is that you actually know it's working and it's doing the stuff that you want. So, not the most technical talk, but if you're curious about more, we can discuss a bit on the panel. But we're also having a booth behind here. So if you want to see a little bit more or ask some questions, I'm more than happy to answer them there. But thanks for coming out.
All right. Well, we're going to do the panel discussion in a few minutes, but the Slido allows you to ask questions for the panel. So if you have questions and you want us to discuss them, when is the panel discussion starts? In the panel's in 5 minutes. Yeah, the panel will start in about 5 minutes. So if you have any questions for the speakers, feel free to add them to the Slido. It's in Discord, and then you'll be able to make sure that it gets included. And here's the QR code if you want to get access to it. All right, we're going to go ahead and get started with the panel discussion. Yep, you have the mic. Oh, I think you might have. The mic's coming. All right, just a reminder before we get going. If you scan this QR code, you'll get access to the Slido, and that will allow you to ask questions. So if audience members want to ask questions, you could direct it at any of the members of the panel. Feel free to connect there. We already have 2 questions that we'll go ahead and make sure that we deliver. But we'll have conversations. If you don't have any questions, we can make them up. I'm happy to ask. And then we'll go from there. So feel free to hook up into Slido. Make sure you select the proper room. I'm not even... Somebody French, please tell me how to say that.
Salle Ville-Marie.
There we go. Okay, so go to that, and then we'll go from there. So we had 2 really great discussions, 2 really great presentations that I think really kind of touched on really important factors of detection engineering. So one is this juxtaposition of false positives and false negatives, and how you can go towards reducing false negatives while maintaining a reasonable false positive approach. And the way that they talked about doing that is to disconnect detection firings with alerts and investigations, right? So the idea is that just because your detection fires or there's an event that matches your detection rule, that doesn't mean that you need to fire up the entire investigation process, and that allows you to maintain resources. One of the things that is really interesting to me when I'm kind of looking into signal detection theory, which is the kind of psychological or the overarching theory behind detection, is this juxtaposition of false positives and false negatives, and the idea that different detection problems, right? So in cybersecurity, we have one detection problem, but for instance, the criminal justice system is a detection problem. The question is did the person commit the crime, right? And like medical testing is another detection problem, which is does this person have the disease, right, for instance? And different detection problems are going to prioritize the reduction of either false positives or false negatives differently, right? And so in the criminal justice system, we have this situation to where we want to reduce false positives, right? Because, for instance, convicting an innocent person of a crime is worse than letting a guilty person free, right? But in medical testing, you could say that false negatives are viewed as being worse because, for instance, not detecting cancer early on, for instance, is worse than telling somebody that they're fine when they're actually not. And so one of the questions that I think they kind of touched on this from their perspective, but I'll go ahead and ask everybody just to kind of get the juices flowing, you could say. In detection engineering in the context of cybersecurity, do you think that false positives or false negatives are worse? And maybe give us a little explanation of why. And I'll start with Olaf.
Oh, great. So
tons of time to think about it.
Yeah, now I have to do it on live, right? But it's I think it stands to reason that false negatives are worse because not knowing that you got breached is always worse than having noise. I think noise can be dealt with up to a certain extent. I think they had a great example where they used indicators on top of detections or in parallel to detection. So the stuff you know that you want to make sure that it always alerts you build a detection for. That's also how I approach it. And the other stuff is it could be bad or not, and their false positive rates are, I wouldn't tune it as much because, yeah, an attacker is smart enough that he knows how to mimic whatever is happening in your environment if they spend the time and effort to do so. So those indicators, what we built as well is a sort of framework around it where we can quantify every indicator based on all of their entities and their context around it. So we look not only is this a user in our environment, but also which rights do they have? Do they have a path to any sensitive resources in Bloodhound or all these kind of things? We look them up externally, and based on that context, we give them a rating, and then we do correlation on all of those ratings over multiple time frames. So their false positives don't really make a lot of sense because in correlation, they get evaporated anyway.
Cool, thank you. Emilio?
I would simply simplify, I would say the same thing, simplifying that, saying there aren't many ways to deal with false negatives, but there are tons of ways to deal with false positives. Like, as you presented,
For sure, for sure. Thank you. Remy?
Yeah, I think it depends on the context. Well, if you have limited resources, maybe false positive are the worst because you want at least to treat the most critical things first. And if you have a way to handle the false negative, then maybe the false negative is the worst. But if you don't have these resources, well, then I'd say the false positive are the worst.
Okay, thank you, thank you.
Yeah, I think context matters, right? I think Remy has a very good point. So it depends what you are as well. I'm the only one here who works for a SIEM vendor, so my team deploys rules that goes to all of our customers. So generating a lot of false positive impact many lives. Well, analyst lives, not threatened lives. And there's also the impact. If we make a bad rules that generate thousands of false positive per customers, that generate lots of problems. So false positive are big problems. False negative, if they're known, if we have assumptions, or if we know our blind spots, then they're less dangerous as well. So if we follow like the ADCS framework from Palantir, that can help you negate a little bit the false negatives. But in general, yes, missing an attack is more impactful than having a bit of a flood of alerts.
Awesome, awesome. Okay, actually, it looks like we've had quite a few questions come in, so thank you to all of you in the audience. I'm going to pick one. I was going to pick them in order that they came in, but I don't think it's in chronological order anymore. So one easy one is Yamaha an acronym, or what did that name come from?
Well, yes, like YAST, yet another system tool or something like that. There's like a trend, and I was thinking about yet another something, and I have a Yamaha base, so I had to make an acronym with Yamaha, so it's yet another mainly aggregated hunt activity.
Okay, you're going with like the YAML, yet another. Okay, awesome. Thank you for that. I just realized that they're being upvoted, and so it's in order of kind of most upvoted. So again, for Remy and Emilio, what is your favorite indicator? Are there any that are kind of like your child? Like, do you have any baby indicator? And based on that reaction, I think there probably is one at least.
I give it as an example, the indicator that was our success story, which I don't remember the exact name. Sorry, I'm a bad father, but the indicator which triggers on when a new domain is accessed on a small number of machines. So this is a very noisy indicator, but I really like my favorite thing about Yamaha is the pivot concept. So you pivot from an investigation through two indicators, and this might allow you to pivot to something else or confirm or infirm theories. And having an indicator for small noises that are different on each machine, but might give context on an investigation. That's my favorite type of indicators, which don't contribute that much to scores of when we talk about scoring entities, but during pivot on an ongoing investigation, they're very useful.
Yeah, one of the things that I liked about at least one of the, you said there's multiple scoring methodologies, but one of the scoring methodologies was basically less frequent has a higher score, right? And that reminded me of Nassim Nicholas Taleb's Black Swan book. So it's a book by Nassim Nicholas Taleb, and the general idea, the philosophy is that things that are going to have a major impact on you are by definition statistically rare. And the idea is that in general we live in an organized and ordered world, right? So everything kind of makes sense, and things that happen frequently almost certainly have to have very small impacts on us. Otherwise, we just live in chaos all the time. And so the idea is that if something happens all the time, it's by definition not bad, right? And so all the bad things that are possible to happen, or like the worst things, like his example is like the financial crash in 2008, right? The real estate market crash. Those are going to be things that are going to be statistically rare. So that seems to be, if you're going to take like a starting position of how do you start to score things, it's all about, least frequency of occurrence or prevalence, right? Seems like a really good good start.
Yeah, and it also limits it increases the feasibility of actually analyzing it properly, right? Because it's
Yeah, so Olaf's talking about the ability to actually analyze things. So can you expand on that a little bit?
well, if the domain name is anomalous, then and it comes from a small set of processes, it's easier for an analyst to determine, hey, this is weird, I should look into it. Whereas if you see Teams connecting to Microsoft, it's 95% or 99.999 whatever percent, it's legitimate, unless a sophisticated attacker found a way to actually piggyback off that. Determining if that is actually malicious or not is way harder than the anomaly that stands out.
Yeah. So okay. So that now you're making me think of something different. So I don't even know if it's machine learning would be the proper field of study to talk about this, but there's this concept called the manifold hypothesis, which is you can analyze things in like an infinite number of different from different perspectives, basically. And so the idea of this, like, the less frequent something is, the more likely it is to have a major impact. The interesting question is how do we know that we're looking at it along the proper, looking at the proper features maybe, or like the proper variables of that thing to know. So like Teams connecting to Microsoft, that may not be the appropriate way to be looking at that interaction. Maybe there's some other feature that maybe we just don't even know about, maybe we don't have telemetry on, that's actually the thing that makes it statistically rare relative to all the others. And so that's something that I constantly struggle with, is like, how do I know that I'm looking at the right things instead of just what is apparent, right?
Yeah, and it's not only a machine learning struggle, it's an everything struggle. When you're a SOC analyst and you look at alerts, you have to think, am I looking at the right data? Are there other data? Are they more meaningful? And then you have the concept of pivot, which is going to show you other data. So it's the same kind of problem as well. I think it applies to a lot of fields.
There's this concept called the snake detection hypothesis, and the idea is that humans or primates in general have evolved with snakes as their primary predator, right? And so the idea is that humans dedicate a large portion of their brain to visual, like their visual acuity. And so the question is why do we see better? Like dogs, for instance, don't see as well, and that type of thing. And the hypothesis kind of posits this idea that the reason is that snakes were our predator, and snakes are relatively camouflaged. And so it's very difficult to see snakes. And so our ancestors, which survived in rougher times, basically, they were able to see snakes and actually differentiate them from their environment. And one of the things is that we prioritize movement. So there's all these different things, like, for instance, you could go on the street corner in a busy city and point up in the sky, and then people will stand next to you and like look at where you're pointing, even if there's nothing there. And that's because there's this like kind of lizard brain thing to where we start to think, oh, if this person's wasting their most valuable resource on looking up in the sky, then there must be something to see. There's this question that I have of like, how do we, that's a biologically or evolved process, like our visual perception, but imagine that EDRs are our perception, right, in the cyber realm. So the question is how do we know that what EDRs are seeing is actually what we should be seeing, because it's not evolved in the same way, it's artificial. Does anybody have any thoughts on that?
I'll let them go.
Scooby, come on, buddy.
This is rent time.
No, but I think So EDR in specific, and like all other tools, you cannot blindly trust any vendor, right? There's some vendor that you might trust more, some vendors that you might trust less. But I think Olaf kind of talked about it a little bit in his talk. But you built a detection for something that you are aware of, and at some point the EDR might catch up, and then you can retire your detection. So that's one kind of going in the direction you were talking about. But yeah, I think it's very important to know your threat models, test your security software, and make sure that they are responding to the way you're expecting them. And if they're not, you should hold your vendors accountable as well. They are the one who provide the detections, and they are the one who can improve their product. So in general, if the tool you're using are not detecting what you're expecting, you need to go back to them. If you're building your own tool, then you talk to yourself and you prioritize those things.
Cool.
And I would balance on the laser brain stuff because this is actually something I love using as so one of my other function in the SOC is doing SOAR automation, so automating contextualization and showing them to analysts. And one of the things I love using is the fact that we stick on shiny things.
Yes.
So I love putting colors in the contextualization for important stuff. So for example, we have a contextualization when we add a domain artifact. So we're going to look up our environment in the same stuff as Yamaha to see when was the first scene and the last scene of the domain. And for how many days it was in our environment. So if the domain has been in our environment for a very short time, so for example, 1, 2, 3 days, I'm going to put it in big red. But for all the other domains that I've been seeing for like 1, 2, 3 years, they're going to be in white like everything else. So when you look at the data, you're going to see this one is standing out, so you might be interested in looking at it. So I think it's actually interesting that we can use this to orient analysts into looking at the stuff that might actually be interesting or analysts.
Yeah, for sure. I live in Las Vegas, so of course, leveraging color to force people to do things that they otherwise wouldn't do is like right up our alley.
There.
All right, so trying to stay on the SOAR topic, so maybe this is a perfect question for you, but this is another audience question that says, what are some tips to enrich existing detections with sufficient context to make the triage easier? Does anybody have like a favorite data source or maybe a little trick to try to make sure that you're giving the analyst as much information as possible or anything along those lines?
I'll try to answer that. One thing to be wary of when contextualizing stuff in is you cannot show too much information because showing information comes with a mental load.
Okay.
And if you overload an analyst, they're gonna a bit like fatigue, they're gonna start to ignore some stuff. So you need to pick the information that's actually useful to show them and still show them a way to have the full information, but not necessarily show it by default. And I think that the best kind of information to show is really, well, stuff obviously that's related to the stuff you're analyzing and stuff specific to your environment. So I give it as an example, the first scene, last scene, and the number of days the domain was seen on our environment. This is usually very interesting for analysts to consider as information. So I would say this kind of information that's really tailored to your environment and is normal in my environment is the best kind of stuff you should show.
Gotcha.
Yeah, I think one of the things, I fully agree. And I think one of the things I would add on top of that is a sort of historical overview of the entities that you're analyzing. So if you're looking at a machine, a user, and a domain, I would add the machine and the user at least as a historical overview, how many alerts have triggered on that machine and that user. Because if you have a larger SOC, it's quite likely that like Mathieu looked at alert 1, you look at alert 2, an hour later, you're not aware of each other looking at it. And in context, or in correlation, those two actually might not be false positives and lead to a bigger story.
Yeah,
right?
clarifying relations between
Yes.
entities is really important.
Yeah.
I agree.
One question I have about how you're doing the grouping, have you considered the idea, so there's this idea called composability, which is how things provide, like one thing will provide output that's then an input to another thing. And so imagine that you have some alert that's based on some behavior, and that behavior can't stand alone. It requires some sort of prerequisite to be achieved. So for instance, curb roasting is the example that I like to use. So it's like, if I curb roast, I'm not just, first of all, you can't necessarily just curb roast. You probably need to enumerate service accounts first, right? And then you can run curb roasting. But then I don't just curb roast for no reason. I then intend to like log on with the user that I requested a service ticket for. And so there's this idea that kind of what you suggested in your talk is that we can potentially look for things that with a broader scope, which is somebody requested a Kerberos service ticket, which potentially happens all the time, right? But now I'm waiting for other things to happen that are going to be relevant, that gives me context. But have you considered thinking about it from the perspective of other things that are relevant to that particular behavior as opposed to other potentially bad things?
Yeah, but sorry, we have some indicators that are like super indicators.
Okay.
They are built like it's a correlation between indicators, and it triggers if there are like 5 of these in the same hour or something like that, and then you get it raises an alert with all the indicators that triggered, and the SOC analyst can say, okay, this happened and in this sequence, and yeah, we have things like that. And it's pretty nice. We don't have many.
We're kind of scratching the surface on
Yeah.
on this concept, but it's a goal for us to be able to leverage that concept that something A, B, C, if they happen independently, we don't care. If A, then B, then C happens, it's probably like something that's very bad.
Yep.
So it's something that it's a goal, but we're not quite there yet. So Yamaha is kind of new, so we're still doing R&D on that. It's coming.
Yeah, that's awesome.
There's 2 things there. So there's the chain rule, so things that you know should not happen in a certain order, or just together. But there's also, you talked in your, you mentioned that I think in your talk as well, there's the entity scoring. So today you're doing this, maybe you have a score of 2 because you've done, I don't know, you request a Kerberos ticket, but tomorrow you start logging to this SQL database that you've never connected to. You start maybe targeting things that you've never touched before. You go to some SharePoints. So every time you do one of those things, the score on your entity or the danger of the likelihood that what you're doing is bad increase. And I think you mentioned that in your talk, and that's also
Yeah, we called it inertia analysis. I'm not sure if it's the scientific term. There must be a better term for this. But yeah, basically, if the entity has a kind of static score and in the next week it increases the tenfold and stays like that, well, perhaps we should investigate that because something new is happening on that machine, and it triggers indicators which are indicators of abnormal activity.
Yeah, I actually, for what it's worth, I liked the term inertia analysis. So, yeah, that was good. Cool. I'm going to switch to another audience question, this one for Olaf. So a little bit of a switch of topics, but how do you convince management to invest resources in detection as code?
Yeah.
Any,
What's it?
he is management, so it was
he
easy
doesn't
for
have
him.
to. They pay him for that.
That's a good question. I never had to convince management of it because in most cases, management wants visibility in what the team is doing. They want to have some measure of quality control. They want to have insight in the process, and these kind of things are all there. And the quality aspect is there, the validation is there. So in most cases, and we work for larger enterprises and global companies. So maybe it's a bubble, right? So if you're in a small company, it's a harder sell. But even then, you can, the guarantee of consistency is usually already the biggest selling point. And then if you're in a company that is susceptible to audit and these kind of things, then it's even easier because the full audit trail is there. Every auditor likes it, especially if you explain how it works, because they usually don't get it directly. But I think that those are the easiest selling points. Is like the measurability, the quality, the insight, and having a consistency method there.
We're implementing detection as code in our organization as we speak, and management was very, very open to the idea. But if they weren't, I would have given the argument that we can have dashboards and automated KPIs of detections.
Dashboards.
Yeah, they have pie charts. Everybody's happy then.
This man speaks management right here. We have about 5 more minutes, so there's a couple questions that I'm going to do a shameless plug for my workshop. So let's see. How do you evaluate that you have a good or bad detection coverage? I have a 3-hour explanation on that coming at 1 p.m. if you're interested in that, at least my perspective. What does the validation process look like for writing a new detection? Also, that would be included in the workshop if you're so interested. Let's see. Maybe a final question that I'm sure everybody kind of has an opinion on, and this is definitely an unsolved problem in my opinion, is
42.
Huh?
I have an opinion. It's 42.
42? Okay, well, we'll see how that ages in a second. So it's directed at Olaf, but I think everybody has an opinion. How do you prioritize your detection logic from the backlog to the planned state? So like you have this backlog of detections. How do you prioritize? And how, like, so we have limited, just like we have limited capacity for dealing with alerts, we have limited capacity for detection engineering, and there's way more things that we could be building detections for than we have time. So how do we choose which things?
Yeah, I'll try to give the answer as a person working for one organization, because as a consultant it's kind of different, I guess. But I would, knowing you have a threat model or are aware of what is trying to attack you, I would have a feasibility of how likely is it that I get attacked by it, it's not mitigated by anything, and I can detect this in a meaningful way that our analysts can analyze. I think those 3 things, based on knowing your threat landscape, because running after the newest Twitter 0-day is not maybe the most important in every case.
This is another Nassim Nicholas Taleb idea called the Lindy principle, which is this idea that things that have existed for a long period of time, you should assume that they will continue to exist for at least the same amount. So like if I wrote a book today, the chances that 2,000 years from now it would still be published is like 0. But the Bible, for instance, was published or written 2,000 years ago, and it's reasonable to expect that it will continue to be published 2,000 years from now. So that's kind of the thing of the longer something's been around, the longer it will continue to be around, and that's the antidote to chasing the new hotness. So something new comes out. I don't even remember what the snake Turla malware thing. It's like people are focused on that because it's this new thing, but if you actually look at it, a lot of it is really old stuff that's just being repurposed or wrapped up into something that appears to be sexy, right? And so if you would have focused on the old things, the things that have been around and have been successful for attackers for a long time, you would have been already prepared for that type of situation.
What I'm hearing about your theory is that if my backlog is 100 tickets, in the future it's going to be 100 tickets.
Perfect. They will never leave. Yeah, I think it's difficult to prioritize well, but knowing your own environment and your own threats, you can make the best determination based on that knowledge, I think. There's no single source answer there.
Yeah, I would say make sure you have the logs. So which logs do I have to actually detect this? If I don't have the logs, that's probably not my priority. My priority is probably to go get those logs, but it's if you're a large enough organization, that might be another team than detection engineering. What's the severity of this attack? What's the impact? And what's the likelihood of being hit? So a little bit like the vulnerability system, but you can apply that calculation for your detection as well. And what's the likelihood or the fidelity you're expecting out of it? Do you expect it to generate very little false positive or be very noisy? Is this like a 1-for-1 rule? Is it more like a chain rule? Is it something that you built more like as an indicator, that's more like for threat hunter? So those are all things that you can consider to help you organize your backlog and put the most value on top, obviously, and then for what gives you a 1-for-1, you put at the top. What's more threat hunting, I'll put lower in the priority.
And a whole class could be given as to what is a high value detection.
Yeah.
So
True.
Very hard to answer.
Yeah, for sure. The one thing that I'm interested that nobody mentioned it, but it's like prevalence seems to be a thing that a lot of people will use, but I'm cautiously optimistic about prevalence numbers just because as everybody's seen the plane with the red circles on it, and that people talk about observation bias, right? So the idea that like if you see something, you're going to look for it, and then when you look for it, you're going to continue to see it. If you've ever heard of something and then gone out into the world and then you see that thing over and over and over, but you feel like you've never seen it before. That's essentially observation bias. And these prevalence numbers, well, they are useful, right? Because absolute occurrence is interesting. You got to be very careful when you're starting to compare things, because just because something has been seen more often doesn't mean that it actually occurs more often in reality or has a bigger impact. So prevalence is an input, but it shouldn't be in my opinion, the primary factor when you're prioritizing.
Also, something that has not been said, maybe how much of a pain is it to the threat actor if we block this technique? So if you just disrupt the skill chain because you block this particular spot, that could be something nice to put priority on.
Yeah. So centralization, like how central is that technique or that behavior to the most number of possible attack paths or something like that would be really interesting. And so it's like, and then also how many different options do they have? So if you're talking about like lull bins, for instance, right? There's a trillion lull bins, and so if you block one, I'm just going to use a different. But if you're talking about lateral movement, for instance, there's a relatively finite number of lateral movement options, and so if I could block WMI lateral movement, now you're stuck with, services or scheduled tasks, or there's very few, but you kind of start to close people in. I think we're near the end, but it looked like you were getting ready to say something.
No, well, they said pretty much what I wanted to say.
Okay, cool. All right, well, thank you everybody for joining us. Thank you to Olaf, Emilio, Remy, and Scooby. Great presentations to all three of you, and looking forward to rewatching those and kind of playing around, especially with your tool, because that seems like it's fun, and it really seems like a capability that a lot of organizations would benefit from. So,
Yep. Sure.
Cool. Thanks everybody.
So the conference will start again at 1 p.m. So you have lunch, go have lunch, and come back. Workshops also start at 1 p.m. All right. So welcome to the second block of the Ville-Marie room. So we're now at the red team block. So our moderator is Martin Dubé. He has been hacking for 15 years, in particular on malware development, evasion of defense controls. I'm losing my sheets. And process automation. He has been a challenge designer for Hackfest for 7 years and NorthSec for 1 year. Currently, Martin leads a large ethical hacker department. So welcome, Martin Dubé.
All right, good afternoon, everyone. I hope you have a good lunch. Maybe not too heavy, because honestly, this afternoon is going to be heavy in content. I'm very excited to animate this red team block. I think it's going to be an awesome 3 conference in a row. Without waiting, let's start with our first speaker. We have Guillaume Caillé. He leads the pen testing team at Okiak. Guillaume specializes in malware development, red teaming, and incident response. The floor is yours.
Thanks. Thanks, Martin. Hi, everyone. Thanks for joining me for this talk on thwarting malware analysis, integrating established and novel techniques. So as Martin said, I'm Guillaume Caillé. I'm the team lead at Okiak for the pen test team. I'm a huge NorthSec fan. I've been participating for the last few years, and it's always a pleasure to be here. As you will see in the next slides, I really like Nimlang as a programmatic language. So every proof of concept that I will publish today on GitHub are written in Nimlang, but be assured you can translate them in less optimal languages like Rust, Go, or C. That was a joke. Please don't throw rocks at me. So here's what we will cover today. But first, where this research started. So obviously, when you do red teaming, you need to craft your own payload, because if you use anything public, you will get burned instantly. It's not even worth doing it. So when you spend that amount of time creating those special precious tradecraft, the last thing you want that to happen as a red teamer is the blue team getting a hand on your payload and creating a bunch of signature on it, like in 1 hour or even 1 day. So yeah, I wanted to, even if my goal is to train the blue team in the end, I wanted to put a better fight, make it more interesting. And in 2021, there's one researcher that published a tool that I will present soon. And basically, it was an anti-copy technique. So a file executed on system A could indefinitely work on system A, but on system B or on VirusTotal after that, it was not possible to execute it. That really sparked my interest, because it didn't explain anything about that technique. So I spent a good amount of time trying to understand what it was doing. I found some weaknesses. Then I created more proof of concept that improve on that technique. So this is what I will present today as for the novel anti-copy techniques. But first, I will present some established technique that you can use to prevent your payload from being executed in sandboxes or from being reversed. Then we will talk about detection opportunities and other elements to consider. Established techniques. So the first big category of technique you can use are called guardrails. So the goal of the guardrails is to prevent your payload from being executed in the wrong environment. So it can be either VirusTotal, a sandbox, or just not your right target. There's multiple ways you can go about that. So making sure your payload can check that the system is joined to a domain, there's a good enough number of CPUs, a high number of screen, as the mouse moves in the last few minutes, as the number of windows change in the last few minutes. So all those techniques are really good against sandboxes, a bit less against human, because a reverser can just take a look at your payload, see what you're looking for, and just modify his virtual machine. And in the end, he will be able to decrypt your payload, get your shellcode, get URLs, secrets, and etc. So it has good points, but some good weaknesses. The next big category of things you can do is anti-debugging or anti-reversing technique. So the goal is to prevent a reverser from being able to take your payload, open it in a debugger, like I'm showing here, and being able to bypass your basic guardrails. So in the GIF at the right, you can see that I implemented 2 checks. First, when you execute the payload without any debugger running, it does not detect a debugger. But if you open IDA IDA by default creates few temporary files next to your payload. So I'm checking regularly for those type of files. And also in the PEB of the process, there's the am I being debugged value that you can check. So those are two known anti-debug or reversing technique. The more you add in your payload, the more it's painful for the reverser. So the goal is to add as much as possible so the reverser lose interest and move on to other things. However, a dedicated reverser will in the end be able to decrypt your payload because if he has the right tooling and the right knowledge, he can hide itself from user mode. Your payload won't see that there's a debug. So here's the first and novel anti-copy technique, which is scroll like a king. I didn't develop this. This was created by A.One. It was presented at WoodCon and ITCon in 2021. Before I move on, there's a QR code at the bottom right. I tested this morning. I'm not sure it's possible from the crowd to scan it. But just know that at the end, you can just go on my GitHub and find the repos. So yeah, this proof of concept was published in 2021. And what you can see is in the GIF is that at the right is executing the file one time, and then he's moving the file to a second system, and on the second system, it doesn't work anymore. As he was saying, it's naturally broken. But how does it work? Why is it naturally broken once it's on the other system? Well, let me explain it to you. When you have an exe or a DLL, both files are following the PE format, and in the PE format, there's something called the import table. So let's say you have a basic program that when you execute it, it pops a message box. So your program to be able to spawn a message box, it needs to call a function in a system DLL on Windows. For message box, it's a user32.dll. So the import table of your payload needs to have an entry for message box inside that DLL to be able to fetch the address at runtime. So the text at the right, the two more important things to know today is the original first chunk and the first chunk, which are a small part of the import table. So the original first chunk is a read-only table, which contains the function names of each function that you need at runtime. And at runtime, the first chunk table, which is empty on disk, will get filled with the real address on the current system for that function. So that every time that function is called, again, it's the address stored in first chunk that will be used. So here's a small or simple example. In the original first chunk, you could have a few ETW-related function. At runtime in first chunk, you will get memory addresses for first chunk, in the first chunk that will get filled in. However, the screw like a king proof of concept does not use function names. Instead, it uses integers. But what are those integers? Those are ordinals. So if you open any DLL or system DLL on Windows, you will see that for each function, the function name is exported, but also a small integer that is an ordinal. And how it works is that the first function of the DLL that is exported will have the number 1, the second number 2, and so on and so forth. Normally, everybody calls function by their names because this is more stable. The names don't change. However, it's not the same thing for ordinal, because at every Windows version change, even for small Windows version changes, the ordinal number can be swapped. So you could have a binary that calls a function with ordinal, you do a Windows update, suddenly it doesn't work anymore. Not really fun for a normal program, maybe more interesting for payload. And you might see where I'm going to with ordinals. So the screw like a king proof of concept, basically what it does is you have two binary, the builder and the target file. So the builder will load the target file's byte in memory, map every section of the binary as an image in memory, like when you are doing PE reflection. It will then parse the import table, find every function names, look up the function ordinal on that system, swap the two information so that the import table only has ordinal, and then write everything back to disk where the file was. So every time the file gets executed again, there's no function names in the import table, only ordinals. So it will work on that system, but maybe not on other system which doesn't have the same Windows build version. So in the end, it's a really efficient technique, but you need to trust your victim to have a different Windows version number than VirusTotal or NorthSec. So it's great, but you have to trust your victim in some way, and I don't want to trust any victim, any target. So it has some drawbacks. It's not effective against the same Windows version. I tried to contact the authority, he never answered, but I tested it between two systems that has an identical Windows version. And as you can see, even when you apply the scroll technique on the first system, like as of right now, calc still work. On the second system, the same file will run again and work perfectly. So it's a really good technique, but has some weaknesses. So here's what I did. First, no, since I like NIM, I first translated that technique into NIMlang. And what I did is I improved it, so instead of needing two binary, one that target the other, the file overwrites itself and change itself. So you could send one file to your victim. Once the file is executed once, the file loads itself in memory, changes itself with ordinal, writes itself back to disk. So it's nicer. Maybe in some red teaming scenario, you don't want to send too many binaries to your target victim. However, it has the same weakness. It's not effective between the same Windows version. Before I move on to the next technique, there's two concepts I need to talk with you. The first is alternate data stream. For those that don't know what is ADS or alternate data stream, you can look at the image at the right. You can see in that folder I have only one file. It's northsec.txt. If I try to output its content with the first type command, you will see the default content. However, with ADS, you can create alternate content in what we call alternate data stream. So if I request the secret alternate data stream, you will see that there's a different content. That's a NTFS function that was created for macOS compatibility. It's mainly used nowadays for web browser. So when you download a file using your browser, that is, even if it's signed or unsigned, you will get a zone identifier alternate data stream applied to it. So if the file wasn't signed, when you execute the exe, for example, you will get that big blue screen that we call smart screen to tell you that, hey, that file is not signed. It's the main use nowadays for ADS. However, every file has a default unnamed data stream that when you create a basic file and you open it in Notepad, for example, that's the default unnamed data stream that you see. The key thing to understand here is that depending how it's done, when you move a file that has an alternate data stream to another system or to VirusTotal, for example, the EDS does not come with it. So that's really interesting. Keep that in mind. The next concept is self-deletion. So normally on Windows, it's not possible for a process to delete, or even you cannot delete a file which is linked to a running process. So if the file is mapped into memory and the process is running, you cannot delete that file. However, NorthSec found a way to do it anyway. So how it works is that your payload gets an indel on itself. Rename is default unnamed data stream to something named. Close the indel, reopen, and when it tries to close the indel again, since there is no primary data stream, Windows triggered the file delete itself. So you end up with a process in memory that is not linked to any file on disk. So here's the first technique I created, which is I call payload rekeying. So the goal will be to have a payload that contains encrypted stuff like shellcode, URLs, other secrets, and have it executed on a system A while not having any prior information on system A. Then I want that file to always execute successfully on system A, but never again on system B, C, VirusTotal, or other virtual machine. Or I want it to be hard to execute it or to decrypt the encrypted stuff. So here's the plan. At the right, you can see an XDump of a binary. The parts in red are encrypted secrets in this case. So you could think of variables, URLs, or other stuff. So the payload loads its own bytes in memory, locate those secrets, decrypt them with the hard-coded key, then generate a new key, store part of that key into ADS, or the whole, and then re-encrypt those decrypted secrets in memory, then overwrite itself back on disk. Few things. So to be able to locate my encrypted secrets, I append and prepend those secrets with a unique pattern that is not commonly found in the byte patterns of a file. Then I will just show you the quick GIF while I talk about the rest. In the GIF, you can see that I'm executing nimriki.exe on system A. I try to re-execute it. It still works. Then I move it on system B, which has a mounted drive for the same file. Copy it on desktop, re-execute it. It does not work anymore, and I also added a function that self-delete when it detects that it is on another system. So for all of that to work, initially the key needs to be a hash. It's my implementation because when you replace bytes in your payload, you cannot change the length. So my key needs to always be the same length. And this is the same thing for encrypted secrets. So you need to use an encryption algorithm which does not add padding or change the length. The bytecode need to be the same length. So you can use encryption like AES 256 CTR, if I remember correctly. That encryption does not change anything as for the length. So I stored the original key, which is an hash, and I stored the hash of the original hash. And then when I do the rekeying operation, I generate a new key, replace the bytes in memory for that key. And at every run, even on the first, I validate that the hash of the key is the same as the original hash of the key. So if that is different, it means that I'm on the second run. It means that I am already rekeyed. So yeah, like I said, on subsequent runs, that thing is checked. And my payload will know that it needs to use the new key and part or the whole thing that is stored in ADS to be able to decrypt URL shellcode and other secrets. If that decryption fails, I trigger the self-deletion, as you can see in the GIF. The goal is to give less possible opportunities for the blue team to be able to decrypt the payload. Yeah. So in that case, the payload becomes bricked if the file is moved to another system, or if the file is uploaded to an online sandbox, or if, like the SOC analyst, download your file using the EDR functionality. In all those cases, the ADS does not come with it. If you have an NTFS USB key and you move the file on it, since it's a NTFS function, the ADS will come with it. But if your USB key is FAT32, for example, yeah, the secret will be gone. If you delete the file, the secret is gone. If you move it in most ways, the secret will be gone. This technique was nice, but it again adds some weaknesses because if the SOC or if the analysis process took an image of the system before doing the reverse operation, in the end they will know that I'm looking for a key in ADS. If they still have the laptop or the system, they can get the secret back. So I wanted something even better. So here's the NIM DRM proof of concept. The goal was to build on the strength of the last proof of concept, but even provide even less opportunities for the blue team to, in the end, be able to decrypt the payload. So the approach is that I've completely removed the decryption key from the payload. I'm using an external licensing server. So let me explain the GIF. At the left, you have a license server that runs on system A. At the right, sometimes you have system B. The file is initially executed on system B and contact the license server on system A. The payload contains a unique license that it sends it to the license server on the first time with many fingerprinting elements like file hashes, host name, and you can get creative with this. The goal is to it can look like an anti-cheat or licensing server for games, though it's a really cheap version of that. You can calculate memory checksum of some important element of your payload to make sure it's not bypassed. You send all that information to the license server. The goal of the license server is to take a decision with what was provided. If it decides to return the decryption key, it will also send a generated secret. The secret will get stored in ADS. I think you can see the pattern here. And that secret needs to be provided on each subsequent run with all those other unique elements that fingerprint the system. So if anything is missing, the license server can return a message to self-delete or do other actions. In this case, the license, the payload gets bricked for the same reason as before, but if you added all those basic guardrails and anti-reversing technique that I talked at the beginning, so if someone patched the binary to bypass some basic guardrails, the file hash will be different, so the license will get banned. If the process is being debugged for any reason, the license will get banned. And more importantly, if as an operator you feel like it's time to close your campaign, if you feel that the SOC has begun its investigation, you can just ban the license or close your license server, and the decryption key will never get returned again. So here are some detection opportunities. The one technique that is all of the proof of concept that I presented today is ADS. So you can use Sysmon to detect that or to log that. The thing you need to know is that basic configuration for Sysmon Online does not look for exe creating ADS, except if they are in the download, startup, or temp folder. There are some other Sysmon configuration, like this one from Florian, that checks for very specific alternate data stream name. In this case, this is a Cobalt Strike beacon object file that is public. But as you can see, you cannot always trust hackers to be consistent. There are multiple other GitHub repos that use other alternate data stream. So in the end, this is not really a good detection mechanism. I initially thought that I had a really good detection idea, is that my payload creates an EDS on itself. So if the main usage of EDS nowadays is a browser creating zone identifier EDS, a file creating an EDS on itself would be a really good detection. However, as you can see in this Sysmon image, it's not numeric.exe that creates its EDS, it's explorer.exe. I have no idea why this is the case. I need to investigate more, but on all the tests I did, it was always explorer.exe. So this is not really nice for a detection opportunity. However, you could really well baseline your environment for any EDS creation, and aside from zone identifier, I don't think there's many more zone identifier EDS creation. So baseline your environment is a really good idea. An attacker will try to mimic zone identifier EDS, but without other custom content that will not add much value. Another key stuff to note here, you can see the content. So the content of my ADS was logged. I can guarantee you that I didn't create this Chinese or Asian looking string. So even Sysmon does not monitor correctly the content of ADS being created. So as a conclusion, anti-copy is really fun. I encourage every red team or pen testing to play with it. I also encourage every blue team to start play with it, because we never know when threat actors start using those techniques. Other aspect to consider will be handling of the key. So when you contact the license server, for example, and get the decryption key, if the file continues to execute for a long number of time, keeping the key in memory is dangerous, because any blue team can dump your process and get your key. And in the same style of idea, in general, preventing in-memory content carving using custom sleek mask, if you're using Cobalt Strike, for example, is a nice way to make content carving at runtime difficult. Today, I start every secret in ADS because I find it nice, it's volatile, it's hard to notice, but you could store that secret in other locations like regedit event log or the file system itself. However, in my opinion, it offers more opportunities for the blue team to find it in a short period of time. Well, thank you. So again, if you want to look at the proof of concept I released today, they are all on my GitHub at offensiveteacher offense teacher, sorry, on GitHub. Yeah, thank you.
Thank you, Guillaume. Good job for your talk. It was very, very interesting. Guys, don't forget to send your questions on the Slido. I will address them at the Q&A after that. And we'll be back in 15 minutes at 1:45. 1, 2. Thank you. We'll continue this afternoon with this red team block. We have with us a legend. I'm sure everyone knows Charles Hamilton, so I'm not sure I will really take too much time to introduce him. But just for the form, Charles is the founder of Ring Zero Team website. He's known as Mr. Encoder. He has a Patreon. He has been given many talks. Always very epic stuff. So Charles, have fun.
Thank you, thank you. Can you guys hear me? Yeah. Thanks. So I have a tendency to have way too much content. So this is going to be like 30 minutes for probably 3 hours of content. So buckle up. We're going to start real fast. Nothing really interesting about me. Manager at KPMG. We have some KPMG folks, also known as Mr. Unicoder, founders of Ring Zero Team and a bunch of other stuff. Some GitHub code that I wrote over the years, and also have a Patreon for like 3 years now where I produce a lot of content regarding red teaming and a lot of love to share with everyone. So first of all, I guess we're just going to address this difference between red team and typical intrusion tests. I guess the key point here is that typical pen testing will not assess the blue team effectiveness, right? So we're not trying to see if they're good at detecting you or anything like that. We're usually not going to do any social engineering and stuff like that. So when we go to red team, this is slightly different, right? We want to actually assess the detection capability and responsiveness capability of a company. Because of that, usually we're going to have to deal with some security products such as EDR, antivirus, and stuff like that. So that's the major difference from a client perspective and also the tester perspective, right? We have to deal with those products. And today, we're going to definitely focus on one of the phases of a red team engagement. There's much more to it, but lack of time. So we're going to focus on gaining access, right? You have to have your code running at some points, and we need to find a way to evade those products as red teamer. So for those of you that are familiar with typical C2 framework, you probably have seen something like that in the past. This is typical shellcode. This is something that you're going to see with Meter Predator, Cobalt Strike, or any other of the framework that are quite popular. No need to tell you that EDR and AV are really good at detecting those patterns. Those bytes are known forever. I just want to point out the MZARUH. Just keep that in mind for the future. We're going to have to go back to those bytes a bit later on. So this is well known. This is highly predictable. Of course, from a detection perspective, this can be detected easily. There's a lot of stuff on the internet about evasion and bypass. Nothing fancy here. Personally, I love to not follow the rules, right? If we look at the typical tricks that's been used over the years, you're going to come across XOR loop, which is super typical. It's like the dummy encryption kind of thing, using RC4 because it's a super simple algorithm to implement. AS2 or gzip base 64, layers of crap on top of your shellcode to actually achieve evasion. There's a big issue with that. Most of these will end up creating what we consider encrypted shellcode, which brings me to this next slide, where entropy is a thing. And I know that there's someone that's going to present or had presented a talk about entropy. Long story short, high entropy, which means that the sample is highly random, is bad. They know that there's a lot of encryption, and legitimate software tend to have really low entropy in the sense that there's a lot of patterns that repeat themselves, right? So if you encrypt half of your payload, there's a good chance that your entropy will be terrible. You would definitely want to avoid that. So you want to make sure that your code look as repeatable as possible. And one of the key things that I love to do instead of encryption, because as I mentioned, I like to not follow the trend. What I do is fairly simple. I'll create a dictionary of words, whatever. You pick 256 words at random. And then what you're going to do is you're going to transfer all your bytes into the offset associated with the word in your list. So what you're going to end up with is something similar to this, right? Let's say your shellcode is 0, 0, 2, 0, 1, 0, 0, 0, 1, and you have your table that contains all the offsets. In this case, we only have 3 because we only have 3 different bytes. So table first, second, and third. And the mapping of the shellcode will be converted to first, third, second, first, second, which are actually words, right? So you may have realized by now that we converted the shellcode into actual words, which is quite useful, right? Especially when it comes to entropy. You're going to have a pretty decent entropy because these patterns are going to repeat over and over and over and over on your sample. Especially if you're looking at stageless payload, you're going to end up with like a 3 megabyte sample with a bunch of words that are harmless on their own. Now, how you actually deal with this, lately I've been using a lot of C# for my payload, so you can literally just use a built-in C# capability, which is array index of. The point is you're going to provide your needles, which is whatever bytes you're trying to map back to whatever it's in your table, and you're going to get the offset, which will eventually be converted into the byte associated with the original shellcode payload. So if you look at the final code, if you implement this in C#, this is pretty much what it's going to look like, right? Overall, nothing really fancy. You have your table, your mapping, and the loop here that actually just convert back the index into this byte array, which contain the final data. And then the typical memory allocation, virtual protect, marshal copy, and just executing the function pointer to actually point to the shellcode. So this is pretty standard stuff. The only major difference here, I'd say, is really the use of word instead of something else. But you can be creative. The whole point here is avoid encryption. Like this pattern is not going to be as detected as any encryption pattern because this is not something as popular as the other type of code that we see. We need to understand something too. It's really important, right? When we talk about EDRs and antivirus solution, when they actually detect that kind of code, when you drop your payload on disk, they're going to check for signature, right? It's really important to understand that the compiler will do a lot of magic for you under the hood, and you need to understand that sometimes the compiler will lie to you. We're going to have a brief look at what the compiler may actually do for you. Keep in mind that the same concept can also apply to C#. C# have a metal language called MSIL, which is the upcode version of whatever you're going to write in C# that is interpreted by the .NET environment. So just a quick example, if you look at GCC, for example, for standard C code, right, you can just compile it. If you're trying to use the optimization switch, in this case the O1, you may actually end up with totally different code. So if we look at this example here, we have this piece of C code that doesn't really do much, right? It's just an XOR loop, typical stuff when it comes to encrypting shellcode, right? This is obviously weak encryption, but the whole point is about just to hide what you want to have executed in memory later on, right? This is the assembly code of this. Keep in mind that at the end of the day, what's inside of your binary are those bytes here, right? So they can build signature on that. Let's say in this case here, you have the for loop with the XOR OF, which is actually living in here. So they could actually build a signature on those bytes here. The point is you want to obviously modify those bytes. That's kind of the whole point. So if we look at the same code with optimization 1, like I showed earlier, you'll see that we have two different pieces of code, right? Notice here that the XOR is now here. You have this byte here, which is 8030 OF, and the original one was 83 F1 OF. Depending on how the compiler did its magic, it totally changed the code, and the signature is totally different. Just keep in mind that sometimes using optimization may change your code. When it comes to writing malicious code, it may also affect the way that the code behaves because you may actually try to trick it. But it's really important to understand something. The compiler is definitely smarter than you. Sometimes you're going to write super complex code. When you're going to compile it, well, it's going to end up being the exact same code that you had at the beginning. This is an example of why the compiler is definitely smarter than you. It's going to try to guess for you. So if you declare a variable like I equals 1, and you're trying to assign XOR I into the variable A, well, it's just going to figure out that A will contain whatever the result of 1 XOR with I is, right? So they're just going to remove all that code, so it's not going to change the signature. This is something to keep in mind. The trick usually when you want to make sure that the signature will be different is to make sure that you don't have any static value in there, so the compiler cannot predict what the value is going to look like. So here's an example where we have some code. It's the same thing as what we saw earlier, right? This is the more complex version of this code, which is exactly the same result at the end. It's just that we use much more complex code. So as you can see here, we have the D-word key equals D-word size XOR with D-word size. This is a typical trick. It's actually going to zero out the value. And you may believe that, oh, this is cool. I'm going to change the signature of my code with this XORing technique. At the end of the day, the compiler doesn't know what's inside of D-word size, but it knows that this operation will turn out to just create a value with 0. And then you have all the magic, you know, we do plus, which is going to increment the value by 1, bit shifting by 4, and then reducing it by 1. At the end of the day, this is going to end up generating OF. So you may think, oh, that's pretty cool. My code is super smart. I hide the fact that it's XOR with OF. Well, the compiler figured it out for you. So as you can see here, you ended up with the same signature, XOR the byte, which is part of the loop with OF, because the compiler was able to understand what's going on in there. If you look at the code on the right side, Pretty similar. The only difference is the key in this case here, which is D word size, is actually unknown because we don't negate it with like XOR or something like that. So technically the compiler doesn't know at this point what it's gonna look like. However, it's still smarter than us. It figured that this whole operation will end up causing a NOT, which will actually revert all the back. It's a NOT instruction, so this was replaced with a NOT on this specific register here. At the end of the day, it's still a victory for you because you ended up having a different signature, right? So it's just a matter in this case of using different piece of code. You change a line or two, and the whole signature is going to be totally different. So main takeaway when it comes to obfuscating your C code or C# code, look at the actual final result. You may be surprised, right? So if we go back to the original code, right, which is the one that we have on the right, and the fully optimized one, well, you're going to realize at this point that the signature is totally different. At the end of the day, those two pieces of code will yield the same result, but signature-wise, they're totally different, and it's really important to actually assess the code that you generate through your compiler. So this is another example here. If we remove the optimization on the last one that we saw, because keep in mind that the one on the right was also optimized when compiled. If we remove it, you'll notice here that it's much bigger. So we had the original 83F10F, and now this whole operation here has been modified for like a sub EAX XOR. I cannot really see anything, to be honest. And here is, but the XOR is 31C1. So at the end of the day, totally different signature, right? Just by modifying a bit of your code, right? The downside with that, it's pretty annoying, right? Let's be honest. If you have to rewrite all your tools to make sure that you obfuscate all the C codes or whatever language you use, it's going to be painful. But keep in mind that this is doable, especially if you maintain your old tool set. That's why I usually love to write my own tools, so I have full control over the source code and I kind of understand what's going on to a certain extent. There's that. So let's just go back to this original code. For those of you that are not necessarily familiar with most of the modern C2, they have a concept which is called sleep mask, right? Sleep mask is the ability to actually encrypt the data in memory. So when the beacon or the agent is not doing anything, it's going to sleep in memory encrypted. There's no point of actually looking at that piece of code because it's not doing anything. So they hook the sleep method. There's multiple methods that you can hook. But the point is, when it's living in there, it's going to be totally encrypted. So if there's memory scanning going on, well, they're not going to see anything. However, there's a catch. Most of the code like that have no effect when it comes to memory scanning. Because if we look at how these engines work, you're going to end up actually copying the code in memory at several places. Just a quick hint, final here. We're definitely going to have the final shellcode in there. It's going to live in memory. That's going to be the original shellcode, right? The Marshall copy, too, is going to copy this into an unmanaged variable that can be later reused to call. So we at least have two variables that actually contain the clear text shellcode, which is definitely something that you want to avoid, right? And you can always validate that by actually dumping the process. So if you just dump a process and you search for patterns, remember the MZARUH that I mentioned earlier? Without surprise, well, we have two instances of it. The reason why we don't have a third one is because the agent itself is actually encrypted in memory at this specific time, right? So that's the expected behavior. That's the whole point of a sleep mask. So million-dollar question, is there a way to have an invisible shellcode within your process? Well, the answer is yes. Here's the trick. It relies on trying to get rid of the final content and the allocated content later on. How can you do that? Well, there's two things. We're going to have a thread that's going to be spawned. So the whole point of having a thread is you have execution in parallel to another flow of code that's running. The whole point is the whole shenanigan of memory copying and execution is going to be inside of that thread, which I call let's have fun for whatever reason. And then inside of your main, you're just going to call that thread. So far, nothing fancy. And then just to be sure, I'm also going to modify those variables to make them global to the class. So I'm sure that there's no copy because there's a bunch of magic going on, especially with C# where you have clone of memory and stuff like that. So if it's inside of a thread and it's not necessarily global, you may end up with an extra copy of code without even knowing. Once again, curiosity, here's the key. Feel free to just dump your process and analyze what you see in memory. You may be extremely surprised of what you'll find in there. So by making them global, it's going to definitely help you, right? And for those of you that know me, I love C. Not the best at writing C, but I love it. So here's the million-dollar solution. There's a specific keyword in C# called fix where you can actually use raw type like byte pointer. So everybody says there's no pointer in C#. Well, technically you can cheat and everything is a pointer live, but that's another story. Point is, you have your main, you call your thread with let's have fun, so you're gonna get your beacon running in memory. Then you're gonna sleep for whatever. I usually put 12 seconds just to be safe to make sure that it's gonna happen. Then you enter this unsafe piece of extremely terrible code. But the point is, you're gonna generate a string. In this case, it's just gonna be the length of whatever the shellcode originally was. And I'm gonna replace this with a bunch of CC. You can just randomize that, be creative, doesn't matter. And now, just for the fun of it, I'm gonna retrieve the raw pointer to the actual data that we created earlier. So PTR is now the raw unmanaged pointer to data, which is the managed environment variable. And what we're going to do is fairly simple. Keep in mind that the thread is running in parallel. At this point, 12 seconds later, well, we definitely have the shellcode in memory. It was copied by the whole framework associated with whatever payload you use. And we move back to let's clean up that memory. It's super simple. All you do is you copy that string back into those two locations. Because at this point, the execution was completed. The beacon itself copied itself somewhere else, so you don't need the original payload. You empty them with this, and you move on with your life. And if you actually check what's going on, extra point, you can also even change back the memory permission, because this is also well known. Read-write executable memory will get you detected depending on whatever product they use. So you can even revert back the permission on the code to typical execute read, which is what you will expect to see, right? And you're done. And if you actually dump that process memory, well, all you're going to find is a bunch of CC. So the beauty of this is there's no trace of your shellcode, because at this point, it was modified in memory. So keep in mind that whatever tools you use, it's always important to make sure that you do your cleanup. And most people don't actually think about that. And memory scanning is getting more and more popular because we're getting more and more creative. So if you don't clean your original clear shellcode after the execution, well, there's no point of using fancy technique. They're just going to find the sample in memory. Simple as that. Keep in mind that, as I mentioned, same can be done in C#, right? MSI is like C. C is also like the human version of assembly. Same goes with C#, right? So you have the opcode associated with a bunch of instructions, which are IL instruction, which is the middleware kind of thing between C# and the engine, and the opcode is what's understood by the runtime environment associated with C#. So we can also technically obfuscate these, right? The beauty of this is there's built-in capability that allow you to actually get the IL code of a method. So I'm not going to go to too much details here, but you can use a sample, like let's say you created your malicious payload, and you're going to get all the IL bytes. The point here is you can actually obfuscate them, right? By extracting all the IL, you can actually, in this case here, use a simple technique like a +3. So every byte is going to be added +3, so it's going to become gibberish, and it's actually not going to point to the original one. The point is you can actually patch the original software. So instead of obfuscating the C# code that you write, you actually obfuscated a layer above and closer to the actual engine execution, and you're going to get that MSIL obfuscated code instead of a typical C#, using random string and AS tricks or anything like that. At this point, the code is not even functional within the binary. And the beauty of it is what you get after that is you actually hunt for your own method that was modified. Here, there's a pattern, so obviously I just need a couple of bytes that are unique enough at the beginning of my modified code. In this case, it's 03, 75, 8A, 03, whatever, this whole thing. And what I'm going to do is I'm going to read my own process memory. I'm going to loop through all the memory until I found that pattern. Knowing that it was +3, well, all I have to do is when I found the actual location is to revert it back to -3, right? So you're using unmanaged functionality within your managed code to modify the managed code back to the original state, if it makes any sense. Hopefully it does-ish. And then the beauty of this is you get to the point where you have your MSIL code back to its original state, and you don't have any C# obfuscation because you're a level above. So no need to use fancy variable shenanigan or trying to bypass AMSI. You don't care. You're just below that, so they're not going to understand any of that shenanigan because it's just going to be a bunch of random bytes, right? But there's something to consider too, and that's something that people tend to oversee a lot, right? That's cool. You know, you obfuscated your stuff. You have plenty of really interesting concept going on. But the thing is, C# actually going to leave a bunch of artifact in your code that people tend to really forget about. One example here is the PDB. It may sound silly, but for those of you that actually do red teaming, you may actually end up being part of non-malicious database just because of the PEB that you use all the time. If you're using the same VM over and over and you have this, you know, random username or anything like that, you may actually be there because by default it's always going to be part of your assembly in .NET. So that's definitely something that you need to consider. There's a lot of tools available for that, but you should always clean that. Another really important thing is you can use all the obfuscation in the world. Every time you actually have a function that are used, even if it's C# or unmanaged function, they're going to end up being unclear in the assembly. So we have an example here where the sample is actually going to do assembly load. And when it performs assembly load, it's going to invoke a specific set of method within the framework, right? So you're going to end up with something like mscorelib, load, invoke, GUID, attribute, debug, all that stuff, which is known pattern, right? So you may actually come up with a super cool evasion technique and be like, but I got detected right away by, you know, MDE or whatever, and maybe wondering why. It's probably because your imports have some well-known pattern and you don't even realize it. That's also something to keep in mind. So if we go back to this kind of code, keep in mind that we modified the MSIL, but we could also technically modify more than that, right? We can get the offset of all of that and make sure that we actually also modify it. So at runtime, it's going to be patched back to the original code, but when you look at it on this, it's just going to be gibberish, right? That's something really important to also consider. It's like, for those of you that are familiar with C, you have the concept of import table. It's pretty much the same, right? There's a lot of product that use your import table to actually create signature. It's the same, right? There's different technique and patterns that you're going to find when you look at malicious code, and this is no exception, right? So make sure that you also assess the final binary to actually get this kind of output. Does it look like something that we know is known to be malicious? If the answer is yes, well, you may have guessed it. You probably have something malicious going on. Same goes with the GUID. There's a GUID associated with your installation. Funny enough, I know cases where legitimate APT group were uncovered because of that. They found that the GUID was used in a malware sample and also a legitimate software because probably the guy forgot about it and he ended up compiling malicious code on this production machine or whatever. So this GUID is also the key. Keep in mind that you either replace it with gibberish or you make sure that you make one that looks legitimate but it's not yours. Especially for red teamers, you probably have one VM, you generate the same code over and over and over. And if you test the same client or your internal red team practice, well, they may end up starting creating rules just based on this GUID associated with your Visual Studio environment, and they're going to detect you. Doesn't matter what you're going to do. They know it's your signature. It's unique per installation. So that's also something to consider. Point is, you can have super complex, fancy code with super advanced technique, but if you forget about those little details, well, you may actually get detected right away. And funny enough, right? If you don't believe me that these are actual use pattern, if you take a look at Microsoft security product in memory, just a quick note on that. If you have the trusted installer privilege, you can do pretty much whatever the hell you want with Microsoft detection product. So you're allowed to actually dump the process memory. And if you look for certain keyword, let's say PDB within the memory, well, obviously it's a bit of a mess though, but you realize that these are some of their patterns that they know to be malicious, right? Of course, some of them are obviously malicious, like QZ miner source release Bitcoin miner.pdb. It's pretty obvious that it's probably a Bitcoin miner, but there's some that may look a bit more subtle, like rubbish DN loader, RC release. It's probably, just another tools, and they realize that this pattern is always there because every time that group or that individual create a malicious sample, well, they forget about the fact that they have this specific user. It's like here for example, job goals release loader. Like, loader can be literally everything, but it was unique enough that they were able to actually make signatures. So back to this kind of code here. Once again, you can come up with some interesting technique. And I've been told that I have 5 minutes left. Thanks you, Martin. You can come up with a really cool technique and realize that they caught you way before they get to your fancy code because you forget about those little details. Another example, release shell code. Just out of question, how many times you think you name something shell code in your life and forget about the fact that you name it shell code? Probably a million times. This is an example. It's in there. They're going to cut you just because of that. Doesn't matter what you did afterward. It's there. So this is something really important to keep in mind, right? At the end of the day, as I mentioned, it's always about being creative and making sure that you check what the code that you create is going to result in your binary, right? This is a typical reflective loader in C#. It's super simple. It's literally 3 lines of code. You can get unmanaged code in memory or whatever .NET assembly. This is something that I love to use. However, the pattern is super known, right? So if you look at your data in your XC, remember earlier we saw the MS-core lib load, append get method, and all of that. It's always going to be there. So you need to actually make sure that you get rid of this. Another thing to keep in mind, right? This is a bit small, but the point is, this is something that I do often too, is heavily obfuscating my code. I have a little tools. If you're interested, I'll be more than happy to share the concept afterward because we're running out of time. But point is, I'm going to use a switch case concept. So it's all automatically generated for me. So it's going to take a function or a method that I provide, and it's going to create this crazy switch case statement. So this code is massive. It's literally the same as this at the end of the day. The only difference is all the gibberish that was added. There's a bunch of check, counter. There's magic going on just to make the code more heavy. However, here's the catch. Doesn't matter how complex it is. You still have the MS-core lib load pattern in there because this specific method has to be called like that. So there's nothing that you can do unless you hide it, which brings me back to something like that, where you definitely want to hide the code, and don't forget to hide what I like to call the import table within your exe when you're dealing with .NET, because patterns are easily detectable there. Another thing that you can do, if you look at the opcode, as I mentioned earlier, this is the opcode, so the equivalent of assembly in C#. The small version is just that, right? The switch case one that I'll show you is this one. It's definitely bigger. So this helps, right? Pattern matching is going to be different, but if you look inside of that, you may come across part of that pattern too. So definitely it's going to make pattern matching much more difficult, but still something that can cause you problems. So obfuscating on top of it will definitely make sure that this pattern is not going to be present in the bigger, more complex function. I guess at the end of the day, I've been saying this for a year. I believe that obfuscation and evasion is really an art. And I think lately in the industry, people are trying to come up with super complex technique. But at the end of the day, sometimes they just forget the root, right? It's like little details will get you caught. So before you're trying to, come up with some complex technique where you scan your own memory, patch MSIL code and all of that, make sure you actually understand what's happening under the hood when you generate a C# payload or just a piece of C. What are the artifacts left in there? And hopefully, well, today achieve the goal of showing you that there's a bunch of little artifacts left in your code. And I guess be creative and enjoy life. And that's it for me. That was fast. 2 minutes left. Wow. Any question for Martin, I guess? Just yell. Perfect.
In 15 minutes is the next talk. Please send your questions to Slido. Thank you.
This, whatever he said. So are we taking question or we're just leaving? Okay, so apparently we're gonna have a Q&A at what time? At 3 something, there's a Q&A. If you have any question, I'll be more than happy to answer them while you guys exit the premise. Hopefully you had a good time. I know I did. Qui te voyait pas? Oups. Ah. J'essaie de dire ton nom. C'était peut-être... je sais pas comment ça... Mon Dieu, c'est bien fou. J'essaie de faire des miracles en peu de temps. Alors, ça se tombe comment? C'est spécial comme formule, tu sais? Ouais, mais je peux pas...
All right. Welcome back. Welcome back to this third talk of the Red Team block. We'll have as a speaker Laurent Desaulniers. He's an amateur in most things, CTF challenge designer, speaker at a few conferences, and also Balenciaga model.
So hi everyone, thank you so much for being here in such a large group. So today I'm going to talk to you about deception for pen testers. First, let me introduce myself. My name is Laurent Desaulniers. I'm the Vice President of Breach Detection and Response at GoSecure. But first and foremost, I am a NorthSec challenge designer. It's my 11th year as a NorthSec organizer, as well as a magician and pickpocket. So today I'm going to talk to you about magic, as well as about pen testing. And the question you should ask yourself is why? Like, why am I here talking to you about pick a card or these type of things? And in truth, my magic improved my pen testing. What I found out was that once you understand how the mind works, how can you capture the attention of someone or make sure they don't look at something you'd like, then suddenly you're better at lying, you're better at deceiving, you're better at crafting the right phishing email that suggests just the right level of stress without being too noisy. So basically today, I'm going to talk about you regarding magic and how it can make all of you better pen testers. And I kind of felt clever thinking about this. But turns out, other people had thought about it before. There's a Freedom of Information Act that you can request in the United States where a famous magician coached the CIA in deception techniques. So if it's good enough for the CIA, I figure it's good enough for us. But let's go even further. Jean-Robert Houdin, also known as Houdini, during the Napoleon Wars, helped Napoleon do propaganda and do psyops using a trick called the heavy light chest. And that was used to convince population that Europeans were better and that magic was real. So if it's good at, if we look at these things, I mean, there's a background where deception and magic intersects. So today I'm going to talk about a few things. I'm going to talk about convincers, suggestion, repeatability, repeatability, repeatability. Don't run if you're not being chased, managing attention, stooges and accomplices. And while it's not exactly something that's about magic, about surveillance detection, how to tail someone, how to surveil people, and common mistakes people do when they're tailing people. All right, so let's go. So the first principle you need to know about magic is that people doubt others but don't doubt themselves. What it means really is, if I tell you I'm a plumber, you might doubt. But if you look at me and you say, oh, he's got the suit, the car, there's a problem with my faucet, I called someone, then you're more than likely to believe that I am the right person. So if I tell you something, you can doubt it. If you deduce it yourself, then you won't be as likely to doubt it. So a convincer really is like a game where I want to give as many hints as possible at what I'm doing here, what I'd like you to do in these type of things, without actually telling you. Because if I tell you, it doesn't work. So that's called a convincer. Of course, if you talk about your convincer, it doesn't work. In magic, you'll never see someone say, look at my thumb, it's a totally normal thumb, I have two. Here's two sides of a thumb, here's a thumb, it's a normal thumb, look at this thumb. Like, that doesn't work. I mean, they're gonna show their hand, but the moment they say it's a normal thumb, of course it's a normal thumb. Like, we all have two, well, most of us. So it's a type of thing that, of course, if you need to say it, then it's not as good as a convincer. And if you had one rule to recall, that's the one. Like, people are better at lying at themselves than are better to, it's much easier to, people don't doubt themselves, but they're likely to doubt others. So when you're crafting phishing, you are much better not to say something, but let them deduce it. Believe that they're smart, more than likely, and hint about things, but give as many hints as possible. Let me give you a few examples. This one I already talked about, the lanyard attack. So if I have a lanyard of, say, EY are famous auditors, and I wear my EY lanyard, it's more likely that people will say, this guy must be an auditor. Of course, I mean, who else carries lanyards or who's crazy enough to collect lanyards? So, of course, in that regard, by having this, I mean, nobody will never, ever only let me get in because I have a lanyard. That doesn't make sense. But it adds credibility and people build on it. But some things are even simpler. And the following attack my team did this year is the very fabled hot dog attack. So, some places, they have like favorite spots and favorite restaurants. So we found where people ate, and in this case were hot dogs, and we purchased the same hot dogs at the same place, and we walked with them as they came back in the office. Now, of course, nobody will ever say, I trust this guy. He has the same hot dog brands as we do. Like, that never happens, right? But the thing is, they might say, I don't know this guy, but he works for us. Obviously, he knows our secret hot dog spot. And it really worked. Like, people find the hot dog attack stupid, but it works. So keep in mind, convincers doesn't need to be fancy or complex. All they need to do is reduce the risk about somebody doubting you because you gave a hint that you're part of the in-group. So lanyards, uniform, way to walk, way to talk are all things that are common as convincers. So convincers are a way to reduce path in your mental mind. Like, when there's a path of possibilities, and convincers are used to remove these paths, remove that perhaps he's an outsider. But what if instead you wanted a person to perform something? If you recall the principle, if I tell you to do something, you can doubt. Whereas if you convince yourself, you're more than likely to do it without understanding that I told you about it. And of course, there's ethics here. But if I say, gee, the dishes are due and we may have visit anytime, I'm not telling anyone to do the dishes. All I'm saying is, dishes are not done yet and we may have visit. The person might be more inclined to do it without me telling that person to do it. You understand the difference? And since the desire or the understanding comes from them, comes from within, then suddenly they're more than likely to do it. So that's the first principle of magic. People are the best liars to themselves. Does that make sense? All right, I'm going a bit fast because we have plenty of examples. Repetition. That's a common thing in magic. First time is exciting. Second time is normal. Third time is routine. Magicians do a thing where, they would show something in their hand, put it in their hand, put it back, put it in their hand, put it back, put it in their hand. Oh, it's empty. Why is that empty? Well, because the first time you were looking at the hand and your brain said, oh, yeah, there's something happening. But nothing happens. I take it coming back. And I put it again. Now your brain says, I didn't get caught the first time. This time is right. But no. This time again was true. And third time, your brain was lulled into a sense of repetition, and then coin is gone. And repetition is a way to build trust, because it's normal. Like, you have a model of awareness, and things that are repetitive are suddenly boring, and your mind erases it. Of course, it's a mechanism to reduce suspicion, as I mentioned. For example, asking for information. You're performing a social engineering attack, you need to know something since important. The first time is abnormal. So suddenly, that's not when you should ask your question. If you want somebody's password, the first time you call them, don't say, hey, what's your password? That won't work. Instead, how about you call and give information, share something non-committal, like there's a meeting about something. Or, the first time is where they have the most attention, is where you should be the most mundane. Second time, you reinforce that model. So again, you're non-committal, you're asking for something that has no impact. And the third time, then you go for the kill. And that's, by creating patterns of 3, it's much, much easier. Let me give you an example. We had to perform I'm really happy about that example, so I'm going to take like 3 minutes. We had to perform phone phishing. And phone phishing is super difficult. One, it can't be automated. Two, depending on the personality of the person, it's difficult. So we had to craft a scenario. Here's the following scenario. Hello, I'm calling regarding a survey regarding your IT services. Do you have a minute for me? One, they will say yes. Two, it's boring. If you're having fun doing social engineering, you are failing. Most people, when they call you, they're not having fun. If you're like, hey, I'm super happy to talk with you. Can I interest you in insurance? Like, it won't work. Those people hate their lives. So be the same, do the same. So I'm calling saying, hey, I'm here for a survey. First question, on a rate from 1 to 10, how happy about the IT support? This is non-committal, like they're gonna answer 7, who cares? Question 2, from a scale of 1 to 10, how happy are you about the material that you're being provided? And then I give an explanation saying, in time of COVID, any items that belong to you were not provided by the IT company, so please disregard these. Whatever, they give you 4, fine. Question 3, from a scale of 1 to 10, how happy are you about your network speed? Whatever they say, interesting. What's your speed? So from the way it's made, the fourth question is not part, it looks like improvised. Like, what's your speed? Interesting. And when people recall the discussion, they will recall the 3 questions, not the, oh, by the way, like it seems like an afterthought. So what's your speed? I don't know, whatever. Oh, you don't know, no problem. Can you go on evil.don'tclickme.hackme.ca/evil.exe? You're gonna run a speed test. And here are the way it worked, why it's so clever. Some people knew that this was wrong. They knew by then that there was a problem. But they had said yes 3 times. They had committed. They had said yes, they gave information, oh, I don't like the background, or my mouse doesn't work, whatever. So they had involvement in the discussion. So once they had their arm in, it was too late to say, oh, I don't feel comfortable downloading your exe. So we created trust, we created repeatability, and at some point, we did interviews, and they said, I knew it was bad. I knew I should not have downloaded that virus, but I did, because it would have been an awkward conversation otherwise. So, and I swear, like, this scenario is using repetition, is using trust, and is using what's called afterthought or side thought, where the important part doesn't look important. And I'm going to talk about it in a minute. That makes sense? All right. Same thing used by politicians and pollsters all the time, the 3 yes rules. If you want somebody to do something, ask 3 questions that will end by a yes. Are you using Windows? Yes. Cool. Do you work at this place? Yes. Amazing. And are you having IT problems? You want a yes. But by creating 3 rules that end by a yes, people are more likely to also start with a yes. Does it work all the time? Of course not. But it really, really works. And politicians and pollsters use it all the time. Some famous German politician in the 1940s was very famous for using this rule. Now, so the whole reason why I started this talk was because of the following situation I'm going to share with you here. The magic principle is called don't run if you're not being chased. And what it means is this. So we're doing an intrusion at a site, and we're saying we're a plumber. And we get caught. There's somebody like challenging us. If I say, I am a 4th generation plumber, my mom was a plumber, she went to the International Plumbing Institute where my father is a copper plumber, I'm such a legit plumber that I named my kid, my dog Gasket, and my first kid is going to be called T-Trap. Well, most people don't talk like that. Most people, when I say, are you a plumber? They're going to say, yes, I'm a plumber. That's it. They're going to talk about the name of their kids or anything. But pen testers oftentimes feel guilt. Deep down, we're good people, and we're told that lying is bad. So since we're feeling guilt and there's risk, we want to over-explain. And that's a common defense mechanism. We all want to be good person. So, like people, of course, naming your kid Gasket is a bit of a stretch, but the idea is still this. Oftentimes, you're going to see, especially pen tester, over-explain. While just saying, I don't know, is such a powerful word. When you're being asked, like, what are you doing here? I don't know. And oftentimes, the people will have to do the processing power on their end. It's like judo. You're using their cognitive power against them. I don't know. Oh, you're here for this. Yes. You know, so, but you need to do a pause. Like, when you do I don't know, stop. People will fill the blank. But these are the type of thing where if you run, if you're being chased, you're going to look, if you're not being chased, you're going to look suspicious. And I've seen this over and over and over in physical pen tests. So again, you must be comfortable and not feel guilt when you're lying. Now, how do you know? How can you avoid feeling guilt? It's easy, like everything else, practice. Next time you're in your taxi, you don't have kids. Talk about your kids. Mine are 2 and 4. Like, don't lie to people who are important or you're gonna see again. That's not gonna work, you know. And like, don't invent things that don't make sense. Like, there's no way I'm gonna be like, oh, I'm an ex-Marine and now I am a Olympian. You know, it won't work. Like, that's not gonna happen. So, but you know, be mundane. You work in an office. Talk about life at the factory was difficult. Or perhaps invent that you're a fax repairman and business doesn't go super well except in hospitals. Or, you know, find something and learn to lie, and you'll find out that people don't care. And it's like a super sad story because we're all unique snowflakes. But when you think about it, most people you'll never encounter again in your life, and they don't care. But you need to practice lying. You need to practice just the right level of information. So, you know, and lie. The taxis are wonderful because they meet people and you'll never meet them again. But you need to learn about lying and understanding that all this over-explaining comes from guilt. Yeah, keep things simple, I'll already explain. Now, managing attention. There's this amazing book. It's difficult to find called Leading with Your Head that explains how the attention model works. Like, there are things that are called active versus passive positions. If I'm talking with you like this, you know I'm interested. You know I'm looking at you. Whereas if I'm like this, you know, I mean, I might be listening or thinking about whatever I'm eating tonight, right? It's just my body language. So the idea is people will care when you care and people won't care when you don't. So if you need to copy a card or something, if you're like this, man, well, of course, there might feel something's worrying, right? Or if you're giving information and you want them to focus on something, look at them. Like, be active in your posture. Whereas if you want someone not to look at something, don't look at it. You know, I've oftentimes seen people copying cards and being like this and looking. Of course people are gonna look where you look. Like, we're humans, we look at people's eyes. So if you want to emphasis on something, look at it. If you want people not looking at it, don't look at it. It appears very obvious, but it's not so obvious after all. Then you need to take in mind what is called the bubble of attention. So, quick question. What is more worrisome? Somebody in your back or somebody in front of you? In the back, yes. You can talk out loud, by the way. I see you, but just in case. So, yes, so people in your back are more worrisome than people in front of you. So obviously, if you want to not be a threat, you should be in front of them. Now, what's more worrisome? Somebody in front of you or somebody inside of, next to you? Next to you is less worrisome than in front, in theory. And what's worse, somebody going toward you or you going toward them? Well, somebody, I am going towards someone, it's less threatening than if that person is going towards me. So when you take that in mind, that if you need to clone a card or pick a pocket, you are much better if you understand that model to be in the right place. My favorite spot are escalators. Because when you're at an escalator, in a non-active position like this, cloning a card, you're not a threat. You're on the side, you're not moving toward them, they are moving toward you, and the fun part about an escalator is they can't go back. So It's pretty nice. Elevators work as well, doorways, but you know, we've all seen the TV series where there's a cloner that like hides behind a guy like this trying to clone a card, and everybody finds it really weird. Try to avoid these things. When you know how people perceive what's around them, by knowing this, just take care of, know the bubble of attention, and know when to attack. Yeah, so yes, I worked super hard to find a Sun Tzu quote, because it's obvious that all cybersecurity conferences should have a Sun Tzu quote. And this one is, the hand concealing the object should be dead to you. So really, if you have something important in your hand, like you have a rubber ducky, and real thing, I got into a high security place where they patted you down, and I had a rubber ducky in my hand. And they did pat me down. I was like, sure, pat me down. And it felt like, I felt like such a spy, but in the end, I just stopped looking at it, and they didn't care. Oh, by the way, if you're breaking into high security place, they're gonna look for cell phones and cameras. You know you're allowed to have decoys, right? And they never think about it. You know, they're gonna say, do you have a laptop? Say yes. You're allowed to have 2 laptops. They don't know about it. And decoys work very, very, very well, by the way. And if you have cheap laptops, because oftentimes they're gonna expect you to come back to get it, so like find the most broken, super dated laptop. I'm a marketplace guy, and like leave that laptop, and they'll know you will come back to get it because it's an expensive item, and then you're free to roam. So when you're breaking into things, think about having decoys. Anyway, that's a side note. Active versus relaxed state. I just want to explain again that if it's important to you, you should be active. And it's not important to you, you should be passive. And use the attention model to exactly know when to attack. Actually, it should be the opposite. You're doing something at that point, well, then you should be in a relaxed state of mind. You should be in a relaxed body, because, of course, if you're like this, well, people are going to feel stressed. And it's more about position, words, tone of voice, and all these things. There's this amazing book called Psychological Subtleties by Banachek, who is, you can read all about this, or the Leading with Your Mind by Gary Kurtz that are, like, it's only this. As a side note, Gary Kurtz was a dancer before being a magician, so he's an expert at the body, and it's like a 300 pages book about all the subtleties of position and how to use your hand to convey some things. It's really nice. Stooges and accomplices. So, spoiler, in magic, sometimes we have things called stooges, accomplices. And what an accomplice is somebody who's with your team and that whoever you're trying to con doesn't know. The first thing you should, in magic, they always do is say, we've never met, we've never seen one another. Of course, the accomplice is expected to say no. But the thing is, why are they all saying we've never met, we didn't know one another? Well, because 2 people build trust. So if you're able to have an accomplice, then it's amazing. But accomplices only work as long as it's not obvious you know one another. So if you say, hey, how are you? Nice meeting you, then suddenly you're not 2 team of 1, but 1 team of 2, and then you can't leverage accomplices. Now, in what kind of pen testing you use accomplices, right? Because of course, if your client lets you in, it's easy. But say you're able to get in once using 1 person, then you can privilege escalate by suddenly becoming an internal employee and then opening the door for somebody else saying, hey, you're a new person, by all means, register. So now you're able to bring your own team inside the premise because you're now an insider and you're enforcing the rules of having people sign in, and since you're there, you can even request for a badge. So by being an accomplice, it only works if it's obvious that you're not working with the person. So that's called an accomplice. It's very used in magic. But there's something much more cool in magic that is not well known called stooges. And stooges are accomplices who don't know they are accomplices. And this is really nice. And let me give you an example, and I'll talk about the next few slides. I came into a pen test and say I'm here for the audit. Now, the first person expected me to be an auditor. So that person brought me to the auditors. And now, that person said he's here, he wanted to tell that I was here for the audit. But the auditors really knows that I'm not, that they don't have an ongoing audit, right? So I'm kind of stuck. What do you do in these cases? There's this amazing magic principle that you can use called double talk. And what double talk is when you're saying something and both sides understand something different. When I'm saying I'm here for the audit, the person at the reception hears I'm here as an auditor. Whereas the auditor believes that I'm here to be audited. I'm using the same words. I'm saying I'm here for the audit, but both sides of the people hearing hear something different, or they understand something different. Does that make sense? And it's an amazingly powerful tool. I'm giving you a very, very simple example about audits, but when you can have somebody on the inside understand something, and that person can now be your messenger about your truth to somebody else, then you're leveraging their trust in order to get in. So that's something super useful, and it's called double talk. Now, unless you're exceedingly witty, it's very rare that we see people being able to do double talk like this. It requires some practice, but it's a very, very nice tool in that regard. Now, I have like 4 more minutes, and I want to talk to you about surveillance, because recently I've been privy to people doing surveillance, so tailing people, and I want to give you a very, very good example. What is wrong with this picture? No one? Well, first, yes, people doing this. Now, if you ever have to do surveillance, please know that you don't need to do this. In movies, they do because they want them to see it, but you don't need to do this. Oftentimes, you can just talk and it'll work. So, and it's very obvious. When you see people being trained at surveillance, they will all have the reflex of doing this. There's another problem with this picture. What is it? Yes, exactly. There's this little, but earpiece. You don't need an earpiece. Like now, the earpiece is so small, it goes inside the ear, and there's an induction loop in your collar, so there's no wire, it's just like radio. But more than this, again, in movies, they use cell phones and so on, but you can't always use your cell phone. If you need to talk to someone in surveillance, there's something called a press cell, or a PTT switch, press to touch. And the way that it works, roughly, is since you can't talk, you need to have an operator asking questions. So oftentimes, 3 beeps will ask me a question. So I have the press cell in my hand. It's like a little beige-shaped button, basically. And I'm going to press 3 times to say, ask me a question. And the operator will say, is the target moving? I'll press 1 for yes. Is the target going west? I'm going to press twice for no. Then east, twice for no. Then north, yes. And all these things. So it's not like in the movies, and people need to be super worried about surveillance. The way they're doing it is really bad, and you're gonna see pros doing something like this. But it still is about magic. If you care about it, and if you look at it, people will look at it. So now, if ever you're lucky enough to do surveillance, it's really boring work, by the way, just relax and don't touch your earpiece and behave like normal. There's lots of things. I'm out of time, so I'm not going to talk about clothing and techniques and counter-surveillance. Talk to me around a beer if you'd like. But it's something you should need to know that in the movies, it's totally wrong. Yeah, I said this. And references, finally, the CIA Manual to Deception. This is something the CIA wrote. Well, with magician, leading with your mind, I talked about it before. Psychological subtleties. A Sleight of Mind, it's amazing. It's like neuroscientists looking at deception. And the book Influence by Robert B. Cialdini, it was a psychologist who wrote about how influence works. It's a really, really good book. Thank you so much for your time. You've been great. Have a nice day.
Thank you, Laurent. It was awesome.
Pleasure.
So last call for the questions on Slido, if you have time. And after that, we'll be doing the Q&A.
C'était niaiseux, mais si c'est stupide, ça marche.
welcome back to the Q&A of the red team block. I hope you enjoyed the afternoon. I personally really appreciate it. So let's start with a round of applause for our speakers. So, by the way, I have had a big one question on Slido, so it's going to be all my personal questions that I have received no feedback from you this week. But anyway, it's going to be...
That's not true.
Okay. A few feedback. And we'll start with the easy ones. So let's just start with a basic question. We had a talk by Guillaume on guardrails. I really appreciate this talk. I really appreciate guardrails. I mean, it's a very interesting topic when you develop malware. What do you see what do you see as a challenge in 2023 for EDR evasion from the guardrail point of view?
For the guardrail point of view.
Well, anyway,
Okay.
whatever the point of view, but...
From my perspective and my knowledge, in 2023, guardrails are not really detected as a behavior. So I don't know any EDR that see a process looking at the user, the domain variable of the computer and say, hey, this is a guardrail. Obviously, let's block the process. So I don't think it's a problem right now, but it might be in the future.
Okay. Because I saw a trend between the talks of Guillaume and Charles. You two modify your code, modify your malware, and it really becomes like a bit weird. And I have had some challenge evading EDR by just adding piece of layers, things like that. So same question for you, Charles. Do you see your techniques not work in 1 or 2 years?
Well, I guess it always depends how you implement your stuff, right? I always trying to be as generic as possible, but I'm a bit of an idiot, so I shared those tricks online with a bunch of people, so they're not really a secret anymore. However, I guess it's always about creativity, right? This is something that I added to most of my talk. You just have to be creative. Sometimes you just go in the shower and you think about some weird things and you come up with some ideas, right? At the end of the day, EDR cannot track everything. It's like hooking or kernel callback or all of that. At the end of the day, they cannot hook everything. They cannot have callback everywhere because it's just going to make your system unusable. So you always have to play the catch and mouse game with them. And at the end of the day, it's part of the job, right? Being creative and always coming up with new solutions. So they're going to improve. We're going to improve. I made a talk 6-7 months ago at ACFest about machine learning. For those of you that attended that talk, I was always air quoting machine learning because I don't know anything about machine learning, but I know for a fact that they're definitely not using machine learning based on what I presented. You know, typical super simple evasion techniques still work, and they should be able to detect that with machine learning. So we're definitely not there yet, I guess, from my point of view, which have no value.
If I may add, I talked yesterday with some detection engineers, and they talked to me about one indicator that I see will be a challenge in the future, is saying like this binary is only present on 2 of your hosts. Like we've only encountered this on 2 hosts, or it's never been seen before on the internet except there. That type of intel is going to be a real challenge. Much more, obfuscation at the EDR level is there, I think, due to the risk of false positive and so on, this is going to be, there's plenty of years and years and years, and these people are at the forefront of it. But when you were attacking human analysts, these type of metrics saying, in your 10,000 hosts, this binary is only present twice, that's something you should look at. And this is something that in the future, will be much more difficult to evade.
And if I can add to that, that's why nowadays DLL sideloading is so popular, because if you have a legitimate process, have a DLL being sideloaded, and if you do an error afterwards, the alert will come from the signed DLL, which is found on like thousands of systems worldwide. So
the first investigation step will see a legit binary.
And if I may add regarding this, it's super cool. They can technically detect side loading if the DLL loader is not signed. However, if you look at .NET, you have the concept of app domain, which allow you to actually load a DLL without actually side loading it, and doesn't have to be signed. So for every problem, there's a solution, literally. But yes, side loading is definitely cool. This is something that I've done in phishing. You use an actual legitimate Microsoft signed binary that you know supports some side loading, so you just ship the executable that is signed and your DLL, so you bypass mark of the web, smart screen, and all of that, and you get your code execution through that actual binary. So it's, once again, just about being creative.
But thanks for the answers. I'll talk now about deception. I really like your talk, Laurent, about tips and tricks and the link between magic and deception. I guess everyone knows that deception is a real topic in our field. You can put fake systems to detect red teamers, for example, and of course, real threats. Have you think about this topic? Do you think magic can be used to, is there a way to detect threats with deception?
Oh yes, absolutely. So I am also doing purple teaming and more days now incident response, and we do exactly these type of things. Of course, there's all the common techniques, have a password in GPP, a honey token, inject creds in RAM that don't work, but look at it. Look at files. There's all of these things that are fairly common, but there are ways to cheat. There are ways to have files with beacons. And now, if you're using Canary and all these things are well known, but as you know, most doc files are an XML file inside, and if you have an external DTD, it can call you. There's lots of things you can do to hint people about doing these things or these things. So yes, deception works it's a tool, so it can be used both for attack and defense, but there's been such a massive improvement the past few years in honey tokens and these steps. It really changed the layout of the way we do red teaming. Myself, I tried first, I'm not technical, so I oftentimes don't rely on these
You're an amateur, right?
Exactly, yes. So I don't rely on these advanced techniques. I mostly go to people and do stupid things like asking for the files or, and there's no EDR for humans, right? So, yet.
Awesome. No?
Well, just maybe a take on deception, but from an offensive perspective. For those of you that are familiar with Lulbin, you may have probably heard of MSBuild, which allow you to run an XML file where you have embedded C#, right? So Microsoft response was to actually start to use AMSI within that file to actually detect malice, right? And one day was like, hey, this is XML, right? Why not just using entity to obfuscate the whole thing? So now what I use is XML entities to actually have my payload encoded using HTML entities, but nobody looks for that because right now MSI is only going to look at the C# part of this. So it's about deceiving the people that are chasing you, right? So put your code somewhere where it's not popular or where they're not looking at, and that way you're always going to come up with new technique. I've been using this for probably like a year and a half, and Microsoft doesn't care.
But it's a technique you've been using for a while now. I mean,
yes,
people who are on your Discord know about this for a while.
Because I share all my little secret with the world.
One similar technique that I share, and some people know about it, is oftentimes you can use your target's website as a CNC. So think about, for example, a website that has a review field. Then you can craft malware that's going to read in the review the commands, and then push the output as an answer that reviewing the item. So when the SOC is looking at the C2, they're not looking at some weird website with an unknown domain or with something else. What they're looking at is your internal computer visiting your main website. There's some beaconing and so on, but leveraging trust and deceiving these. So you're not fooling systems, you're fooling the analyst looking at a system saying, oh, this is fine. And that's, again, where deception is useful.
Yeah, and on that note, thanks for Google to create the .zip TLD. That was a terrible idea. I think like all the domain that were registered so far are definitely malicious. Like
Yes.
none of them are legitimate. That was the dumbest idea ever.
I agree.
I think it's an amazing idea. There should be more. Like, I'm a proponent for PHP 5. I think we should, industry should use more PHP 5.
Definitely.
And like, you know, I think that's a wonderful idea. As a red teamer, I'm all for that.
Yeah, definitely, but I don't even understand what was the point of doing this. Like, legitimately.
According to the blog, they said that .zip is more secure.
Right.
Let's
According
change
to who?
topic. We were starting to receive questions. Thanks, guys. What's the most important difference between an okay red team and an awesome red team?
The report.
So
But that's true. At the end of the day, you said, what's the difference between an okay red team and an awesome red team? And I believe that the report really does matter. You can be the best hacker in the world. If you cannot provide a decent report, it has no value, right? And we tend to overestimate the fact that we're highly technical, and the people that are going to read the report have no clue what we're doing for a living, right? So you can have this super crazy chain of exploit that lead to whatever. At the end of the day, they don't care. They don't know what a certificate server is and all of that. So it really depends on how you actually provide the result to the customer, right? I've seen cases where they didn't find that much, but it was well written and people still see the value in there, right? So I guess from my perspective, it's really whatever you deliver to the client.
For me, a good red team gets caught. By that I mean, once you've achieved your objective, as a red teamer, you should increase the noise level in a way to get caught. Because you want to give feedback on, did they catch you, and then did they take the right decision? Oftentimes, we have people saying, oh yeah, it's just malware. AV cleaned it, thanks, done. But malwares are not like shrooms. They don't grow like, if there's malware on your host, somebody put it there and you should investigate. And so oftentimes I think great red team make the blue team work.
Definitely. And I think a lot of red teamers are scared to be caught, but at the end of the day, as you pointed out, it's because someone did something great. At the end of the day, we're not invisible to EDRs and stuff like that. It's just that I think EDRs are not ready yet in the sense that everything is an event, but nobody looks at events, right? They should find a way to make them more useful, easier to query or whatever, but it's impossible to run something without existing. You're going to leave a trace at some point, and they just need to get better in that sense, but I think they're just not interested yet.
And Guillaume, do you have an opinion on that?
Yeah, so one other important aspect is to not spend half of the project on the external part, because if you don't succeed, you don't provide any value to the client. So it's important to have clear check mark when you switch phase to the assume breach or the detect and notify phase.
Awesome answers. I really agree with what you said. I will surf on a few ingredients here. Let's talk about prioritization. So you set up a red team, you prepare your chain, you write your malware, you write awesome stuff, you take all the awesome tricks. How do you make sure that your attack chain, your attack scenario will provide most value to your customers?
I guess, go ahead.
Well, first you need to make sure that it's not detected immediately, because else you won't provide any value. If the clients hire a red team and you don't modify anything, you send your payload, it's detected, the client gets no value. So my point of view is that try to recon, try to find what's their SIM, their EDR, their configuration, mimic it in the internal environment, and when you're 100% sure that it's bypassing it, start your campaign, and the value will come after that.
Sometimes we just called it the white cell. We're saying, hey, white cell, we're going to run this malware. Can you run it just to make sure it's fine? And so we know for sure at that point that it's all right. I mean, is it cheating? Well, yes, but that's the best way to provide value. So sometimes we just straight up call the client, say, you want a red team? Cool. Make sure this runs on your system. Run this, it's totally fine, we swear. Pinky swear. And that's it.
And I guess client also need to understand that we're limited in time and budget. We are limited, so sometimes, yes, of course, if you give me 6 months, I'll come up with something more exotic. But at the end of the day, it's important that they understand that. Also, if you have an accomplice, make sure that they understand what they have to do. Looking at you, Martin. But yeah, so it's important that everybody's in the loop to actually truly understand what's going to happen. How many times I had to actually educate client on what an actual red team is, right? It's a buzzword that is used on every recipe. At the end of the day, it's more than that, right? As I kind of briefly touched on my talk, it's always about also detecting your capability of detection and how you can actually find a path to crown jewels, right? It's not about, here's a list of thousands of vulnerability without any context. So they need to understand that we're not going to give them like a result, like a Nessus scan kind of thing, right? And there's a lot of, company, businesses, and vendors. Like the new thing that I see often is automated red team. I still don't really understand what it is, because if you ask them, it's like a scan, but they actually exploit it. So it's an internal test, but from my perspective. But at the end of the day, it's an industry that generates probably billions of dollars, so everybody's trying to get a piece of the pie. But I'm going to fight hard to make sure that people understand what is my vision of a red team. And fun fact, I was working at TrustWave years ago, and they're based out of the UK mostly, and a red team in UK is really different than what we consider red team, like what I call now American red team. American red team is what we're used to. UK is more about the modern attack framework and cases, specific cases. They don't, tell the story like we do in America. So it was really different, but for them, that's the reality of what a red team is. So you also have to adapt with your actual crowd.
I guess they use the Tiber EU framework.
Yeah, all kind of stuff. But that's just the reality. And they also have like Crest that push their agenda and all of that. So, everybody have different standards.
Let's surf on that. Do you think they have more maturity than North America?
It's different. It's just, validating and control is good, but sometimes you may miss the whole picture, right? Typical, patch all my system, but what about your certificate server? Did you actually make sure that your server properly is configured? Does your template actually well secured? So it can be up to date, fully patched, but if you have terrible template, it's not going to do anything.
Sorry. Yeah.
We have people doing a wave in front, so
awesome.
Don't worry about it.
Yeah, I'm not sure what's going on with Mr. Marcel. He actually flew from like super far just to be there and see Laurent, so you deserve a round of applause.
Yeah, Jonathan. Oh shit. Okay. Next one.
What about you, Martin? What do you think about all of this?
All of this. Yeah, thanks. well, first of all, for the crowd, so I run an internal red team, so it's completely different. We have our own team. The dynamic is different, the objective is different, and that's the base of the question about prioritization, because I ask this question every day. Because once we use tradecraft, we need to rebuild new ones because it's always brûlé. Burned. Right.
Well, I guess that's a question for you at this point. As an internal red teamer, since you're already the same guy that do the same kind of stuff over and over, you have to adapt, right? Because like as I mentioned earlier, I don't know if you attend my talk, but like the signature of your compiler and stuff like that, at some point they may actually realize, oh yeah, we know it's Martin again, he's part of the red team. So as a consultant that just, do my thing and leave, it's slightly different than you, right? So how do you actually adapt to that kind of, they know we're coming, you also have insider knowledge kind of thing, so.
Oh, it's quite a challenge, yes. But today I will say that we have a very, very good collaboration with the blue team, and I'm a big purple fan. Most of our activities are purple-based, and sometimes we do what we call adversary simulation, just to do a little surprise and have them work at night a few weeks a year. But no, it needs to be collaborative. And why do you build a red team in a company? Well, to train, to create opportunities, to improve, to challenge assumptions. So it's all blue driven. So that's how I would answer your question.
Fair enough.
Let's talk about AI. Do you believe that EDR and antivirus solution will leverage AI to the point that the current state of the obfuscation and evasion will not be enough to bypass them?
So, the people who are pushing AI are the same people who pushed the metaverse last year, NFTs the years before, and so
is AI a thing? Well, yeah, it's cool. You can make pretty cat pictures and you can chat and even sometimes get a right answer. So is that something that's going to be leveraged? Well, yeah, perhaps. But I think, is the metaverse still a thing? Well, not really. Do we care about NFT? Not
do.
really. So, I mean, next year we're gonna talk about AI, like this really cool concept that happened once. But don't worry, like there was some point where PKI was a solution in 2000, then 2002 was the year of the WAF, and and all these things. So next gen AV was 2006. So every year we come with a new concept to buy stuff. So it's gonna be great at selling. Like lots of sales people are gonna sell lots of cool product, and they're gonna make lots of money. And many industries gonna have a new box with AI powered on it. And it's going to be as useful as the previous one. And yeah, that's it.
If I can add to that, I think AI will definitely be an accelerator. If you were at my presentation, the Strul like a king proof of concept, it took me like several weeks to understand what was going on. And when ChatGPT came out, I just provided the code and it was perfect. It was explaining to me what was going on. So I don't think it will break our payload immediately, but it can help Blue Team investigate faster.
I'm a bit on Laurent's side on this one. I guess it's going to help me write phishing campaign without having typos and grammatical error. I'm not going to have to reach out to my boss to QA my phishing campaign. But apart from that, I think there's a misconception about AI about the fact that it has learning capability. It can only learn what it knows about to a certain extent. So if you ask ChatGPT to come up with a new attack vector that was never seen before, good luck, right? It probably have some value. It's just, I guess, I don't know how to use computers, so I don't really know how to log into ChatGPT. So I'm probably going to have to write my code myself.
And it's all about the data set.
Yes.
I mean, the internet is dumb. Like,
Yes.
look at it. There's anti-vax things. There's like lots of cats, a picture of cats. But like, think about it. Like, OpenAI is based on the internet we all know and use. So like, the Facebook post of your grandma, it's in there, and that's what intelligence is. So think about this next time you're using ChatGPT.
Thank you, Laurent.
And I think as far as I know, ChatGPT is basically a prompt and a UI on top of OpenAI. So still not sure how this was acquired by Microsoft and not OpenAI, but I don't know much about this.
I don't know.
It's probably written in Ruby or something like that. Or Perl, maybe Perl. Any Perl dev in there?
Olivier is not here today, so no.
Let's go for Rust.
Rust? Yeah, speaking of that, for those of you that love Windows kernel, latest beta have a part that was written in Rust. That's going to be really interesting. You're going to have to relearn everything you know about Windows. That's going to be interesting from a red team perspective, evasion perspective. Really looking forward to it. You can already take a peek at it if you want. It's quite nice. There's some drivers that are already in there written in Rust.
We have only 7 minutes left. Sorry. So let's. I mean, you would like to share some failed stories, red team stories?
My life is a failure.
No. Don't say that. Yeah, some story, something interesting that you'd like to share.
I can go ahead if you want. So
Sure.
my fastest physical intrusion to impact was like 5 minutes because from the outside, I tailgated, followed someone upstairs, went into a conference room, plugged the internet cable from the VoIP phone, looked what was my DNS server, and the DNS server was vulnerable to MS-17.010.
Nice.
Survived 5 minutes from outside to domain admin. That was pretty fast. It was in 2017.
That's actually really fast. Our record is 9 minutes, so 5 is really blazingly fast. One fail I had was I was calling tech support saying I was someone, and the guy answered, "That's me." And I don't know, I'll be honest, I don't know how you can recover from that. I'm like, oh, sorry, wrong number, and you hang up. Like, honestly, if ever you have, what to answer from this, let me know. But right, that was my yeah.
But maybe a funny one to a certain extent. So I was working with this client, and we had an accomplice that was told to actually click on the phishing. That was part of the scenario. They know that this person will get phished, right? And for some reason, the person had all the information, the subject of the email and all of that, and they still reported the email. So I was like, well, that went well. And funny enough, it was reviewed by the security team, and it was actually marked as safe. So I was like, that ended up being pretty decent. That was a funny one I found.
Oh, damn. Okay. Something else? I'm just checking my awesome questions. I'm sure you have another one, Laura.
Oh,
You're
well,
good. You're good
sadly,
at it.
there's plenty of fails. It's more a pen test than a red team, but we had a client who made a typo in their IP range, and they had the same, like the other company had the same mission. Like they were building widgets, and the other one was called the widget factory or something like this. And they had the Grafana endpoint, we pivoted, we hacked their mainframe, dumped all the credit cards, and the client was copied every step saying, that's fine, that's great, continue. And at the end, once we sent like the log of like, we had credit cards and so on, it's, oh, but that's not us. And then you were like, what should we do? And we even called the other client, say, hey client, we apologize. We mistakenly hacked your mainframe from the outside. I apologize. You get a free pen test. Congrats, here's a report. And the client was like, no, I don't want to talk to vendor. But yeah, but we went out. I don't want to talk to vendor. Don't call me again. And so as far as I know, the client is still vulnerable to this day because we've never been able to reach them right now.
All right. Let's end with
Let's sum it up.
a philosophical one. What do you wish for the cybersecurity industry? What do you think is their next best move from your perspective as simulating adversaries every day?
We talked about it earlier, but Oni tokens, Oni threads, I find them very effective. When I do a red teaming, I'm becoming automatically paranoid if I find easy credentials on the system. I just don't want to look at it. So I think it's really strong to use Oni stuff.
For me, browser is the new LSAS. Everything is in the cloud. You can have 20 MFA factor. I don't care. I'm just going to steal your cookie. You don't have to touch LSAS.
My answer is going to be boring, but for me, one thing we're seeing more and more is involvement of management in red teaming. So suddenly it's not just get domain admin, but test our processes and like do some actual business risk. In the past, we've stolen a building, if I may say. Like we've found the building certificate of the ownership sent to the city of Montreal, and we took ownership of a building. That was a pretty big business risk and not IT related. So I think more and more, and you've said it, Martin, more and more as management are involved, red teaming are much more tailored to the business need of the client, and they're much more what the business needs, and it's not just about getting domain admin. And this is something I'm really, really happy, and internal red teaming is something we're seeing more and more that I think brings a lot to this.
Thank you, Laura. I think we'll. Oh.
No, I was just about to say, pass the hash is dead, long live red teaming. And pass the hash is not dead.
No, really not.
Not yet. All right, well, thanks, guys. It was amazing. Amazing talk this afternoon. Thank you very much. Let's have a last round of applause. We'll take a 15 minutes break, and after that, there's another talk. Thank you.
All right. So the evening is not over. So we have another talk by Ashley Manraj. He's a CTO at Pivotal Technologies, where he spearheads technology and development methodology around event-driven, asynchronous, Go gRPC microservices in the back end. He didn't make that easy for me. So in the front end, they're developing with Flutter across a platform using the block pattern to interact with our backends in gRPC and gRPC Web. You'll hear a lot about gRPC in the next 30 minutes. And I have to say, I know Ashley since university, so it's a great pleasure to see you on the stage right now.
Thank you.
All right, so...
Thanks. So I'm representing today Pivotal Technologies with a subject gRPC with less effort. The less effort comes after having done the transformation to be even sourced and having done the work in order to simplify it. But if you don't, we're going to go through the steps that get us there. So first, I was doing applicative pen testing. I was doing security review for banks before. Now I'm more in the building and trying to build more securely things. And we're doing a bit of branding. We call it Infinite Enterprise, but it's basically the way to have pure containers everywhere, the deployment methodology to secure everything from small to medium-sized companies and do digital transformation. And so we try to do secure patterns, develop libraries for infrastructure as code for your cloud infrastructure, for some of your on-premise. But right now it's very focused on GCP. And we try to simplify maintenance of microservices and maintain huge fleets of microservices for our clients, but also try to develop them faster or transform those groups faster. So you can see on top, our website is Pivotal Tech, and our GitHub is Pivotal-Tech. Some of the technologies we use very quickly, so because it was mentioned before, we only use Flutter, or mostly Flutter for front-end, for all platforms, and we've been using web for almost as long as it's been available, almost 3 years. We try to maintain our own CI because our CI and CD are very custom. So we use mostly Tecton and some GitHub Actions when you need root level privileges when you run your CI. Bitrise for mobile, otherwise everything is in Bash for that part. Continuous deployment is Google PubSub in order to deploy in network restricted environments using Argo, the Argo stack before, and now we have our custom deployer that builds on top of Argo. For the deployment, heavy users of Terraform Cloud and Terraform, users of Vault and HashiCorp tools, mainly Kubernetes, sometimes Google Cloud Run, and the technologies now is mostly Istio for service mesh, egress gateway, and the ORI stack for authentication. And last but not least, event store, mostly for event sourcing. If you don't know what event sourcing is, we're going to talk about it a bit later. And those libraries do the heavy lifting for us to transform, because if we don't have libraries, you can't actually go faster. So the OWASP Top 10 for 2023 is mostly about broken object level authorization, which is an authorization problem. I'm going to define it a bit later. Broken authentication, so it means knowing who your users are, which differentiates authentication from authorization. Authorization is also the topic, but at the object level property and number 3. Unrestricted resource consumption, mostly DOS and DDoS, not going to be talked by me in this talk. And the 5th subject as well will be addressed by the infrastructure automation during the talk. So it's 1, 2, 3, and 5 of the top 10. The objective is to show how we secure directly from Protobuf and ensure that infrastructure is secure by default or non-functioning. So we try to have either functioning services and secure or non-functioning at all. So that's what we try to do, because otherwise, if you have to review your code every time you deliver hundreds of endpoints, you wouldn't deliver fast. So now it's kind of, bear with me, it's the template for some of our large-scale transformations. So as you can see here, there's a white label project. It can be one or more Kubernetes projects, but mostly it's like the front end, but also front-end and customization of the endpoints. So it gets into a Kubernetes cluster with an istio ingress gateway. It goes to an authentication service, here represented by Ori of Keeper for the white label. And then it talks in gRPC web through a translation layer of istio ingress to a proxy. And through that proxy, it goes to an internal gateway, and from the internal gateway to a core. Why do we do it like that? It's because we've automated authorization, and because you have automated authorization, it's simpler to have less endpoints, but more closely maintain and manage them for your clients. Because if you don't have that automated authorization, you leave developers to do it, it's more secure to develop one set of endpoints per white label, and that's what we've seen a lot of our competitors and others do when they don't have their built-in authorization. But once you do have a core for which you can control authorization very tightly and do just the customization needed for some of the white labels, it's more efficient to have many white labels in front and then have a gigantic distributed microservice core for the core. And the core retakes the same logic as mentioned before, except we're using a gRPC interceptor directly at the microservice level, and it's templated in order to be always there, or the service wouldn't be deployed. And it goes to an authorization service that does rule expansion for us, and then finally to an authorization engine behind. The roots, as I'm mentioning in the text here, you're much better off defining completely new rules for your HTTP2, HTTP3 routes, whether it's cloud or on-premise. The reason being, there's a huge new attack vector mentioned by James Kettle from the group, which is HTTP2 request smuggling or HTTP2 downgrade. So if you're on-premise, don't share your load balancers for HTTP1 workloads and HTTP2 workloads. Define completely new endpoints for it, because to my knowledge, it becomes a lot harder at your different load balancers to be managing correctly. You're at heavy risk of either smuggling or HTTP2 downgrade, or of a more complex problem related to caching. So we recommend to really separate those two types of routes, whether on cloud or on-premise, not to share any HTTP2 or HTTP3. And the last thing from experience, when you're using those new protocols, get ready to patch everything in your critical path, which means your cloud configurations to be regularly updated, whether you're using Google Cloud Load Balancer or AWS Cloud Load Balancer or other large cloud providers in order to do your DDoS protection, your Kubernetes cluster, your Istio ingress, keep them at least unstable, your Ori of Keeper, everything that is in the critical path, including the proxy, has to be regularly updated, because if you have a vulnerability, the chain is so long that it has to be able to be patched quickly. So if you get into those new things, IAC is mandatory, and doing things fast is also really necessary. So now let's get into one simple service. Why do I say that it's simple? Because there's only one endpoint, and the endpoint is very simple. It's a simple read. The logic here, why we're using Proto and talking about Proto for security, is not, as you can see here, not only about speed, because people talk about Proto a lot for speed, but it's about the IDL and the fact that you can template directly from the code CRDs for the deployment of your security, so that your security is automated directly from the Proto level. Your Protos are compiled and then are deployed through your CD at related to the different configurations that we see here for authentication, and under for authorization, and the first one being for the white label. So when we go back to this schema, you have the off-keeper config here for the white label, and a second off-keeper config here for the core. And you can see here the config for the white label. As you can see here, it's white label player with authenticators player GWT. And the name of the endpoint is get user wallet and get user wallet response. But at the core level, you can see that it transforms into get player wallet response and get player request. So on that proxy, you can transform the calls and modify them a bit without the white label knowing that they're actually using another interface. So that's one of the big advantages as well of having two different sets of configuration and security. You have like basically two levels of control, and as well, the aspect that we really want to talk about here, it's a simple wallet with a requester ID and a player ID, and authorization, if I haven't mentioned it before, it's knowing what the person should have access to or who it is. The requester being the person requesting for the asset, and the player ID is who is he requesting it for. So knowing if a requester is allowed to request for the player ID is what we solve for the authorization. So our custom option here that you can see is made for authentication purposes to validate the JOT. So here it's X1 platform for the core, and the other one that we saw previously is for the white label, and the authorization is evaluated for now for us on the core. It can also be evaluated on the user, on the white label end, but the validations didn't completely make sense because we're doing absolutely the same checks twice. So we ended up doing more on the core and add another level of platform check on the core. And so you can see here a custom structure with a player and the player ID, and using a permission as player viewer on the requester, sorry, I inverted. The requester ID is a player viewer on the protofield player ID. And so from this authorization check, we make sure directly by reading our RPC that there's a validation of player viewer needed in order to access that wallet on the core. So in order to summarize, the big objective here is to delegate a lot of the security to be templated directly from the protos, use custom annotations to drive at each layer of the interfaces. So as soon as we patch or upgrade any interface, the security is deducted automatically at different levels of deployment, and you don't have to maintain as much once it is built. The problem, again, being you have to build it or find someone who helps you get through that transition of supporting the templates at the different levels. And so we're going to get now into the templated value that is generated. I won't bore you guys too much, but for the white label, it has, again, the required scope, the audiences, the issuers, but more interestingly, the URL is automatically templated and generated directly from the proto. So as a user or a developer, you generate your proto, and all the security is deployed for you, but your authorization is not. Your authorization requires a few other things that will be added by infrastructure later on in order to make it available. That's for the white label, and we're going to get rapidly into the core. As you can see, it's very similar. It's also templated. The infrastructure generates the URLs for it. We're using Hydra from Ori in order to manage it, and we're using the different scopes. And again, the developer doesn't have to type any of that. Most of that is generated directly from the options here, plus deployment manifests in order to enrich the authenticator's name here, platform GWT, and here, player GWT, so the template knows to look for those two fields in order to enrich it for automatic deployment. So how do we enforce at the final microservice that the interceptor will always be there? So otherwise, what's the point of doing all of this if it wasn't automatic? So we're using templated Go and code generation in order to enforce that all developers are following our code base and our methodology. So it goes from here, the core interceptor, to databases, to external services, to mounted services, to shared secrets, in order to patch hundreds or thousands of microservices directly by patching a code gen. So we can see here that the unary server interceptor is present. We have a value to remove the authorization if need be. So there's a bypass that is in the code, but it's not available in config, just available for the developers in their local Kubernetes for the authorization while they're working, because if they don't have the entire flow, they can't work if we don't add the authorization engines that come later on. But I'm going to talk about how we actually add those authorizations. So that's just to show that you can have an enforcement at infrastructure level in the microservices by controlling tightly the code of those microservices before they get to the authorization. And here we have the config that goes along the service that we saw earlier with the player viewer. This is a syntax from Google from their white paper from 2018 called Zanzibar. That spec was described in the white paper, but the code is not open source. So we implemented the entire spec in 2020. As you can see here, the description is basically, when you read it, it's made to expand upon the list and expand the user sets in order to understand what's happening. So I'm going to try to go slowly with you guys so you understand. But the objective is, at the end of the day, to have something that's a bit more easy to read for the infrastructure specialists, because as a developer, you only see the tags that are here. So player viewer, player editor, or player manager, and in between is the deduction of rules. So we're going to go through the simple one. So the player viewer is either directly a player viewer or is somebody computed from a player editor. So a player editor is also a player viewer. So if you give that property to someone else, you'll automatically get assets to player viewers. And now a player editor is either directly a player editor through the use case of a word this. This means directly that, the term player editor, or from the computed user set from player owner. So if you have a property player owner, you're automatically a player editor and automatically a player viewer. And so if you start to build more complex engines, let's say with 3 front ends and hundreds of rules, for us, it's in the order of 50, let's say 50 or 70 keywords on larger platforms. It's way easier to read those terms, understand what those relations mean, and test them, rather than try to build or understand the larger authorization that's come in play. And so I've just put one example of a more interesting use case. So a player manager here is related to a tuple set of, in the namespace of master, and has a relationship player related to, so it's a master-player relationship that makes it a player manager. So basically a master that has the relationship player related to that player, he's that player's manager. And the computed user set also applies to master owner, in order to, the master's owner will also be player's manager. And the big advantage is for that infrastructure developer, because we don't want every developer to be doing this. We want only 2 or 3 of your developers doing this that like doing and working with tuples, but all the other developers benefit from it afterwards. And so here you have your developer specialist that understands the tuples, that defines the rules to be inserted, player grat as player owner grat, master of the white label, with a relationship player with player grat, and the platform with the term white label, with the term active on player grat. So those are more complex rules that were added later, and this is just a subset, and you can check directly at compilation time of the authorization library that player grat and grat is a player viewer of himself. And you can check for you can assert that other things are false as well in order to make sure that your validation makes sense. But that's kind of a big advantage of a methodology. You have some people specializing in authorization, and they manage it for everyone else, and you don't have to manually re-verify a lot of things. It's handled by the infrastructure for the developers. And that's an example of tuple testing, dedicated for those that do this. And here we have an example of the entire flow with a trace that's happening from the large-scale infrastructure that we showed before that goes down to the secondary cluster. So the first query comes, and it takes 40 milliseconds. It spends a bit of time in the first offkeeper that we showed earlier, and then there's evaluation at the offkeeper level in terms of 3 milliseconds. It gets to the get user wallet, which was the first call that we saw earlier, at the proxy level. And from the proxy, it gets to the secondary get player. If you remember earlier, we showed that there's a discrepancy and a change at that layer of the proxy. And from the proxy, it goes to the internal load balancer and the secondary cluster. So we get again into a cluster. And then there's another, the secondary offkeeper. It's a bit faster at evaluation. And then it gets to the final get player wallet within the microservice, the internal microservice. That's the first part of a trace. The second part of a trace is once we get to the get player wallet, it's down to 23 milliseconds. It performs the check get player wallet. That's an internal call for Keto, another internal call. But as you can see, there are two checks. The reason for having two checks is Keto is checking that the player is indeed a viewer and that there's a relationship, a direct relationship compared to the one that is in Keto. So is a player viewer related to player owner? And the second check is yes. And so the chain is valid, and the get balance is performed within the ORM, and the user gets his query back, and the change propagates all the way back to the front end. So it goes back through the entire chain back to the beginning. But one part I didn't talk about is how do you make sure that your authorization are added correctly by your infrastructure related to what your developers are doing. So now we're going to talk rapidly about that part. If we're using Event Store DB, and with Event Store DB, we're monitoring here 3 streams as an example. Player created, player activated, player suspended. We're using event sourcing, so developers feed those streams. And this is a projection in Event Store DB, and it would automatically link it to another projection or another stream called authorization. So for the authorization, the authorization stream is listening to hundreds of internal streams in order to feed the authorization, as we show here. All the platform users or the developers add the different commands. Those commands, such as player created, player activated, player suspended, get into Event Store DB in our case, but you could use Kafka, you could use NATS Jetstream, mostly event buses. And the infrastructure listens to all those streams that are relevant to authorization, and from that, we insert the tuples into the authorization engine, and from there, it inserts it in AlloyDB. For us, that part is just for scalability. We're using large-scale databases in order to have high performance there, because those checks are performed once on every single call. So it has to be performant. And so that's what I was talking about in terms of event sourcing. All our applicative services use streams, and all the events from all the applicative side is pushed into an event sourcing. You could technically do it without it and only push your authorization as an event sourcing part and keep all the rest of your infrastructure normal. But we did the effort of doing event sourcing, so we did it on everything for us, which means that once new events are propagated, we're eventually consistent. The authorization, EH means event handler, pushes the rules for those different situations into the database for Keto. And then VRD authorization is capable of doing the rule expansion and check the same Keto in order to make sure everything is secure. So the advantage is here, once you've put that methodology, by the way, we're not the only ones doing that. A lot of the big organizations are also working with large-scale authorization engine. It's the practical way to solve the big issues related to authorization. The examples we've just shown are just simple examples. It can get a lot more complex. And honestly, after doing that for a while, we wonder how developers manage complex authorization when there's 7 types of user groups, 5 types of privileges, and delegations in between. It's very tough to manage with tuples. So I wonder how developers were doing it correctly, if they could do it correctly back in the day, without even sourcing engines. And so this is just a small example for people to have visibility on an example of stream, such as player-created. The player-created stream here has all the events that are associated. It's basically, for those that have never seen an event store, is just a stream that contains all the events related to that context. And so you can do that for any type that you want, player, and any type of secondary word to qualify what is happening. Usually it's for new objects. Like if somebody's suspended or activated, that's related to the activation if an account is active. So that's why you had those other terms. But you can think about dozens or hundreds of use cases. Do they have a permission to do, let's say, modify their cart, obtain another account, open another account, chat with somebody? You can do anything with the authorization. That's what Google is doing behind the scenes for cloud storage and GCP. They're using huge Zanzibar engines that do billions of queries per second on all the assets to validate systematically. This is the way that we're doing kind of the same thing, but with even sourcing at a smaller grade. But the objective is to be secure by default and by design. With another method, they use tons of other services in order to do that. We're just doing it simpler at a smaller scale. But because we want security and we want speed, we ended up having the same methodology. What are the key takeaways? It's not easy to implement the entire structure. A lot of banks haven't done it. When you look at who has implemented it, mostly a lot of groups are experimenting. I think there are just a few dozen who have completely implemented it in prod, the methodology with authorization at scale like this. But I believe that it's the best way to simplify not only authentication, because a lot of you guys are probably using authentication services. It's becoming fairly standard. The authorization requires a lot, well, in our opinion, a lot better annotations by default. As you saw, the rule expansion that we've shown before, the annotations are heavier. You need the structure of protobufs to directly compile and obtain a functional service that implements it. And we thought that it's not mandatory, but even sourcing makes it implementable. So if you don't have access to a lot of streams coming from your developers out of their usual path, if you're trying to listen to a database, it becomes a lot more complex. You can miss things, whereas if you're using an event store in write-only, you get the advantage of seeing all the event and even correlate for, let's say, activate and then deactivate and then reactivate and then deactivate, be able to exactly follow the flow. If you have event sourcing and you have an event handler that's measuring both streams at the same time, it can have the logic and the timestamps in order to figure it out. Whereas if you do it from a database, discrepancy between the operations might completely make it go disarray. So we thought event sourcing really helps to do authorization in that fashion. And the other big thing is your CDs need to be very powerful in order to manage large fleets of microservices like that. Because if we saw before, we have like 7 types of microservices in our infra. And in order to just generate 1 or 2 services, business services, so you need to have the capability to be very, very efficient in your continuous deployment. We're almost 100% infrastructure as code on that part. So that's how we deploy dozens to hundreds of services now. And finally, if there are other people that are interested in behaving or going in a similar way so our effort doesn't go to waste, we can help. And particularly if you want to customize the Ori stack, we have it implemented for everything from validating tokens to the authorization and OpenID engines with Hydra to Keto for the authorization engine. We use the entire stack, and we heavily collaborate with the Ori group for that part. And again, Pivotal and Pivotal.tech for our libraries. Hope you enjoyed the talk.
Hello. So we actually have a bit of time for questions. So if you have any questions, you can raise your hand, or you can put them on Slido, and I'll read them. I'll just check the website. Any questions? Don't be shy. Oh.
Thanks.
Thanks,
everyone.
Ashley.
Comment je mute?
One, two. Ça marche.
All right. So, welcome to the last scheduled talk of the day. So, Nicolas Grégoire has been auditing web apps for 20 years. He is an official Burp Suite Pro trainer since 2015. There's a training next week. So, he trained thousands of people privately, publicly. Other than that, he runs Agari, a one-man business where he looks for security vulnerabilities for clients and for fun. His public talks covering many subjects like SSRF, XSLT, Burp Suite, and all many subjects have been presented at numerous conferences around the world. We're very happy to have you, Nicolas. So take it away.
Thanks. Hi, it's a pleasure to be here once again. I think that's my third edition. So I did a similar talk 10 years ago, like plenty of tips. So luckily we have a different content for this year. So quickly introducing myself, I'm French. You probably noticed the accent already. I own a company, like a one-guy company, and as said during the introduction, I'm an official Burp Suite training partner, mostly for Europe, but given I love Canada, so if I have customers in Canada, that will be welcome. And I train nearly 100 people a year, so that's a lot of I mean, anyway, you are here for the tips. So what is the plan? First, I have a few tips for core tools, so tools which are here by default. Then I will discuss a few extensions. Then I have a few other subjects, depending on the time left. And after that, we have beers and CTF and enjoying Montreal by itself. So, regarding proxy story, my point is to be as lazy as possible. So if I have to scroll through the results, that's probably useless, and I want to avoid that. And if we look at Burp Suite, the default sorting order in proxy story is the oldest on top. So you are constantly scrolling and scrolling to the newest content. So the solution is super easy. You can simply double-click here, have the newest entries on top, and that's quite comfortable. It also works for Logger. You can apply the same sorting, and Logger++ too. In short, if you are scrolling to see the new results, you probably have to change the sorting criteria. Okay. Second problem in proxy story, you want to map a specific action, like clicking on a button in a mobile app or following a link to a specific set of resources. So what I do, for example, in proxy story, I will tag the topmost entry, then I will do something like I don't know, accessing a website, a complex one like Solar. And here I can easily map. So everything which is higher than the gray line is related to my latest action. And a variant of this strategy is that I will intercept the traffic, access a specific host, switch back to proxy. And here I can colorize directly from this menu. So it's the same outcome, but with a different workflow. And I switch back to proxy story, and I can see the very first request is green. Sorry. Okay, that's some beginner stuff. Let's discuss repeater. So in repeater, on the left, we have the request. On the right, we have the response. And quite often, we are interested in a specific location of the response. So I have an example for that. OK. Scroll to match. OK. This is a web GOT. So that's a vulnerable web app. We can see here. And this parameter is used in a command. And the command is outputted somewhere in the result, in the response. So the less efficient strategy would be to scroll and simply go to the location. Something a little bit better would be to search. You can see at the bottom, I can go directly to this entry. But every time I send a new request, I have to scroll again. So behind the cog, you have this entry. And then the response will be scrolled every time you have a new content. So if I submit my request, I go directly to the location I'm interested in. So I don't need to scroll and I don't need to spend any time looking for the interesting piece of data. What else? Since a few years or months, we can create colors, create groups and put repeater tabs inside groups. So that's very useful. A related feature, which is little known, is the hotkey for search, or search tabs exactly. And I use Ctrl-Shift-S. And we get a list of all tabs, so we can just navigate using the up and down key. And if I type some text like Piper, I see directly and only the relevant entries. So when you have 50 or 80 entries, that's very, very useful. Of course, you need to put correct names, but you probably have to do it anyway. OK, let's discuss intruder. In Burp Suite Pro, and not in the community version, there's some interesting features in intruder. When you are using simple list, as I do here, you have a menu, a drop-down menu with plenty of word lists. And so that's useful by itself. And it's possible to customize the word list. So from the menu bar, I go to Configure Predefined Payload List. And here I can use the built-in. This is the default value, or point to a specific directory. That's what I do here. Here we go. And now I go to the same menu, and I have only my own word list. And if I want my own plus the built-in ones, I can go back to the same menu and click on copy, which should be export or dump. And that will extract the built-in word list directly to my hard drive. So it takes a few seconds. Here we go. And now I have the built-in word list on top, and at the very end, my own word list. Yeah, what else? So this feature, the fact that we can customize the word list and there's a built-in list, that's very nice. Let's say something negative. No. There's placeholders in word list. So let me show you them. If I use fuzzing full, you can see base here. And if we go below, we can see your email here or your server name here. And if you want to fully use a word list, you need, of course, to replace these values with real ones. And there's a few payload processing options relevant to this feature. So on the screenshot, you see the first one will replace base with the base value stored in positions. Domain will use a unique collaborator host name. And for all the other placeholders, you need to customize manually. So here, I will replace file with etc password and your email with my own email address. It's currently a mess, as you can see, and as listed on the previous slide, the syntax, we have curly brackets versus angle brackets, and we have file versus known file. So they have to clean that, but in all cases, we have to manually replace the values. And I think that plenty of bugs were missed just because users were looking for ... file between curly brackets and never finding the real file, of course. Okay, something about Collaborator. So Collaborator is a way to get notifications from the web app. And a very common assumption is that if you want to get a collaborator pingback, you must use the collaborator domain name. And we will simplify. We will consider only the public collaborator server. So is this assumption really true? That's the question. And you can imagine that if the answer would be yes, I would not have this content in my slides. So the answer is no, or it depends. For DNS pingbacks, you must use the collaborator domain name. For HTTP interactions, you can use any domain name as long as it points to the correct IP. I could do it live, but I mean, I did it live 5 minutes ago. I will take a collaborator host name, so that's the public server, and that's my collaborator ID or host name, and it points to several IP addresses, but we will use this one, 44.77, etc. And we will use another domain name resolving to the same IP. So nip.io is a free service, and this is the IP address X encoded, and this is just a random string. I mean, not so random, of course. So we have a domain name. We have a domain name pointing to the collaborator IP address. And my host name is RSN, etc., etc. And it works surprisingly well. Here, I will simply access collaborator via my own domain name and put my collaborator host name directly in the path. It could be in a parameter name, it could be in a parameter value, and as you can see, the interaction is correctly linked to my own instance of Burp Suite. We can see here RSN, this is my collaborator ID. And we can do, I mean, there's plenty of ways. That's another one. Oops, my bad. I use my collaborator ID as the user agent. And once again, the traffic is correctly correlated to my own interactions. And I mean, if the web application firewall is looking for the domain name here, there's no way to find it. Okay, so we have a clean bypass in most situations. Okay, let's discuss extensions. HackVertor is a Swiss knife, like you can do whatever you want. It's XML or similar to XML tags, and you can chain them, so you can apply several transformations on the fly. And that's a basic example. Here we have a string, and we will compress the string, and the resulting binary data will be base64 encoded, and we get something like that. So that's a minimalist example. We can generate fake data, and that's very useful when you have to generate unique values. If you are creating users or, let's say, files via an API, you probably have to provide unique file names or unique usernames. And you can use the fake hacker, fake book, fake company tags in order to generate valid data, but random one. Like in this example, I'm just asking for sentences, and we get a few sentences generated on the fly. We can go to more complex solution. Here, I will encode my email address and put that in a variable called email. And the flag here means the variable is global, so we can reuse it anywhere in Burp, in a different tab, in a different tool. And somewhere else, possibly in Intruder, I will get my variable and maybe iterate on UID, for example. And everything is in a JWT tag, and HackVertor will generate tokens on the fly. So as soon as you have been able to leak the secret key, you can generate tokens on the fly simply using Intruder plus HackVertor. If there's anybody doing HTTP smuggling, you probably know that managing size is a mess, because we have usually two sizes and we need to manage them dynamically. So it's a complex HackVertor setup, but it does exactly that. We have some text here in the middle. And on the line above, we will get the hexadecimal size of the chunk. And here in content length, we will have the size of the size, so the length of the size plus 2, using the arithmetic tag. And I think I have a demonstration. Not sure if you can read anything. Can you read something? Yeah, okay. Because HackVertor, we can't set the font size, so that's a problem. But as you can see here, I have a short string. The size is 8 here, and the content length is 3. But if I add some characters, okay, we can see that now the size is 26, so that's 1 extra character. And the content length is now 4 instead of 3. That looks like nothing, but then you can pay your attention to this section, because maybe you're exploiting a complex bug and you don't want to spend any brain power managing the size manually. And we can go very far, so I will stop giving example. Yeah, that's a specific application where you need to sign the body of the request with the CSRF token, and that could be done on the fly with HackVertor. Okay, and there's much more. We can execute Python code. We can execute system command like cat, whatever. We can access the execution context, so we can have the URL, the value of a specific parameter. I mean, that's, the more time you spend with HiveVector, the more you like it. It's really good. There's a big disadvantage. Using tags will break burp syntax parsing, and that has a few side effects. But yeah, we don't really care. Like, it's not something that will forbid us to use the extension. Okay, Piper, I need to go quite fast. So Piper, the idea is interesting. You can execute anything running on your workstation or laptop directly in burp. So it could be an interpreter like Python. It could be any command line or GUI application you have locally. So I have a few examples. Let's switch to burp. Okay. So on the right, I have the response, which is a big blob of JSON data, and I want to make sense of the data. So in Piper, I will enable the grown entry, and the configuration is very basic. If the body starts with a square or curly bracket, then I pass the response body to grown. And the result appears directly in burp. And that's all we need. Here, I have a new tab here, labeled grown. And if I click there, I see the response body processed by grown. And I have nothing else to do, just define a filter and define which command should be executed. If you prefer, let's say, JQ, we could have exactly the same config for JQ. That was grown. And Ocular. So Ocular is a PDF reader, but we don't really mind, okay? Any PDF reader will work. And we have a similar configuration. If the response starts with a PDF tag, a PDF magic, then we enable a PDF reader in the contextual menu. So here I can go to extension Piper, and given we have the PDF magic, I can directly open the response in a file viewer. So if you are processing a lot of complex files, it's very efficient compared to exporting to file, removing the headers, changing the extension, etc., etc. And last demonstration for Piper. We will compare some entries. So I'm not very happy with the built-in comparer, and I will take three requests. So the three yellow ones here. Right-click, and here the menu will appear only if we have 2 or 3 entries, because MELD can compare 2 or 3 files, and I will compare the requests, and I get directly the files, the traffic saved to disk, and we can see the file names here, temporary file names, and the MELD command line is generated on the fly, then executed. So that's very, very convenient. Okay, Burp Bounty, it's an extension used to write your own scanning check, but I think it will die soon because we have a core feature called bit checks that should be deployed, released in a few weeks. and then you have a scripting language, and you can define your payload here, I mean your attack. Then you define how to identify a vulnerability, and you have some meta information here. And I hope the community will share this kind of recipes like publicly. And you have a link to a video describing the feature in the notes. What else? I need to go very fast. Keyboard shortcuts. There's plenty of keyboard shortcuts. If you want to be very efficient, you need to use a combination of shortcuts. So switching from proxy story to repeater, that's free action. Sending to repeater, we have Control-R. Switching to the repeater tab, that's Control-Shift-R. And emitting the repeater request, that's Control-Space. So if I do it, I pick an entry, and I will use the shortcut, so Control-R, Control-Shift-R, Control-Space, and it takes like 1 or 2 seconds to switch from proxy story to repeater. And you will use muscle memory, so you will not think about the free hotkeys. It's just a complex hotkey bringing you directly to repeater. Poor man automation. That's when you are looking for bugs, like in Bug Bounty, but you are in holidays or you are coming for NorthSec, and you want to look for vulnerabilities anyway. So we need 2 ingredients. We need a live task in burp, and we need a very specific configuration. The live task will monitor proxy story, and every item appearing in the proxy story will be scanned. So in most situations, that's very dangerous. And we will combine that with FUF. And FUF, we will use a specific option. I will show the option, which is -replay-proxy. And all the interesting entries will be relayed through a proxy. So we combine FUF here, looking for status code 200, and every finding will be forwarded to burp. And in burp, we have this configuration. We have a live task monitoring the proxy. Whatever the scope is, whatever the host name is, we will trigger an active scan. So for sure, that's not very advanced, like it's not a real pen test. But if you are in holidays, it's better than nothing. And you could even run FUF on a VPS and forward to burp through a SSH listener. So you have burp locally, and you have FUF on a remote server, and they are talking one to the other. That's quite elegant. Okay, not sure how many time I have left. Something about performances. I have very, very often some feedback about burp being resource intensive. My opinion is very clear. Computers are cheaper than brains. So you can send this slide to your boss or manager. You want a computer which is larger than necessary, and whatever you are doing, like a burp or running VM, etc., that should not be something slowing you down. It's already difficult to find vulnerabilities, so having a decent computer, I think it's a good idea. How to stay up to date? So, of course, this is just a few tricks. Porttrigger has a channel on YouTube. They have very short videos and very long ones. Both are very good. They have a bunch of Twitter accounts. plus all the accounts all of the employees themselves. I have an account, a Twitter account dedicated to Burp. So I have my real account, and this one is exclusively related to Burp tips or links or whatever. And I'm nearly on time. So if you want to access the slides, they are already online. So you can just get them. And what else? If you want some, I mean, if you like what you saw, I will release a workshop for free next month. So next month there's a free online conference called NahamCon, and I will have I'm not sure 60 or 90-minute workshop related to session management, like cookies and JSON tokens, whatever. And so that's a bit later. And I think I'm nearly on time. Thanks for listening. And if you have any questions, they are welcome if we have the time. And I will be at the CTF Friday evening, and with no goal to score or anything. So if you have any questions relating to the challenges and how could we automate them, that would be like a fun subject. Thanks for listening.
We probably have time for one question. Anyone wants to be the one?
Yep. So if you want to take a picture of, yes, thank you. If you want to take a picture of the links, sorry, it's already there. Is that the only question? That's a good question. So.
Okay, then thanks, Nicolas. Very good. I learned a lot. So I'll welcome Nestori Cinema from SecureWorks. SecureWorks is one of our sponsors, and he just wanted to take a little bit of your time to tell us about SecureWorks.
Ouais, pour moi. Oh, je suis encore en ligne. Here we go. Oh, yes. Thanks. Alors, mais... On t'entend toujours. Ouais, voilà. Je vais... Ça marche toujours. Ah, ça y est, ça marche plus.
Super. C'est quoi qu'il y a?
Okay. Can you hear me now? Yes? You can hear me. Okay. So, last talk of the day, very short one, only 5 minutes. So, my name is Dr. Nestor Zurima. Nice to meet you. also known as Dr. Azuredi, and I flew all the way from Finland here yesterday to give you a workshop tomorrow morning 10 o'clock about Azuredi and tokens. So why I'm here? I don't know, to be honest. But it turns out that we have this kind of sponsored talk here, and I was here anyway, so my colleagues from Montreal asked if I can talk about something. So I'm going to talk to you about something, not about SecureWorks, but something else. So how researchers as me, so I'm working as a full-time researcher, so how I as a researcher can actually defend every corner of the cyberspace. So let's start with this pyramid of pain. I think some of you have seen this before, and it tries to describe what is the cost of change to adversaries or threat actors if we change something here. So for instance, there might be a threat actor who has a piece of malware, and you know the hash of that malware. So if you now detect that, and then you, like this hash value here, and then you block that, it's quite easy for threat actor to change that malware a bit so that it will have a different hash, right? So where should we focus then? So instead of this easy to change stuff or something more trickier, and yes, we're going to focus on the tough, which is the top of the pyramid here. So TTP, so tactics, techniques, and procedures. So those are the hardest part for threat actors to change, actually. So even though you change everything below that, these are still going to be valid. So we should focus on those. But those are not easy, right? They are actually quite complicated. So what do? Well, you call the researchers, right? And we come to the help you out. So, yeah. Who of you saw the keynote today? Okay, so that keynote was given by my friend Roberto. And now I'm going to actually show you a couple of slides from a Black Hat Europe talk me and Roberto gave last December. So the talk was about how to prevent golden SAML attacks. So that was pretty much the whole idea there. And here's how we started. So the whole golden SAML attack is based on one technique, which might be called 1649, or steal or forge authentication certificates. So that's the technique they are using. So this is the process how to do that. So you start the attack, you export the token signing certificate, and that's the end of the attack. So as a technique, that would be easy to block, right? But no, it's not that easy. It's not just that, because the adversaries can use a lot of different procedures to get the same end goal, right? Which is to export token signing certificates. And here is actually the whole attack graph, as it turned out. So I've been researching this many years, and I'm good at, attacking micro stuff. And Roberto is very good at detecting stuff. And together we are quite good to mitigate stuff and prevent stuff. So actually in our talk in Black Hat, we were able to block all known attack vectors. So now we are safe, and you are welcome, by the way. So that's what we did. And I'm actually getting close to the end of my talk because this is very short, just a couple of minutes. And I'm between you and the party, so I'm going to be fast. So the key message here is that things are complicated, they are getting more complicated, so you need researchers. And then when they are collaborating, like me from SecureWorks and Roberto from Microsoft, then the magic happens. So you can actually do this kind of stuff. So I found stuff, and then Roberto said, I can detect that, and I was, damn, how about this one? I got you. So that kind of things, when we do things together, we can get it like this. Okay, but before letting you go, so I flew from Finland, and I did a little bit of research, and I learned that you Canadian people also are mad about hockey. Well, so are we. So I know that you guys know that how Finnish national team jersey looks like. So I wanted to make it easier for you to find me. So I'm going to wear this tonight. So if you want to talk about this research or my talk tomorrow, you can just point this guy. Okay, thank you. Have a good night.
Thank you, Nestori. Okay. Thank you, Nestori. Thank you, SecureWorks. You're gonna also give a workshop tomorrow. So if you want to hear more from him, be there tomorrow morning, I think. Right. Yeah. Good. So we're gonna take a short break, and we're gonna be back with a special panel about the history of NorthSec from the founders. There's going to be a lot of fun stories. So yeah. And reminder, there's going to be food. So everyone's going to be fed. There's a party after. There's drinks. And there's going to be a band on that stage I'm standing on right now at 8 p.m. So please come. It'll be a lot of fun.
This. This. All right. Now that Olivier is hidden behind the stage, so this is special. This is for the 10th year anniversary of NorthSec. Olivier Bilodeau, which most of you probably know, he has given a Q&A on red teaming last year without even being the moderator. So he'll be able to entertain you for 1 hour. Please give it up for the president of NorthSec, Olivier Bilodeau.
Thanks. Hey, can we put the photos? All right. Okay, so I have the honor of doing this 10-year anniversary, but it is also a burden. So this is an old scoreboard, I guess. It is also a burden because I'm here to host something that I didn't create, okay? And something that many people contributed to, many people spearheaded, and I know now how much work this represents. So we will basically feature today in a talk show style, laid back, the guests, the creators of NorthSec, and we'll have them, one by one and add to the party. And we will go through 3 eras of NorthSec, okay, by presidencies. I would like to showcase their work, but we will also take questions from the audience if you want. We will be allowed to speak some French, parce que des fois c'est plus drôle en français. So bear with us. We will try to keep it English, for accessibility reasons, because we're an international event. We have people flying over all the place to come here, and we would like to have more and more of that if we want to be the biggest CTF in the world. So we will try to keep as much English as possible, but I want my guests to know that if something is funnier in French, feel free to say so. All right. I will invite up on the stage right now Amandine Gagnon-Hébert, who is our VP Engagement. Amandine, are you here? Simon? You need to find Amandine. They were briefed. They know they should be here, but apparently it didn't work out. So we'll skip her and have Emile first, and then we'll switch back to Amandine. So is Emile in the house? Yeah. Sit right here, man. So Emile is our vice president of the competition, which is our weird way of saying CTF, because CTF translates badly in French. So Emile, how long have you been involved with NorthSec? And what was your path to NorthSec?
Ça marche-tu? OK. Hello. I think the first time I participated at NorthSec was somewhere in 2014, I think. As a participant, I was really bad. And I was very, very bad. And essentially, after like one day of full CTF and trying to find any flags, I think I found like one flag in the rules, and then I decided to get drunk.
In the rules, you found the rules flag.
Yep.
Okay. And this is the path to vice president.
Oui, monsieur.
Interesting. All right. Do you have any specific anecdote you would like to share about the CTF? Like, what's the moment that comes to mind right now for you about the CTF?
I think that my best moment for NorthSec, it's a tribute to Simon, which was the VP CTF before me, is that like, I remember coming in and just like seeing the room and everything happening at NorthSec, and just having Simon in a disguise coming to my table and being like, hey, do you want some bread? And I'm like, what? And like it was kind of a very fun experience to see like that NorthSec was not only just a CTF that you stay behind your computer and do like find the crypto 500 and the whatever. It was more physical. There was things happening, and yeah, it was a full immersive experience.
It was a CTF, but it was also a bakery, is what you're saying.
Yes.
So for those who don't know, we made fresh bread for the year that the theme was Addison Bakery, which is a play on the Ashley Madison leak. That's for Saturday, man. Keep it clean. Interesting because it smelled the bread the whole year, and they were doing it was Pierre David's sourdough, and they were doing this in large bins. It was a bit crazy operation. I have one last question for you, Emile. What are your thoughts, and this is serious, what are your thoughts on elitism versus accessible challenges? Like, how do you see the balance?
It's a good question. I think, elitism is not like a term I like a lot. It's nice to have art challenges. I like to see people having spending a lot of time on difficult challenges and have a good nosebleed on a reverse and everything. I think that's super important. It's part of NorthSec's DNA to have very difficult challenges. But I think accessibility is the path that makes people like me that sucks at CTF be interested and involved and become more part of the community. So we do try to have the more and more challenges that are accessible to more beginner friendly. And I think overall the CTF, we want it to evolve in a way where you could if you're really here for the elite and competition and be super serious, we want it to be we want you to be able to say that you're here for fun and that we're able to give you more hints or coach you a little more about CTFs and everything without really enduring the real competition that's happening behind it.
Interesting, insightful. Thank you. Emile, I will ask you to step aside and we'll have Amandine Gagnon-Hébert who will take your seat. Non, tu t'en vas, bouge d'une place. Like in a talk show, man. Have you ever watched TV? That's how they rotate. During the ad, unfortunately. Hey, Amandine, thank you for being here.
Hey, am I late? Because I know that someone, they run after me, Olivier asked for you on stage, but I'm too busy for being here, so. But
it's
I'm
okay.
Here because,
I'll take 15 minutes of your time, 5-minute talking.
No worries.
So, Amandine, you are our Vice President of Engagement and Outreach.
Am I?
Yes.
Okay.
The question is, how does one go from a PhD in psychology to becoming a full-time pen tester, OSCP certified, all while maintaining clinical practice with youth?
I don't know, man. I don't even know if I sleep. No, I sleep very well. I think that the secret for this is just being a good time manager, and prioritize things that you want to do. For example, NorthSec this year, and the year before. I don't have time to be here, but I'm here anyway, so I missed some shift at the DPG for being here. So, kids are not my priority today, but yeah. So I think just setting priority is my best. I think I have a ADHD too, so I'm just always doing something. And I don't know, I'm passionate about what I do.
But you've been with us for 2 years,
yeah.
Which means that the TDAH.
You don't know psychology, man.
I don't.
ADHD.
ADHD.
Yes.
Sorry. So it's still you're still with us after 2 years. So it means that this community is doing something right for you. Is it?
I don't know. No. No, absolutely. I love being part of the community. I have an extended background in being involved in what I do. And I love genre, j'aime que on peut-tu parler en français un petit peu?
Un petit peu,
Ben
ouais.
oui, hein. Bilingual. Bon. J'aime que l'ouverture de la communauté d'InfoSec, j'aime le fait que je me retrouve avec des gens d'horizons variés et non qui ont été tous... on a des parcours divers comparativement au milieu académique, puis c'est ce que j'apprécie le plus. Je suis rentrée ici, je sais même, j'avais jamais participé avant en tant que participante, avant de devenir responsable. Fait que l'année passée, peut-être que ça paraissait pas, mais je savais absolument pas ce que je faisais. Je disais aux gens quoi faire, alors que j'avais l'air confiante, mais peut-être que j'ai fuck it up, puis...
Il y a une photo de toi très confiante là, dans le slide deck vers la fin. Là,
absolument. Fait que ça a été une découverte extraordinaire. Je rencontre des gens. Je suis sociale à peu près 14 jours par année. Et c'est durant NorthSec. Après ça, je vais dans mon terrier. Mais c'est le moment où je me donne vraiment beaucoup pour rencontrer des gens puis connecter avec nos amis, quoi.
Yes. Hey, merci. Belle réponse. Ouais. Fait que là, maintenant, ma dernière question. Comment on fait pour faire d'autres petites amandines? C'est quoi qu'est-ce que toi, tu conseillerais aux jeunes qui veulent s'impliquer? Genre, quel chemin prendre?
Pour faire des amandines, il faut un DEP en boulangerie.
Pourquoi je suis pas surpris? C'est comme le parcours le plus...
Ouais. Comment faire? Je ne sais pas. Moi, ça va être cheesy ce que je veux dire, mais genre, je recommande pas... Tu sais, parce que j'incarne beaucoup quand je parle la performance, puis les gens sont comme « Oh my God, tu fais beaucoup de choses, puis tu... » Mais pour moi, c'est un équilibre de vie d'être à la fois en infosec et en psychologie parce que je switch de domaine tout le temps et j'ai besoin de me changer l'esprit. Donc, quand je suis ici, je ne pense pas à mes enfants de la DPJ, je ne pense pas à la psychologie clinique et l'inverse est aussi vrai. Quand je suis en psychologie, je ne pense pas à devenir domaine admin. On s'entend? Ce n'est pas... mes priorités sont ailleurs. Il y en a pour qui se reposer, c'est faire du jardinage, c'est jouer aux échecs, c'est faire du vélo. Il y en a pour qui c'est jouer aux jeux vidéo. And all that things are right, you know? Mais pour moi, comme c'est deux carrières que je run en parallèle. Puis c'est ma façon de trouver mon équilibre de vie, là.
All right,
voilà.
c'est bon.
Comment faire pour faire d'autres amandines? Je sais pas. Tu demanderas à mes parents biologiques, là. J'ai aucune idée.
Bien, en fait, j'espère que ton histoire va en inspirer d'autres, puis elles auront leur propre DEP, leur propre chemin, mais je pense que c'est une inspiration pour la future génération.
Puis s'impliquer, honnêtement, je le recommande à tous. Là, je vais avoir un priori pour NorthSec, là, impliquez-vous pour NorthSec, s'il vous plaît. Mais impliquez-vous aussi ailleurs dans la communauté, que vous soyez à Trois-Rivières, que vous soyez n'importe où. Partez des initiatives parce que c'est payant en tabarouette, là. Pour le nombre de connexions que tu te fais, de rencontres que tu peux faire, de capacités que tu peux développer en faisant ça, faire des nouvelles découvertes. Ça demande du temps, on est fatigué, on dort pas, mais c'est très... la reconnaissance est là. Je suis trop fatiguée pour parler en anglais. Je suis désolée à tous ceux qui parlent en anglais.
Ils n'auront pas compris, c'est correct.
Absolument.
Mais merci beaucoup. Je vous inviterai à vous step un side. Merci. Je vais maintenant appeler Sawira. Sawira, can you come up on stage, please? Sawira is a former CTF participant that is now part of the outreach team. Oh, microphone. Someone's sitting on a microphone. Don't we have 4 microphones?
Hello.
Are we missing a microphone?
No, I think so.
Oh, I am? You are sitting on the...
No.
We're out. Ah, yeah. Here we go. All right. Thank you, Sariva. So, yeah, I was saying former CTF participant, now outreach team. So you're a seasoned threat researcher. You presented earlier today, gave workshops in earlier years, and are part of the outreach teams. I found on LinkedIn that you did a bachelor's degree in BC. It's a loaded question. What convinced you to move to Montreal? And how did you discover NorthSec?
What convinced me? Smoked meat.
Smoked meat? Oh, interesting.
Well, it was actually like I got a job opportunity. I could work as a contractor at Google, And so I made the move, and I was like, why not? East Coast, you know, it's just cold, French. What could go wrong? And I'm still here, somehow. Yes.
Well, that's an amazing story. Yeah, we should clap for that. All right. So in 2018, NorthSec had a sudden death. The two first places of the CTF had accumulated the same number of points. So first place and second place were equal. We had to make a decision on who wins. Pierre-Marc Bureau created a reverse engineering challenge at the last minute. And you were on stage with Zach Deveau, who's here, from Goats, facing another team doing live reverse engineering. Like, how can you go through that amount of pressure?
You don't. Yeah, you just don't. I think if Zach was not there, I would probably be more frozen. It was fun. It was weird. I don't think I'll ever do that again. But yeah, it was fun. It was fun to win the point.
You did win, yes. Yeah.
And it was my first CTF, so yeah.
For us organizers, this is a key moment in NorthSec history that we wish we would have filmed. It's like something unbelievable happened. We were wondering what to do. We'd thrown ideas. And at some point, one of the team thought that they got it. But then Pierre-Marc verified and it was not okay, but you guys kept going on and then you got the actual real flag. I was like, oh my God, this is so much pressure and I'm in the audience. So congrats on that. Do you remember any of it or is it just like a blur?
I think it was a Linux Elf file, as RC Folky. Zach had Radari open. I didn't do anything, I just stared.
I might have a side anecdote about
okay,
this.
apparently not through. I blanked out that memory, so yeah.
We did realize afterward, after the sudden death happened and everything, and everybody might remember this for the people that were involved, but we did realize that one of the teams that were involved in the sudden death did not submit the rules flag. And with that flag,
the losing team didn't submit the rules flag. Like, it would have been over before it even started. Amazing. All right, last question for you. Well, actually, you know I'm always doing like double questions or whatnot. But what would you describe as the biggest challenge working on the outreach team?
I guess biggest challenge, maybe seeing a lot more, I don't know, like women type run workshops. I guess I'm really bad at this. Yeah, yeah, I think that's a bit challenging, and it's also I find I don't know if it's only like in Montreal. I find there's not as many women that you see attending workshops, and it's trying to like get them involved in it and just creating a space for that. But to see more women, yeah,
it's difficult.
Yeah.
All right, but good job trying to achieve the difficult. So I realized I miscalculated. We have a chair problem that I'm gonna smoothly handle like this. I'm gonna call on stage Serge Olivier Paquette, who will take my chair. And do we have another microphone? Do we have another microphone? We don't even. Can we get one for the next 15 minutes? But for now, we'll just borrow one from Emile, from the overexposed people. All right.
Thank you.
So Serge, maybe we'll keep it like that. We have another chair, but we'll see.
You want to sit on my lap, Olivier?
Oh yeah, we could do that. Strong enough. So Serge, don't read the questions. So Serge, what were the challenges of your tenure? You delivered 2022 and 2021 as president.
Yes, after a couple of years as logistics. There's one big thing that happened, I don't know if people remember,
when people were coughing and were staying home. That was quite a challenge as a president. Keeping people together, motivating them to come back and spend some time when everyone was in depression, that was something.
Yeah, well, you handled that very well. I'm uncomfortable, sorry.
We're too close.
No, but you handled that very well. But people, yeah, of course, don't want to remember COVID, and I had other questions about it. So, can you tell us something about each panelist here with us? A story or something you've learned from them?
Do you want a demonstration? I don't have my scooter right now.
Emil loves a snowboard, so we're in the team of being on something that glides. And I have no clue about Sawira. I know very little about Sawira, unfortunately. So she doesn't mind the cold of Montreal and loves smoked meat.
All right. Okay, last questions for the bunch. You have a math background. You work in software engineering, data science, machine learning. I was told that you had imposter syndrome on your way to become NorthSec's president. Can you talk about it?
I still do. But I learned to cope with it, and I learned that everybody does also, even those that don't look like they do. And it's something to celebrate. It's something everybody, so the reason they go on stage is because they became the best fucking in the world in their domain. Of course, you don't know as much as them, so it's perfectly fine to not understand what the hell they're talking about. Just listen, grasp what you can, and be the best in your domain at some point in life, and so that's it. And that's what I came to enjoy, that feeling of being surrounded by people that are so much better at me at so many things. And it's just something to celebrate, and then one of the reasons NorthSec is beautiful.
Yeah, good job. All right, so I'll ask everyone to leave the stage, and then we'll go with the next era. We're going from recent years towards oldest years, and I'm taking a lot of time, I realize, so I'll have to pick up the pace. I would like Florencia to come up on stage. Florencia. Hello.
Hello.
So
It's very exposed.
What?
It's weird.
It's
Okay.
weird.
Yeah.
So, I mean, come on, you did stage time before.
Yeah, but not in a chair. I don't know. It's weird. Anyway.
Then, are you the one who organized the panels format?
I never sat in them though. It's
Yeah.
completely different.
So now you
Yeah,
feel
yeah.
like
Now I'm suddenly I'm sorry.
All right, Florencia needs no introduction. She's been running the conference for the last 4 or 5 years and started the year after Pierre David started it. So Pierre David just did like a napkin project, and then Florencia delivered an actual event conference. So you were tasked with this big and vague request of making a generalist cybersecurity event tied to a CTF and making it diverse. So the question is, how did you approach this?
Just trying a lot of things and seeing what sticks. I think the trouble with being a generalist conference is no matter, like you're constantly kind of trying to catch up with yourself. You're like, ooh, we got a lot of applications from people in reversing. Now we got to chase after blue team people. So a lot of that, just a lot of chasing, I guess, running after people that we think are interesting, watching conference talks from other conferences, and doing our best, especially to try to look for diverse speakers, which is not that easy. And then, you just have to hope that they actually will apply when you ask them to.
Great answer. I would like you, we kind of have an opportunity here to describe the call for paper process in a laid-back fashion. We never actually did a blog post about it or whatever, because it's a lot of little things, right? And you ask anyone on the committee how it works, and they will say slightly different things. So I would like to have your view of NorthSec's CFP process. Like, how does it work?
So we have 2, or at times we've had 3 rounds of submissions, and that the reason for the 2 rounds is that we try to get hype when we announce the first round of speakers, and also because we do want to kind of target the later rounds. So as an example, yeah, you know, we get a lot of applicants who are red teamers. Then in the second round, we want to kind of balance that out, and we want to kind of make that all work. But the way it works is we have this open source tool that we use, and people submit their applications, which includes, you know, whatever they want to talk about, the full description, any materials that are related to what they're proposing, and bio, etc. And then we have a committee of, I want to say it's like 6-ish people. It varies from year to year, that will go through and vote on what, you know, how they feel about the proposal. So we do that. It's not fully blinded at this point, but we do not see each other's votes. So everyone votes, and then we afterwards we kind of look at all of how everyone voted, and we discuss the ones that are that have high votes or medium votes, and then debate, and then kind of pick, and then try to make it all work. So we use Trello to kind of arrange it all and see if the total program makes sense. Does that cover it?
That's perfect. I'm gonna clip this and we're gonna put it on our website or YouTube or whatever. It's so much less time than writing a blog post. Great answer. Thank you, Flo. I'll ask you to sit on the side, leave the mic, and we'll call on stage Eric Boivin. Eric Boivin.
Hello.
Scenario lead is the title I think you are attributed.
Yeah, game master, scenario designer, something like that.
So, what is the job of a scenario lead except YAML?
It's mostly YAML, but yes, the job is to take the technical challenges of every challenge designer and then to wrap it up into the entire NorthSec team. Because, you know, this is an event that is, it's not only the CTF, there's the conference, there's all the swag that you see, the t-shirts, the badges. The team is everywhere in NorthSec. So my job is to first come up with an idea, then work with the challenge designers to make up that idea, to create like an entire universe based on their challenges. So it's all about taking their challenges, building a universe around it, and then wrapping it up so that when participants go into the CTF, they can see a real experience. They can see something that is cohesive, that is not just, oh, this is an SQL injection, this is a reverse challenge. It's a world that you're a part of, and you're building a part of that story. So, something like that.
Do people even realize half of that, or?
I would say maybe not. I know there's a lot of people that are very competitive, and all of these messages, they don't care. It's just, this is noise, we don't care, give me the URL and I'll go to it. But when you're building the signature of an image, the team in NorthSec is everything. Like the audio that you hear, the visuals that you see, the t-shirts that volunteers. So in the end, that creates an event that is interesting. So this is why I think, even if the participants don't understand the big picture, they can see all and the color that we're putting into it. And I find that absolutely fascinating.
All right, I'm gonna ask a trick question. Which theme was your favorite so far?
This is, yeah. Each year, they are my babies. Some babies are more troublesome to put into life. Some babies, they do
What do you know about that?
Yeah, some of them are very challenging, but I would say the one I'm the proudest of is NorthSectoria, where we did an entire CTF about medieval cybersecurity. It was so wild. I've never seen, like, cyberpunk is easy. It's part of our culture, us in InfoSec. But medieval cybersecurity, that doesn't exist. So yeah, I would say the opportunity that I have working in that event and creating crazy stuff like that is absolutely amazing. So I thank you all for that.
You just mentioned it, and I have the song in my head.
Yeah, the little whistle and yeah.
All right. About this year's theme, any surprises left or hints?
To be honest, this year's theme was supposed to be last year's theme. So we were not sure last year what we would do with NorthSec. So last year's theme was pretty much built up quickly, so that because we found out that, oh yeah, we can hold an in-person event. So it was really last minute. So what you're seeing this weekend is, put yourself back in May 2022. What was the life that we were seeing as a society coming out of COVID? So this is the kind of ambience I had in mind back then. But now this year, with all that change, all the things that have happened, things like the democratization of AI, that's something big that has happened this year. So you will see little hints about that couldn't have happened last year. So this is why using current events into the theme is something that I absolutely love.
Thank you. No, so no surprise, no hint, no reveal, no like I want insider, juicy. We didn't rehearse this clearly.
No. Juicy.
Leak something, man.
Oh,
peer pressure.
Okay, I will leak.
He will leak.
So you know, there's a lot of iconography that is very weird, very Illuminati, very mystical. Well, keep that in mind. In everything that we've written, in the end, there's this mystical power structure that is controlling everything. Challenge designers might not see it, but you will feel the weirdness. And yeah, I can't wait to talk about you all about what we've created. Challenges this year are especially good, and the integration with the team this year is absolutely great. So it's an honor to showcase that this week.
Excellent. So if you may please step aside. I'm gonna invite Danny to come up on stage. We were speaking about sound and music earlier, and so Danny is a sound designer and DJ for NorthSec, which is something I think we should promote more, our art, the connection we are trying, and we're not good at it, but the connection we're trying to have with art and sound and music. Danny, you did a live DJ live stream on Twitch for NorthSec 2020 at the peak of the pandemic when we were in lockdown. How was this experience? Like from your garage? I remember like drinking in front of my screen with like being on Discord with the other buddies and listening to the music and having fun.
What a weird time that was. And I was just shocked by the amount of fun that I had. Because we had all been in our holes. And then the idea of like, we can't do NorthSec. And I see Flo freaking out and we can't do NorthSec. And then it's like, no, we can pull it off. We can pull it off digitally. But having been here before and seen the vibe in this room when people are doing the CTF, to imagine the CTF without that vibe was heartbreaking. But then to be able to contribute in some way to create some kind of unifying thing where people are listening to the same music and they're kind of sharing that same spot. Honestly, I felt it, and it was a joyful thing to do.
Were you like looking at the chat at the same time?
Absolutely.
Or? Yeah. Okay.
Yeah,
okay.
absolutely.
So in
Looking at the
between
chat.
tracks, adding.
Yes. 100%.
So before doing so and after doing so, you also designed the sound atmosphere.
Yeah.
So I don't recall exactly, but I remember like it started in 2019 because we needed royalty-free music for our pauses and our stream. Yeah. And then the severity high in 2020, we're already planning at a DJ, so I think you did some sound for us. And am I wrong saying the medieval is your stuff? Yeah. So this is your stuff, and we might have a surprise for this year. So what is the process of creating a sound atmosphere?
Well, you get really, really weird prompts, like medieval hold music, or like, you know, you all heard the leak today. The leak was, it's going to feel weird. So, you know, getting a prompt like that is honestly just like the most, like, it's my idea of fun, is being like, okay, we need basically filler music, but, you know, here's a twist or two. And I think it infuses art into the tech vibe that we have here. And honestly, like, you know, you can get hold music royalty free for free on the internet very easily. But you could also, like, if you really need a name tag, you know, you can get paper from the dollar store and write your names on it. But like NorthSec clearly feels the need to have these badges.
The blinking stuff.
Exactly. And so I just feel like that's kind of the spirit of this event, is kind of like, let's go over the top, let's bring it together, let's contribute our own favorite kind of weird. And little hold music is how I get to feel important and sit on this
If
stage.
I may, there's a saying that I really like. Restriction breeds creativity. Is that when you're giving like limits, this is when the mind can go and fly. So this is why working with a set and working with her, like the prompt for this year was so weird, and the delivery was amazing. I can't wait for you all to hear how.
I think it played today. I think it played today.
Oh, yeah, it played.
Yeah.
Eventually
Nice.
it played at some point, yeah.
Yeah, this is for the conference, right? When we have pauses. Did it play today? Do you guys know? Oh, it played in room B today.
Yeah.
So in track B, track 2, room B, we call it many different names. Salle de Bal is the website's name. Yeah, I made some room. I would like to invite the president of that era, or representing that era, Pierre David, on stage. Can someone... Pong un micro.
All right.
Ouais, c'est correct.
I'm going to sit there. You can do like Serge, but I'm getting older, so there's
Nah,
much
I'm
less
not-
material to work with.
Nah, I'm not doing that.
All right.
I'm gonna be right here.
Yeah, you do that.
Don't look.
Don't move.
All right. By the way, I mean, this is very minimalist cue card. So you were president during 2019 and 2020, 10 years.
Yep.
What were the challenges of your presidency?
I don't know. Something that ends with 19.
Oh, another COVID president.
Yeah, I can count. That's a good story. So how this happened, right? So remember, everybody, put yourself back in your shoes. Early March 2020, right? Early March. This is, hearing about things happening in Asia, whatever. It's all like a flu, right? It's all like we've seen that. And so we're having an event on site, in person. Everything is lined up. Everything's going to be awesome. We got badges ordered, like, 1,000 of these, 1,500 of these, like 70 grand, right? All in. And, I'm riding with my company. We actually have an outing. We don't do skiing, in Charlevoix, right? And so we're riding there. And, Mr. François Legault, the Prime Minister of Quebec, announces that, this is on us, right? Things are happening, and so you can't have any gathering indoors more than 250 people, right? Live, when we're freaking riding, on the highway, like on the 20, and then, so we stop at a place, and this is where you gotta make tough decisions, right? Because if you make the wrong decision, you're losing the badges and stuff like that, right? You're losing 70 grand, right? There's a company in China that is supposed to be doing some things for you, and you've already paid some amount of money. And so, we had lunch. I don't even remember what I ate, what happened, where, in what restaurant we had lunch. It had lots of screens. That's all I remember, because like logo was on all these screens. And it was probably in Ashton. No, it wasn't Ashton. They don't have lots of screens, but whatever it is. And so, we had to pull the plug on the badges, that meaning we were pulling the plug on the event, right? Meaning we were pulling the plug on the physical happening of the event, right? March 11th, right? So like 2 days before everything was, like Quebec was canceled. Basically, like the entirety of the province was like indoors, you know, fuck you and that's it. So, yeah, so
this is live stream, by the way.
Yeah, yeah. So, well, it's, you know, there's an LLM on Google stuff that is going to cancel this out. So they're very good. And so, yeah, so I had to call the badge folks and say, well, you know, how much money do we owe this company? All right, let's just cancel all of that. And so pull the plug, pull the badges, and call an emergency meeting while I was in a chalet, you know, in like Baie-Saint-Paul, and call an emergency meeting. And initially, my decision was, you know, as a president, you got to make the responsible choice, right? You got to be the adult in the room, right? We've got crazy ideas, crazy concepts. So you have to make the right choice. And so, as a president, my initial decision was like, oh, we'll just cancel it, right? It'll be easier for everyone. But as a president, you don't, in a volunteer organization, you don't rule by authority, right? That's a trick you learn over time is, you know, none of the people here that are volunteering are paid. You don't have any authority. So you have your idea, but you gotta, you know, have to see, you know, feel the room. The first initial feeling of the room, of the entire organizing committee at that time was, we'll just do it online. We'll just do it online. I was like, all right, let's do it online. You know, let's not cancel it. Let's be the first, you know, March 12th, you know. Let's do it online. And so the entire team switched to put it online. It was crazy, and I had sent countless emails. We received a lot of, I wouldn't call this, you know, not threats, but, you know, people weren't too happy about us. March 12th, remember that, March 12th, shipping it online. You know, people were like, you're making this, you know, what it's not. You know, you're way too intense. It's just a flu. You know, it's gonna, by May, it's all gonna be done, right? It's gonna be done and over with. You know. And so, yeah, you know, hindsight 2020, we still made the right decision. So, but that's the story. So, had to pull the plug on, I don't know, 70, 80 grand. Got a message from Mauser, you know, where we had like, I don't know, 20 grand of stuff ordered there. Are you sure you want to call? You know, it's you know, what's happening? You know, you want to cancel a 20 grand order? What's the problem? You know, in COVID. So yeah, that was quite a story. Sorry, I took a lot of time to.
Yeah, by the way, time's up for you. But
that's it.
This is what people will remember you for.
Yeah.
No. Pierre David is behind many interesting initiatives. But anyway, I didn't have anything prepared, and we're gonna move to the next era, the last era, because food is ready, and it's waiting. So 4 more guests, and then we're good. I'm gonna call up on stage Geneviève La Jeunesse. I see her in the back. So Geneviève is our CFP, on the CFP and has been for a long time. Yeah, a long time. So she's part of the OGs, not OGs, but almost like the earliers of the crew.
More in the stale people in the CFP. No, I don't mean that. I really don't mean that. But I think it's great that we're getting new people in CFP. Yeah.
And you also launched or spearheaded the community room, which we're still unsure about calling community room and villages, but...
Yeah, so about this, I want to say, you know, I'm in the face of it right now, but Martin, right there at the back, right in the alley, hello, dude. You know, it's a common shared vision by a lot of people within the organization committee. It certainly isn't like a one-person thing at all. And, you know, Jean-Philippe, co-VP this year, thank you, because otherwise none of this would be there.
Yeah. Obviously. But so, yeah, I guess we went through the intro. So can you, like, there's this thing, it's a new object, and now we have the opportunity to explain it to everyone, right, with more than a couple of words. How would you talk about the community room? How would you describe it?
So, to any conference you go, you'll get the opportunity to experiment things you've never tried, right? But what we wanted to do was to do a little bit more than this, right? So it's cool, you go to this room and you get to learn soldering if you've never done it or something like this, yay, yay. But it's that yay, it's that moment where you're also learning, what's in your environment. Oh, I have this, there's this makerspace in my community and I could go there. Or someone else is passionate about climate change and now it intersects with InfoSec. And so it's having that space to build those connections and not consider, you're not in a talk, so, nosebleed, brain activity. It's not just about having a break. It's about learning to engage and make this like, you're here, you're passionate about InfoSec, you're passionate about technology. It's a whole of life thing for you. Well, can we enrich that? Can we connect that to other things? And can we connect that to things that are a little bit lateral, right? If people were, in computer science and the very, straightforward thing about it, we would go one way. But being creative helps us in our work. It helps us see things a little bit differently. So you need to kind of enrich that with a bunch of things that may or may not seem like they belong, because this is how you find out where you, as an individual, belong, and also how you can include more people into this. Because otherwise, we'll keep doing things the same way and we'll repeat the same mistakes. So it's kind of meta, like how you learn a thing that isn't what you learn easily helps you learn better things and more things. And that's that space in essence. And also, I really, really, really like puzzles. So, puzzles
So
everywhere. Life is a CTF. Anyway, yeah.
So how would you, I think a CFP is very well formatted and people understand what the contract is. You do a pitch basically and then it's rated and you get accepted. But so the process obviously for a community room needs to be more handled. How let's say someone has an idea and is unsure if it's a good idea or not. What would you recommend them do?
Yeah, so that's a thing we're looking to build, right? The more we do community room, the more people know what it is, and then you're like, okay, I love sailing, and I'd love to explain how this works, and now, this will become more real as years go by. I'd say the number one thing is just throw yourself in the pool. You don't need to be a group of people. You can be one person, two people, and come in with an idea, and we won't, when you submit to the CFP, we judge you, right? We want this to be watertight. We want this to be perfect. For community room, if you're thinking about something that could work or may not, or you would do it, but it's expensive and you don't have the resources to do it, or you would do it, but someone would be far better than you at this, but you just want for it to exist, then, talk to us. And the thing is, CFP is great for talks because a talk, you sit down, you write it out, and you're good. But for these types of things, it can take a longer time, right? You're building this out. Maybe we need to talk in the summer. So what I'd say is, you're all on Discord. I'm Denki with many eyes at the end on Discord. Reach out. Let's just chat. There's if it's a bad idea, I will tell you. I spend my days having bad ideas. I have a lot of experience in them, so don't worry about it. You won't faze me. I have worse ideas than you do, I'm sure. So that's what I would say. So there will be, as every year, there's a CFP period, but don't have this stop you. And if CFP is closed and your idea just came, talk to us. It's, we're in a huge space, and even if we were to go elsewhere, I don't see us going into a smaller thing. I haven't seen NorthSec get smaller at all. So don't be too concerned about that. What I would be concerned about is staying silent, right? If you went to the room today and were like, oh, I wish they had this. Come to us. This is, there's a hacker spirit, break things, void the warranty, do all those things. There's also the maker spirit, get it done, get it done, take it, do it. No one's gonna stop you. Social engineer your way into a better world. No, I'm kidding, but I mean, pick it up for real, because we only have so many hands, and we will truly love your implication into this. Yeah. Oh no, I'm seeing my daughter come in. There's another thing I want to say also. It's not just for what's in front of you. It's also to articulate things. Maybe, I'm grading at the temples. If there's things you used to see in hacker cons and you no longer see, it's culture. We need to keep our culture alive. So bring it. Yep.
That's a great answer. I'm gonna switch question last minute because I was going for the other one, but I'll take this one. As a parent.
Oh no.
See what I'm going? Hello. With a successful professional career, involved in NorthSec at the vice president's level, with limited time, like how do you manage your time? And advice for people who are inspired by this.
Club Mate? No, no. The real answer is like you do something every day. And it's the same for my learning. I have, if it's going to be 15 minutes, I look out my week, I'm like, ugh, this is going to be tough. But you create those habits and you stick to it. There's no, there's no sugarcoating it. There's times in the year where it's like, it is a lot, but it feeds you. And I guarantee you, if you're focusing on the mundane stuff that you feel you have to get done all the time, it just drags you down. But if you focus on the things that feed you and build you up, yeah, they're difficult. But doing the difficult stuff is what makes it worthwhile, right? And if you're a parent, you know it. Like, there's a ton of the difficult stuff. You would never question that it's worthwhile at the end of the day. Hello, kid. I'm not getting woken up at 5 a.m. tomorrow morning. Yay. No, but I mean, like the difficult stuff oftentimes ends up matching up with the stuff that is super worthwhile. And go for it. Like I don't think there's anything exceptional in the things I do other than I'm exceptionally driven to get them done. And it feeds me.
Another great answer. Thank you. So, on va, tu vas déplacer d'une place, and we're going to have our next guest, who needs no introduction, Laurent Desaulniers.
Hi.
Hello. So Laurent Desaulniers is a challenge designer, obviously. A long-time challenge designer. Are you? What's the first year you designed challenges?
Actually the hacker. So before, -1. Yes.
Okay. So you didn't play in any NorthSec. You were already challenge designer.
Correct.
All right. So 11 years challenge designer. How many challenges do you think you have delivered in total, excluding trivias?
Excluding trivias, I figure perhaps, let's say 6 or 7 per year. So I'd say roughly 77.
All right, that's good. At an average of points, let's say at 3 points average, that would be you're like your career, your NorthSec career is like a third of a regular NorthSec.
So the funny thing is, and that's amazing about NorthSec, is the very first year we were very few. There was like Charles Frédéric was doing some, and I was doing some, but individually we did a pretty big part of the CTF because we were like 5. So if one of us messed up, it was 20% of the CTF. No, for real. Nowadays we're like 60. So it's amazing how much this is more reliable, how much we can rely on one another, and that's basically built on this community. So I am very thankful that I am a minute, tiny part of NorthSec now, since that there's so many great challenge designers around.
What are your best stories around challenges? Anything comes up to mind?
There were some amazing challenges. The personal one I had was I had a key grinding challenge, and people brought Dremels and stuff, and there was like flying sparks all over. The security guy was super worried how come people were doing. That was pretty fun. There was a fabled bag of chips, if you recall, that there was a vibrating sack of chips that you had to decode the word around. That was really nice. There were some really cool challenges, but those two come to mind, actually.
I want you to elaborate on your obsession about CAPTCHAs.
All right. So yes, I really, really like CAPTCHAs. I feel they're clever. They're a good way to bring different abstract challenges, and you can talk about crypto, about race conditions, about logic flaws, and nobody really cares about CAPTCHA in real life, but I am an enthusiast, some would say fanatic, and I really like to bring, in 10 years I've done 14 CAPTCHA challenges, so yeah. I really like CAPTCHAs.
That's a hint for preparation if I ever heard one.
The funny thing is, one year I keep repeating that story. The very first year you had to solve 500 CAPTCHA by hand, and the LANETS 4 team did it by hand. Like they solved it. Two people. It took them their whole weekend because if you messed it once, you had to start over, and we gave them a Python programming book as a gift.
That's another one, another great story. How would you describe the approach to designing a great challenge?
So I'm really thinking about this because it's super challenging because when you know the challenge, when you know the solution is obvious. So the rule now that we try is what to do should be very obvious, the how can be very hard. But never in front of a challenge, you should ask yourself, I have no idea what to do. For example, in past years, I had a web app challenge that there was like one function called search. It was the very only input in the page. So anyone trying to hack a web page would say, gee, I have one input. I wonder which one should it be, right? So the idea is for it to make it as simple as possible on the what to do. And on the how, there were people having 0 days in cryptography. Like somehow were very, very difficult. Some challenges were pretty insane.
Thank you. All right, I would like you to step aside for the next, shift left, I guess, from our perspective. I would like to invite David Goulet on the stage. Or as we affectionately call him, Degoulet. So David is part of the infrastructure team now. He's a NorthSec contributor since inception, former VP of the CTF. Yeah, exactly. That's the thing. So before NorthSec, HackUs existed. It's a different beast, but it shared a lot of common values and people. So David was a founder, I think, of the HackUs. Okay, but that's a tangent. My first question, I mean, I didn't do a bio, but I'm sorry. Okay, is it true that you are the one who introduced the scooters?
Yeah, I think at some point I was really sick of walking over and over again, and yeah, we did. I did ask for the small scooters, and actually Kevin, which was with us at that time, went to buy 3 of them, and they were 40-pound maximum scooter. A very small, green, and we still have one working 10 years later.
So why are they necessary? Like for people who don't build NorthSec?
Oh, well, you've seen the size of these rooms. We go over and over again, and we forgot the cutter, we forgot this gizmo, blah, blah, blah. We run wires. Not only that, but in these years, the last couple of years, almost everything is Wi-Fi. But before that, we had to run, hundreds of wires. And so the scooters became, instrumental in our livelihood.
All right, so it's not just to roam around looking cool, right? It's not the hacker movie style longboard shit.
No, not at all, not at all.
Has a practical side to it.
It is a true story.
So can you talk about HackUs? Like, what is it for people who don't know?
So long story short, it was in 2009. A couple of friends of mine, I don't think they're in the room right now, but we went to this contest. It was created by the CRIM, le Centre de Recherche...
La boule de cristal.
Boule de cristal, there you go. Centre de Recherche Informatique de Montréal. And they created this contest, and the entire point of this contest, I think, was to bring people from different universities and college and expose them to cybersecurity. And at the end, there were this bunch of private corporations trying to hire us. And I think that was the whole idea. So we had some fun, but not really. So we ended up talking on the way back because we were studying at Sherbrooke, in the University of Sherbrooke, which is an hour and almost 2 hours from here. And we just like, maybe we could do something better than this. Maybe we could have like more fun, introduce some new concept, existing concept like the Hacker Jeopardy that has been existing in DEF CON for a long time, and CCC. And so we were 3 at that time, and we started discussing. Couple of weeks later, we created Hack Us, which is Hack Us is a very clever thing, Hack Us, get it? Okay. But also Hack Universe of Sherbrooke, so UNS. And we started this, and the first edition was run in 2010 with 67 people, and I was actually in the cafeteria of the university, and actually it was pretty fun.
It was indeed. I remember we were playing with Amish security back then, having lots of fun. So what motivates you to keep giving a considerable amount of time to NorthSec after 11 years plus Hack Us, plus the 1 year off? It means like it's 15 years career contributing, not for as a player, but as a giver, a builder of worlds for others.
I mean, it's pretty fun. A lot of people came before here that says that, they meet people. And it just actually, it's very true. We meet a lot of people. It's extremely fun, the logistics of it. But there's one thing that is very, very cool for me is, and I used to do that, I don't do that anymore, but it was the challenge designer. And through 8 months of work, you do this challenge, it comes through and it becomes a thing that you polish, that you love, that you ate and everything. And then for 2 days, people go at it. And that is the most amazing experience ever, because then you have so much fun looking at people sweating, enjoying. And so that is a big driver for me and for a lot of challenge designers. So I encourage everyone here that wants to do challenge to actually join the team. But apart from that, why am I still doing this and not the challenge? I think it's just fun, yeah. It's fun.
Excellent. So it's time now to bring the last guest, the OG president, Gabriel Tremblay. Come up on stage, please. Qui veut lui donner son micro?
Merci.
All right, Gabriel, you were president. I didn't realize just how long your tenure was before I wrote this.
It's PTSD every time we speak.
You were president from 2013 to 2018. To maintain and create an event like this is a great accomplishment. So, what is NorthSec's original idea?
It's not an idea, but it's cool because David is there. Short story long, which is usually the inverse. For the people who were in there back in the days, we used to love doing cybersecurity, but we felt a bit alone. So we had this competition in Sherbrooke called Hack Us, where we would go, we would compete, and we would really succeed at it, just to say. And then the people that were competing with us, we were building team, and the team that was organizing back then the competition, we decided to get together and build a team to do international CTF, to go and do the DEF CON quals, to go do ICTF, and a lot of us met during these days. But there was, it's funny because we had a good success back then, but we had a problem. We had difficulties recruiting new people because back then the amount of elite level security pen tester was kind of limited, and there was this competition in Sherbrooke that kind of it did its time. It was in Sherbrooke. They had problem financing themselves. Is it? Yeah, it's fine. That's what happened. So we were looking for ways to recruit more people. And we thought like, that would be nice if we built something in Montreal, like just a CTF, just to train people in what we were doing. It's as stupid as that. So we decided to build a competition that would be as hard as the shit we were doing on the international scene, which was like nose-bleeding level back then. So slowly but surely we built that competition that was, I remember one of the first goal we gave ourselves was, you shouldn't be able to do all the flags. Like it should be so hard that if you manage to do a flag or two, you had a good competition. So it was the basic idea because it was out of a need. That was the need. So I went to the old people that were doing Hackos, which stopped back then, and I said, why don't we move it to Montreal? Why don't we rename it? Why don't we rebuild the way it's done? Why don't we just change the way it's financed? And this is how literally NorthSec came to be, as a way to become better at what we were doing.
Yeah, great answer. And so, from there, how did you decide to grow from a CTF to a week-long event spanning training, conference, and CTF, what I call today NorthSec Festival?
So, fun fact, being poor when you make an event sucks. Like, you have to make everything happen. And the first year we had $5K as a budget. That was the budget of the event.
$5K?
Yeah, that was $5,000. But the room was free at ETS, so fair enough. That was solved. So we ran at least, I think, 1 year, and I told to myself and the guys, I said, and it was only guys back then. Sorry about that, we weren't that good. So I said, if we want to grow, we need money. And what's the best way to make money? Let's do a conference. And that was it. That the idea was that the conference probably will be able to fund the CTF. And believe it worked. Like, we recruited Pierre David back then, and we told him, like, you want to make a conference? Because we need money. And he said, like, I can do that. And that's how it came to be. And a couple of years later, we were here now. It was amazing. But we were still really poor. Like, we weren't able to do, like, crazy stuff like you see these days. So we went to see, I think it was you. And we told you, we need money. You want to do trainings? And that's how training came to be, out of necessity. So training were meant to fund the conference, so the conference could fund the competition. Yeah, that worked. But that's pretty much how it came to be. So this is how the event grew, out of necessity to fund the CTF.
So yeah, go ahead, clap, clap, clap. So I have, like, I guess, so we're short on time, it's my fault. But I have two angles here we can take, so you'll pick the one you like. You talked about money already. So I don't know how much you want to talk about budgeting, but I know that we had, in the early days, we had some pretty guerrilla meeting about budget. And it's like, cut this for that, or more of that, less of that. And we were, like, arguing over stuff we cut or not. Do you want to talk about that, or do you want to get into the anecdotes?
No, I'm gonna go about budget.
All right.
No, anecdotes. All right, anecdotes. Anecdotes.
All right. So I have, like, I mean, I have stuff that will just reveal the whole anecdote. You wanna talk about that?
Yes, but don't name anyone.
Go ahead.
All right, so the fun thing is, you look at this event and you look at all the people, they're sitting there, they look responsible because they've aged quite a lot since we've started. But the beginning were kind of rough. Like, think about, like, the people that hangs in CTF, have too much beer, fight in bars, and, like, these peoples. So we're building an event, and I would say, like, because it's kind of going in I don't know, caresser le chat dans le bon sens. But it's brilliant people do shitty shits. Like, this is what they do. So we did the first year of NorthSec, and we get to the hotel first night. We had an epic hacker jeopardy, like a thing that would be illegal today, because that's how things were back then. And not to do any apology, but we didn't know what we were doing, so it ended up in some ways. And then we get a call from the hotel the next morning. Someone stole all our APs.
Wireless access point.
Yeah.
Someone stole all of the wireless antennas in the hotel.
And they're like, we have them on camera. So either they bring them back, or we're gonna call the cops. And we're like, oh, I know who is this. We knew we were there. Like, the night would never end. So these people were, we were part of it. We didn't steal it, but it was the people which we worked with were not. It was not as serious as it is today. So that was a good thing. I think we returned the AP. Nobody got arrested. That was a good thing, I guess.
These are pictures of the first Hacker Jeopardy in ETS. So first Hacker Jeopardy of NorthSec, but we had prior Hacker Jeopardies at Hackos. This initiative was started at Hackos.
We're always on the old pictures because it was like 10 of us. So that's why. You want another one or?
Yeah, sure. Did I throw this away already? Nope. Yeah, that one. I don't know about that one. Tu peux le dire en français, les caisses de 24.
Oh, yes. I think this one is better.
Okay, go ahead. And it's the last one.
Okay. No, I won't go. I will go with budgeting. No, anyways. Ask me a different question.
Oh.
Ask
me.
me.
I threw it on the floor. Oh, I know. I'll do.
Let's go. I could propose one. Which would be a good except for what?
You're going to answer your own question?
Yes.
Okay, go ahead.
As Olivier was about to ask me,
That's great.
we were having this discussion in my head. He said, what's the hardest thing about leaving NorthSec? Because it's going to happen to everyone sitting on that stage at some point. Some people here did. Some people are planning to it. And it's interesting because I had to leave NorthSec at some point. Like somebody mentioned babies at some point. It was edgy. That's cool. But yeah, one of the things I found the hardest thing was to leave NorthSec because it's what I did. And as I remember, you are never as good. In fact, the organization is always as good as you are. So at some point, you become the limitation of the event. So the event you're seeing today couldn't have existed with me. Because I headed up to a point where what I knew as a president, as the guy that ran the show, I sucked with diversity. I wasn't good in many things, so I found people that were better than me to take away. But even today, after I left, 2018, even today, I want to come back. I want to help. And I always tell myself, no, don't. It's like a children. I never had children.
You help at the bar.
Well, I am
you drink.
I'm just a clerk. That's what I do. But yeah, at some point when you create something like NorthSec, if you want it to become as good as that, you need to let it go. You need to let it grow on itself. You need to give it everything it can, but you already gave enough. So thank you for asking, Olivier. So if you ever create something like that, let it go at some point.
It was a great question.
I know, you're so good.
All right, so we're running late. Food is already over there. Martin, do you want to come up and talk about the logistics? So we're gonna turn into party mode. If you have, we cannot summarize 11 years in just 1 hour and 15 minutes. So if you want to talk about what happened, you've seen 12 people, 13 including me tonight. Go and talk to them. They would love to talk about NorthSec and answer your questions. So with that, Martin, talk to us about the party.
All right, bonsoir tout le monde. Moi, je voulais le micro à Gab pour avoir la même voix que lui sur le système de son, mais ça marche pas pareil. Écoutez, on va avoir besoin d'à peu près 40 minutes, peut-être 1 heure pour changer la salle ici. Il faut enlever toutes les chaises, tasser ça sur le côté. Je voulais vous demander votre coup de main, mais j'ai réalisé que toutes les chaises sont taille râpées ensemble, donc il va falloir aller chercher des exactos. Mais ceux qui veulent rester encore 5 minutes pour aider à faire des piles de 5, puis tasser ça sur le côté, je vais aller chercher ce qu'il faut. Allez manger, on a à peu près 1 heure avant qu'il y ait une première partie, un DJ qui va faire une petite montée en puissance. Puis après ça, on va avoir un show, One More Time, vers 20h30, peut-être 20h45, là, dépendamment de comment ça va avec le planning. Fait que le traiteur est arrivé, la nourriture est servie. On veut pas de nourriture dans la salle ici, mais on vous a mis plus de tables cocktails de l'autre côté. Donc, puis une petite nouveauté aussi, il y a un menu de cocktails au bar. Donc, n'hésitez pas à essayer ce qu'on a préparé pour vous. Donc, bonne fin de soirée tout le monde, puis j'ai bien hâte de vous voir au spectacle. Merci.